Thank you. Good morning. Let's talk about layers. My name is Kyle. I work for Yelp. Our mission is to connect people to great local businesses. We make an app and stuff. We also connect great local ambulance drivers to great local hospitals. This is a joke. This is hysterical. Anyway, let's talk about layers real quick. Layers are related. When I think about layers, I think about abstractions. I also think about the separation of concerns principle. They're all kind of the same to me. So to get you all in the mood, I'd like to bring up some inspiring quotes. Dijkstra says that the purpose of our abstractions is so that we be absolutely precise. Maybe. Spolsky says that all abstractions are leaky. That's probably true. David Wheeler says that every abstraction we make will probably create another problem. I think that's absolutely true. But let's think about these in terms of the big picture. In order to get there, before we get there, if you are interested in thinking about this kind of subject, I highly encourage you to watch this talk by Rich Hickey called Simple Made Easy. It's kind of the opposite of what I'm about to show today, so it provides a good counterpoint. If you disagree with what I'm saying, you should watch this one and come up with your own opinions. So layers. The first layer I'd like to talk about has to do with DevOps. Now the reason this is my first example is because it's kind of non-controversial. Since 2009, we kind of agree as an industry that DevOps is kind of a good thing. But DevOps is a reaction. And what's it a reaction to? It's a reaction to kind of traditional thinking. What is that traditional thinking? Well, it's this kind of layered responsibility of the software stack that we deploy. Let's take a look at this real quick. When we think about DevOps, it's a reaction to QA doing its own thing. QA, it's responsible for quality assurance, and release engineering is responsible for making sure the build is green. Operations is responsible for getting the pages, make sure it's healthy and prod. Devs write their code. These layers are built up in such a way that they look really pretty on the graph, don't you think? On the slide, don't you think they look really pretty? Well, so as an audience, whenever you see this really pretty looking graph with all these layers in place, I want you to think to yourself. I even dare say, I want you to say out loud, what if we got rid of some of the layers? Ready? 1, 2, 3. What if we got rid of some of the layers? Yeah, right. So look at this. What if we got rid of some of those? Well, in reality, DevOps is not just a big layer, single responsibility things. It's kind of this mixing of people, and I like how we have this agile team right there. That's some special thing. And then it's people getting these puzzle pieces together. Right. But in practice, it's really just finger pointing. But the thing is, what would happen if we merge those layers together? Well, we get something called DevOps. Maybe some might call it NoOps, but it's where the devs are responsible for all of these things. Devs are responsible for writing their own tests. They're responsible for their own QA. They're even responsible for making sure the build is green. They're responsible for making sure the thing that is deployed and prod and healthy. Heck, maybe they even get the pages. Well, at Yelp we do this, and we generally consider it to be a good thing, and then the industry as a whole, it looks like this is where we're going. So just keep this in mind. It's a metaphor. Of course, these abstraction layers aren't real. They're not code, but it's what happens when you start merging things together. There's no separation concerns here. If you ask the developers, they'll say, yeah, I'm totally concerned with the state of the build. I'm totally concerned with the state of our service and prod, that kind of stuff. What's up with that? Well, we definitely get increased performance for some definition of performance. Deploys are faster, rollbacks are faster, time to recovery, that kind of thing. It is a little harder to hire for. Not all developers are happy about being responsible for their service and prod. There is an overhead to inter-team communication, and you lose a kind of specialization with dedicated ops teams. So there's definitely some trade-offs here. But, as an industry, again, we kind of agree that this is a good thing. Let's try a harder one, so to get you in the mood. More difficult abstractions, we'll talk about file systems. Ooh, look how pretty this is. Look how we have the raw block devices. This is an example of what you might, a typical Linux installation might have a couple layers in its file system stack. You've got the raw block devices on the bottom. Maybe they compose a software RAID, devmd0, and then on top of that you have a volume manager, of course. And if you need encryption, you have to usually put that above on the, whatever it's above the LVM. And then finally you get to actually make an actual file system, and then of course there's files inside that file system. Pretty cool. You guys remember what are you supposed to think when you see these pretty looking layers and separation concerns. Oh, so awesome. What if we got rid of some of the layers, right? Well, what would happen if we got rid of some of the layers? Well, it would look like this. It would look like ZFS. If you haven't heard of ZFS, ZFS is a kind of a very non-traditional file system. It kind of encompasses all these things. It handles the RAID. It handles the pools like LVM does. It handles checksums, encryption. There's lots of good stuff in here, but it's all one big thing. You can't really compose the layers very much. Is this a good thing? Well, if you ask the ZFS developers, what happened to the separation concern principle, man? Well, they definitely don't see any separation concerns here. They're concerned with everything. The ZFS file system is definitely concerned with the state of the raw block devices and all that stuff. What happened here? Is this a good thing? Well, ZFS handles error correction much better than traditional files. And the reason this happens is because ZFS is concerned with the state of the block device and does checksums all the way up to the file. So as a thought experiment, think about if you made a RAID 1 today, two hard drives of a traditional software stack, RAID stack like I was showing just a second ago, and you took one hard drive and you shut down the computer, take one hard drive out, and you go mix up some zeros and ones, and you go plug it back in. What's the software RAID going to do? Your RAID 1. Well, the software RAID isn't responsible for the files, it's just responsible for the zeros and ones on the hard drives. So it might as well be flipping a coin and just picking which hard drive is correct. It can't really know. ZFS knows though. ZFS knows exactly what the checksum of the file system is, so because it's rejected this separation of concerns principle, it can detect corrupt data, whereas traditional software cannot. Deduping is easier because it knows where the files are. Snapshots are quick because it knows not to snapshot a bunch of space that's not occupied by any files. All this tooling that we built up over the time for the other traditional file systems, of course, doesn't work. So, what happened here? We've rejected all this traditional file system layer. We said no to separation concerns, and we said, screw it. We're going to build a file system that is just like monolithic and all-encompassing. I'd like to introduce a new concept, a new term that describes what happens when you do this. I'm going to call it a sympathetic abstraction. I call a sympathetic abstraction, you could call it the opposite of leaky. I would say it's more like it's an intentional leakiness to abstractions. It comes from the mechanical sympathy blog, which is a favorite of mine. But it's the idea that our layers are sympathetic to the layers above and below. ZFS is sympathetic to the fact that it's running on spinning Rust or SSDs, and sympathetic to the fact that corruption can happen down there. Whereas the traditional file system stack, XT4 is not sympathetic to the fact that things can get corrupt, and it says, that's not my problem, that's a problem for the layer below. So a sympathetic abstraction. Keep that in mind as we go through some more examples. You use sympathetic abstractions all the time. Every time you SSH is setting TCP no delay, it's disabling Nagel's algorithm on your interactive sessions. What's up with that? Why is SSH concerned with its transport? I should be able to run SSH on UDP tunneled DNS requests. It shouldn't care about TCP, but it does. It does to give you a better user experience. Cassandra is concerned with whether your block devices are SSDs or spinning Rust. Why is it concerned? Isn't that the job of the file system below, to abstract away the fact that you're running on USB sticks? It is concerned, so it's a little sympathetic to what you're running on. So some more examples. I'm going to also introduce my abstraction law or observation. It's, I'm just some person who just thinks about this stuff. It's not, don't take it for canon. But I do think that over time, the layers that we build as an industry do tend to become more sympathetic in the pursuit of performance, for some definition of performance. We start off with these really beautiful layers that are like single responsibility. Think of software RAID. And then over time, we say, well, maybe it's a little messier than that. Well, and then we just squash some layers together. Let's talk about the bread and butter of, at least my job, HTTPS, serving web pages. And let's think about it in terms of this layer kind of stuff. In order to talk about that, I have to talk about the OSI layer model. Can I have a quick show of hands of who's like studied this or knows what this model is? Oh, great. Wow, that's impressive. Most people in the room raised their hand. That's really great. I learned about this in school. If you're not familiar, the OSI layer model is old. It's ISO 78498. It's really old. For 178 Swiss francs, you can just buy it. it comes in 7 layers. I learned about this, like I said, in school in my CCNA class. And when I heard about it, my mind was just blown away. I was like, wow, what a great way to think about how we build our networks. Physical is layer 1, the data link is layer 2, network is layer 3, blah, blah, blah. And I was just enamored at how great this was, how strongly separated our concerns were, and how great this was of a tool to troubleshoot issues, and how it empowered interoperability between our networks. Didn't matter if you were running a token ring network that was talking over, going up the stack to a router that talks TCP over to, a 10-base-T Ethernet switch. Worked great. So let's talk about HTTPS in terms of the OSI layer model. Layer 1, if you're on a laptop like I am right now, you're talking over Wi-Fi, which is layer 1, but it's also layer 2 for some reason. Layer 3 is the IP protocol, God bless America, that's where it should be. And then transport is TCP, that's the traditional HTTP, yeah. And then layer 5 session, HTTP is stateless. The Wikipedia said that HTTP is stateless. So there's nothing on layer 5. And then SSL is at layer 6 because there's no other layer to put it. And then, of course, layer 7 is HTTP. I hope you all are thinking the same thing I'm thinking. This looks a little weird, and I didn't really question my CCNA teacher when he presented this. I was like, is this really how it's supposed to work? Well, it doesn't quite work this way because it's intentionally not supposed to fit. The IETF is not concerned with strict layering, and it's not intended to be OSI compliant, and heck, there's a special section, layer considered harmful, and when I read about this, I was a little disillusioned. I was like, oh, maybe it's not as cool as I thought it was. In fact, there are many competing standards, and there isn't just one OSI, there isn't just one layer model, there's a bunch of them out there. Some have 4 layers, some have 7, some have whatever. So it's kind of a map and territory mismatch. I thought that this was like the territory, but really it's just one of the maps. Well, I hope you're all thinking what I'm thinking. What if we got rid of some of the layers? What would it look like if we started smishing all these layers together? Would things be better? Well, we have. It's called QUIC. If you haven't heard of this, QUIC is a protocol made by Google that smushes all these layers together. Forget layers 1 and 2. Wi-Fi just consumes both. It's definitely concerned with both. IP protocol is still there. Good. Layer 4 is replaced with UDP instead of TCP, and the only reason that Google did that is because that's the most minimal protocol you can get away with and still get your packets transferred over the internet. And then QUIC takes care of everything else. It takes care of multiplexing, the actual HTTP stuff, the error correction. Again, like error correction, that's the responsibility of the layers below. Session management. Heck, it doesn't even care what IP address you come from. If it could, it would probably get rid of layer 3 and 4 if it worked, because it's got its own session token. You can roam, you can change from mobile to Wi-Fi. It doesn't even care. Is this a good thing? Is merging these layers in QUIC really a good thing? It's definitely not concerned about. There's no separation concerns here. If you ask the QUIC developers, hey, what happened to the separation of concerns principle, man? Well, they would say, we're not concerned with the separation of concerns principle. We want to, we're after performance. And performance they got. So, as much as you may rail against this idea that we are merging all of these layers together for worse, you can't argue with the numbers. It does give you really good performance, especially with loss recovery and 0 round-trip recovery when you roam. It does come at some drawbacks, though. You can't just run TCP dump like you used to and be able to inspect, headers and stuff. So far, only Google and Cloudflare are brave enough to try this out. Only supported in Chrome. You have to have faith that QUIC crypto is like solid. When you merge the layers together, now you can't just replace OpenSSL with LibreSSL. You have to have faith that QUIC crypto is legit. Well, I'll leave it up to you to decide whether the trade-offs are worth it, but it's hard to argue with the facts. If you're watching this on YouTube right now, you're using QUIC. If you're almost certainly using QUIC on your phone when you check Gmail and stuff. So it's out there, and it is working, and it is pretty good as far as performance is concerned. All right, we're getting this somewhere, I promise. Microservices, check this out. Typical Rails app. Let's take Twitter as an example. If you're going to build Twitter and you're going to get started, you might start off with a Rails app. Model view controller is a very standard way of layering your code into different responsibilities, and of course, MySQL database for good measure. Looks pretty great. Look how clean that architecture diagram is. Are we all thinking what I'm thinking? No, you're thinking the wrong thing. What if we added more layers, right? Well, if you added more layers to this, you'd achieve what Twitter has today, which is a service-oriented architecture. You split out all these things. Now you have like these silos of different code. Well, what's going on here? You might think to yourself, Kyle, I thought we were about merging layers together. We're separating these things out for some reason. And as a result, things start talking to each other and they start mixing and matching. And before you know it, you have this Death Star call graph and everything's really complicated. Well, rules are meant to be broken. Sometimes it's important to split out things for a different type of performance. In this case, we need to be able to scale things independently, and we need to scale out our development to many engineers. But it does come at a cost. When you have a service-oriented architecture like this, it's not as easy to just deploy something and just restart your Rails app. You have to interface with the ads team, the search team, your tweets team. Now you have these APIs that you have to upgrade and make sure they're not backwards compatible. Whereas before in a Rails app, you could just make your code change and redeploy, and that's kind of it. So keep this counterexample in mind as we move towards Kubernetes. We're at Kubernetes. Well, in order to really think about Kubernetes in terms of this, of the layers we're building, we have to compare it to the traditional way of deploying things. And when I say traditional, I really mean the type of deployment you might use on a cloud before we had Kubernetes. Before, you would build an AMI. You would build an AMI for your application. And that AMI, on Amazon, I'm using Amazon Linux terms, Amazon Web Service terms, but that AMI would be an image that contained your operating system and your application code as one big blob. And when you deployed it, you would be deploying it on these kind of layers. There would be the infrastructure, actual physical machine, the metal. You don't get to control that, that's Amazon. And then you're launched as a VM, so they use virtualization, Zen, and you get launched on that. And then your operating system, you get to pick, Ubuntu, whatever. And then your application code lives inside, and that might be a Java jar or whatever, Tomcat. So this is a very typical, if you rewinded 10 years ago and you were like, how do I deploy something on AWS? Well, you would make a machine image with this kind of stuff. Not that many layers. Performance is good because it just ran on the VM. I don't know, pretty easy to understand. That's right. What if we added a bunch more layers to this? We're engineers and we just love, making things more complex, right? Is that why we're doing it? Well, let's talk about Kubernetes. Well, in the Kubernetes land, you would have a lot of the same layers. If you're going to deploy on Amazon, you'd have bare metal, you'd run on a VM, you'd have an operating system, fine, and then you're going to be running Kubernetes inside. The kubelet is going to do, whatever, launching stuff. And then you have this pod construct, okay, and then inside the pod is multiple containers, and inside of those containers is finally your process, the jar. It's a lot of layers. What's going on here? Are we implementing, we're just architecture astronauts? We want to build all these primitives, and we want good separation of concerns, and we're like, oh yeah, the application should be there, and whatever. I'd like to say that it's not necessarily the case that this is so bad, and as an industry, it's hard to say no to the momentum that Kubernetes has. Maybe they're onto something, or maybe we're just making layers for layers' sake. What happened to the good old days when we just launched a jar? What if we got rid of some of the layers? A little bit of heresy, Before we talk about that, let's talk about the metal. In the old days, the reason that we had many different instance types in Amazon and any other cloud provider is to make it easy for us to shrink how much compute you needed for your application. When your deployment is the AMI, that means that the containment, the level of containment is the Amazon machine image and the instance type. And if you only need 4 CPUs for your application, you launch a VM with only 4 instances. But in the Kubernetes world, our containerizer is Docker or some sort of other containerizer, and it's not the VM. So you can set arbitrary CPUs, and you don't need the type of containment that a VM provides where you have smaller CPUs. So you don't need that segregation. So maybe, as we progress towards the future, we'll see more trend towards bare metal instances, because we can shrink how many CPUs you get for your application in Kubernetes land, and you don't have to do that at the entire VM. So I think the future is merging layers 1 and 2. I think it's just not running virtualization at all. I think we don't need it anymore. So let's merge layers 0 and 1, where you're just running metal. What would the top look like if we merged all those layers together? Well, if you've heard of unikernels, you might have been able to predict where I was going with this. Is the future unikernels? Well, it's definitely what happens when you merge all the layers together. If you're not familiar, a unikernel is where you have a single boot process that contains all your stuff. Think of it as like maybe like a jar plus the JVM contained, but it can be in any language. There isn't really an operating system. It's really your own, all your own code. There's no like kernel threads versus user threads. It's just all you. That's all you get. It's a pretty interesting idea. I don't think it's the future. The reason I don't think it's the future is because, well, I'll explain later why I think the benefits of having containers empower more things than this. But it's definitely what happens when you merge all the layers together. Now remember, back in the Rails app example, having all the layers merged in one monolithic code base maybe wasn't such a great idea because you want to be able to do other things by taking other things apart. But like the quick example, maybe you get really good benefits by merging all those things together into one single monolithic sympathetic layer. In this case, we're not getting a lot of the benefits that we got out of having containers, because when we have containers, our deployments are fast, really easy to iterate on, and unikernels don't quite have the tooling necessary to be able to do that, especially when you're considering that it consumes the entire image, so you can't just SSH to it. So maybe this isn't quite the right layer to iterate on when you're concerned with application development. Well, if it isn't, what is? Well, let's talk about AWS Lambda. I'm going to say the word serverless, but that's the last time I'll say the word serverless. I'm going to say the word functions as a service. This looks really similar to what we had before. Sure, we have metal or VM, whatever, and yes, we have the substrate, which is the operating system and the orchestration services, the thing that's slurping the logs and collecting metrics and stuff. One layer up, you have your containerizer. In AWS Lambda, that would be Firecracker, and Kubernetes, that would just be Docker or whatever, Docker plus Kubernetes and the functions as service code, and then you have your process up top. This looks pretty good. One of the nice things about this is that by slicing up these layers, now developers only have to worry about that top one. Developers don't have to worry about all the ones below. So unlike the unikernel example where you had to be concerned with all of that stuff, by separating our concerns, you're allowing developers to focus on only their process and not all of the other substrate. Cool. But aren't we back to where we started? It's the same thing. We're just running Kubernetes and we have all these layers and we have the thing. Where is the mechanical sympathy? Where is the merging of layers? Where's the performance coming from? In fact, what happened to that layer smashing vigor, Kyle? Were you so excited about smashing layers together and now we're splitting them all out again? I thought you'd be like all pro unikernels, yeah? Let me give you 3 reasons why I think that, given all of the layer abstraction stuff that I talked about, that the functions as a service or Kubernetes-based architecture really is going to be beneficial for us as an industry, even though we're not smashing the layers that you think we're smashing. Maybe we're smashing layers at a different layer. Like I said, by separating out that top layer, developers no longer are concerned with everything below. Good. This is unlike traditional deployments in Amazon where you're concerned about the AMI. AMIs are slow to bake. You have to SSH to them to troubleshoot them. They contain the entire image, so you have to use another thing to shrink how much CPU you have, the instance type. And by now, the Docker tooling is pretty legit. and just containerization in general, we've kind of established as an industry is the way of the future. It's efficient, it's easy to iterate on, and that's good stuff. So this layer is probably going to stay. The second reason that I think that the Kubernetes layering stuff is going to be working out for us is because with functions as a service, we're merging a different set of layers. That set of layer is the layers between routing and compute dispatch. So in the traditional model, the autoscaling group in Amazon would be responsible for running n copies of your service. And then you have a different thing, Elastic Load Balancer, that's responsible for writing requests to those things. Yeah, it's pretty standard stuff. In the new world, they're the same. Sure, you have the Kubernetes cluster, but we've merged these layers at the top. The functions as a service controller and the API gateway is routing requests, but it's also doing the compute dispatch. So now you can do things like scaling down to 0. You can also do things like personal canaries. All these things are possible, but very difficult in the old world because these layers are sympathetic to each other. They know how many simultaneous requests your process can handle. It's sympathetic to the fact that you're running Java versus Go. When new requests come in and needs to scale up, it'll just launch more. In the old world, you had a control loop that was looking at the CPU usage of your Apache and scaling up or down according to that. But in the new world, because the layers are together, if more requests come in, it'll just launch more instances. It's so simple. That simplicity comes because we've merged layers together. So don't be too scared of the fact that we've added layers and complexity into our orchestration system, Kubernetes, pods, whatever. I'm hopeful because we're merging these layers together that will have dramatically increased performance and new capabilities that we didn't have before when they were separated before. Think about it this way. If you went to Amazon's Elastic Load Balancer product manager and said to them, hey, we want the load balancer to be aware of the fact that we're running a Rails app and that we can only handle X requests per second. And they'll say something like, well, the load balancer is a general product that's got an API, it's designed to load balance anything, and blah, 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 blah. And the thing is, that's a way of saying separation concerns. The Elastic Load Balancer is a single responsibility. It's only designed to load balance, and depending on how you set it up, it'll do round robin maybe, and it has some least connections and stuff, but it really doesn't care that your service is now overloaded with requests and stuff. Heck, what happens when your Apache servers get tied up because the MySQL server goes slow? And maybe the MySQL server is tying up all the connections. Your Apache servers, their CPU drops because they're not doing any work anymore because they're waiting on the database. And your autoscaling group scales down. What's up with that? No, it should be scaling up because we need more connections or whatever. Or maybe the MySQL database should be scaling up. But the Elastic Load Balancer doesn't care. It doesn't know about that, and the autoscaling group certainly doesn't. And that mismatch is a problem. Let's talk about the third reason that I think that the Kubernetes layers model is compelling, and that is because we're merging yet another layer, and that's the compute scheduling layer. And it's becoming much more sympathetic. I kind of hinted at this before in the traditional model. The autoscaling group in Amazon is a way of having n copies of something. And if you try to run MySQL in an autoscaling group, it would work. But the autoscaling group, separation concerns, man, it's only responsible for keeping n copies up. It could care less about your MySQL topology. When a new MySQL server is added to the autoscaling group, you're responsible for making the tooling to make sure that it connects to the other SQL cluster and it starts replicating and doesn't add itself to the load balancer until it's caught up, all this stuff. I mean, it's certainly possible, but why is it so hard? Well, in the new world, with Kubernetes, we have these things called operators. And the operators say to themselves, well, I'm absolutely concerned with the health of my MySQL cluster. Unlike the autoscaling group, that's not my problem, the Kubernetes operator is absolutely concerned with the health of my SQL cluster, adding it to the cluster, making sure that the replication is set up, etc. So you might say it's sympathetic to your workload. It takes advantage of the fact that in Kubernetes it's really easy to launch things arbitrarily. It's got control over the deployment. It can launch new pods, it can move them around, it can do whatever it needs to do, but it's also application aware. It's application specific. There are a number of operators out there, but the thing is they're not exactly production ready. There's a few production ready ones, but this is kind of new territory. As an industry, we haven't really had a layer where we could add this application specific know-how anywhere. You know, like I said, autoscaling groups, they didn't really know about your application. You really didn't have a place to stick them. You had lifecycle hooks, but it's really not the same. For the first time in our industry, we have a place where we can have a really tight application sympathetic control loop. All of these, of course, are application specific. They know how to configure the application, scale it, and handle it when it's unhealthy. What layer was this replacing? What layer is this replacing? Well, it's replacing the human layer sometimes. It's also replacing a lot of bespoke automation that I can't really picture on the slide deck. So, sympathetic layers, are they a good thing? I'm a fan. As we saw in a couple examples like Quick and ZFS, having the layers smushed together and sympathetic about the implementation details above and below leads to higher performance. It does come at a cost, but I think the cost is justified. But also, sometimes splitting things out into separate layers does allow you to achieve new capabilities that you didn't have before. Launching Docker containers on Kubernetes is much faster than launching AMIs on an autoscaling group. And the only reason that's possible is because we've separated out your code from the rest of the stuff. So sometimes layers are good, sometimes they're not good. But good for who? It's up to us as engineers to really decide and have the imagination to be able to say, what would happen if we merge these layers together? Would it be better? Would it be worse? So that's why I'm trying to get you to think like that. My second conclusion is that Kubernetes operators and functions as a service are reslicing where the layers are and re-merging some layers and taking apart some others for greater good. I think that being able to merge dispatch and routing together is a good thing. Sure, you're not going to be able to use a traditional load balancer to be able to do things. You're not going to be able to use just HA proxy for stuff. But when you kind of give up on the kind of like do one thing well, single responsibility stuff, you do get some really good new capabilities at the cost of some lock-in. Again, this happens because we've merged together the dispatch and compute dispatch and the routing layers together, and now you get some really good stuff. Third conclusion, you should just watch Simple Made Easy. It's just a great talk by Rich Hickey, and it before you let me convince you of otherwise, you should just watch the talk and come to your own conclusions about when it's appropriate to complect things together or split them apart. Hold for shameless applause. Thank you. And also questions, there's a microphone, and I'll repeat the question if necessary.
Yeah, so we have a mic for questions here. So, who has a question?
Try to convince me that separation concerns, oh look, that didn't make it on the slide, is really a good thing. You know, it's something we learn in school or we learn in CS degrees, and we think that it's a good thing, sometimes it's not.
I have a question about, so Kubernetes, like you say, has a lot of momentum, and it's hard not to sound heretical to question it. But I'm in a situation where, you know, we designed our system from the beginning to be deployed and use Kubernetes, but 6 months later, it's kind of the same system. We haven't really utilized any of the auto-scaling features of Kubernetes, and we're beginning to kind of chafe against all these layers that we have to use to deploy a simple jar, kind of like you said.
Yeah. So
is the fault in the fact that we're not using some kind of simplified model of deployment, or is there like an easy mode, or should we not be using Kubernetes at this point in our product life, company life cycle?
That's a great question. I do think that Kubernetes is not the answer for everything. Sometimes all you really need is an AMI launching your application. But sure, you may not be using autoscaling, but you're probably already benefiting from the first benefit, which is this, faster deployments. Being able to use Docker containers, being able to run your Docker container locally, being able to quickly update your Docker container in the registry, being able to restart the application quickly, if you use your imagination, imagine what it would be like in the alternative world where you baked an AMI maybe, or you did it in some sort of bespoke deployment mechanism. It's going to be tough to beat the kind of declarative deployment methodology that Kubernetes provides. But I'll definitely have to leave it up to you to understand that in terms of your organization and your who's working on Kubernetes to really make the engineering call about whether that's appropriate. But I dare say it probably is just for this first benefit. So even if you're not using any fancy functions as a service or any auto-scaling, just having Docker containers at first is really great. But also for the auto-scaling, or sorry, the metal application aspect. So being able to have a pool of compute instead of using T2 micros for your application can save in a lot of monetary cost. Again, you'd have to do the exercise and figure out whether it's cheaper to run a Kubernetes pool with larger instances that are shared compared to running an auto-scaling group of smaller instances and eating the overhead of having just lots of servers. So that's another kind of like unspoken benefit of using a container system. So I hope that answers your question in the best way I can.
Considering this is DevOps days, and there is still a separation of concern between dev and ops.
Mm-hmm.
Having built and played with Kubernetes for the past year on the operational side, where do I get the developers' concerns of using Kubernetes and building cloud-native apps in my organization? They still don't care, except for satisfying our desire of cramming their existing stuff into a container, and then throwing it over the wall and saying, "Hey, it runs in Kubernetes now! Yay!"
That's a tough one. That's one of the artifacts of using this as a metaphor for the layer smashing, because of course it's people, not software. Developers, I think the key way to get developers on board with a different kind of system is to appeal to the development experience. If you can make it so that it's easier to develop on a Kubernetes platform than it is on a traditional platform, I think you will win. Docker helps a lot with this, I think. But if your previous deployment mechanism was really streamlined, maybe it doesn't. Maybe it just gets in the way. I don't have a super great answer. You may have to drag them kicking and screaming, but the way that we do this at Yelp is by making sure that we think developer experience first, and we make sure that whatever we're building next or building on top or building in addition to is certainly not worse and hopefully better than before. So some examples in Kubernetes, you get the ability to do maybe red-green deployments or fast rollbacks. That might be difficult to do in a traditional deployment system. So by emphasizing the cool stuff, emphasizing the benefits, and taking the time to be conscientious and making sure that whatever you're building isn't unnecessarily painful compared to the old way, I think are good ways to make sure that you can get developers on board. But the same types of trade-offs need to be considered when moving to Kubernetes. The complexity that I kind of showed with all those layers does come out at a cost. I think it's worth it, but only because I have a team to help me wrangle that complexity. That not every org has that. I am a big fan of infrastructure teams.
When looking at the constellation of deployments, you've only touched on AWS, but do you see this being flexible enough to deploy out to the leaf nodes, Kubernetes on the kiosk, and things of that sort?
I'm sorry, I don't really understand the question. When you said it deploy on the weak nodes, what do you mean?
This framework is, you're looking at the deployable in a data center context. Do you think it extends so that you can have Kubernetes managed objects out at the edge of the constellation of deployables so that you could manage, say, Kubernetes on an IoT device?
I don't know. I haven't thought about this subject. I think Kubernetes it's going to be a long time before we have Kubernetes managing things that are outside the Kubernetes cluster.
I mean, having Project Atomic on a Raspberry Pi is not unusual, not unknown.
Okay.
But it then becomes a management issue. How do you handle what's deployed out to that? Is it possible to include those in this kind of a framework?
I'm not really sure. I really haven't thought about this subject. Most of my experience focuses around making sure that we keep things that are kind of under our control inside of our own deployment environment. I haven't really thought about managing devices that are like at the edge or outside of IoT devices or anything like that. So sorry, I don't really have an opinion.
You sounded less enthusiastic about the unikernel. I thought your theme was more towards bundle everything, don't have any separation. So whatever things you need, package everything together so that it can run anywhere. Just have an IaaS type solution and then put your package on. So why do you think there was less emphasis on unikernel? Why don't we put everything together?
Why do I think that unikernels are, why is there less emphasis, why are unikernels not the bee's knees? Yeah. My best guess is that it's too far out. It's too much of a radical shift from traditional development. I think it also makes it more difficult to, I think unikernels are so far removed from our traditional workloads that they're, debugging them and, being able to understand what they're doing is much more harder. They're so different than all the other computers that we've worked with, OS threads and kernel threads and drivers. They're just, the difference is a big barrier to learning. In some sense, Docker containers have replaced unikernels because from a developer standpoint, your Docker container kind of is a unikernel because it doesn't run its own kernel. It doesn't run its own operating system. It just runs your process. Kind of analogous to what unikernel does, but in a less CS clean way. So I think the reason this happened was because Docker got there first, in a sense. First in terms of developer workflow and the ability to actually run your stuff and debug it. I also think that there's a lot of room for improving at the infrastructure level. So look at this layer. What would happen if you want to improve, or an infrastructure team wants to increase performance of the routing tier? How would they do that? Well, they would have to, they have to redeploy their thing to make that work, or they have to tweak the routing algorithm because it's all inside of the unikernel. But when you have this, infrastructure teams can iterate on the green. They can improve the performance of the surface mesh. They can adjust how metrics are collected, and all these kind of benefits where that's much harder to do here. So that's why not only am I a fan of infrastructure teams, but I'm also a fan of adding business value at the green layer too. And the green layer can only be iterated upon quickly when it's not mixed in with the top. The same mixing happens with AMIs as well. AMIs are a monolithic blob, and if you want to make an improvement to the routing layer or the metrics collection or logging, slurping, or any other thing there, you have to redeploy the application. I don't really like that, so that's why I like this instead. Those are two reasons why I think unikernels haven't really taken off. Prove me wrong, though. Let's see.
Hi, thank you for the talk. So, for context, I work for an autonomous vehicle company, and so I'm wondering how this thinking could perhaps change when you are resource limited on the node, right? I think this changes because the cost of adding new layers can be much more prevalent in that scenario.
Can you repeat the question? What's the actual?
I'm wondering if this type of thinking scales to when your nodes are say smaller in compute, and it's not as easy to dynamically scale your capacity.
Gotcha.
Per node, or maybe to offload some of that work, right? It needs to happen and in that location. So edge, thinking along the lines of edge computing.
Gotcha. I agree. This type of thinking works best in a place where you have plenty of compute on the node. Heck, have you seen these metal things? The instance types they're insane. I mean, 96 CPUs, 448 CPUs. Goodness gracious. Obviously, that's an outlier. But yeah, these are big servers in the data center, and yes, Kubernetes is a tool for slicing and dicing up these big servers. Yeah, I don't think adding layers at the edge where you're performance constrained. Remember, just like in Quick or ZFS, in search of performance, you're merging layers together. And the performance here is defined in terms of like making the most of the CPUs that you have on your edge node. So my best guess there is that like a unikernel approach might be beneficial, because you need the performance of just every ounce of performance out of the CPU. You can't afford to run a kubelet on it. So yeah, again, this talk is to get you thinking about the things, not necessarily to prescribe one way or the other. Sometimes you need to merge layers together, like we saw in a couple examples. Sometimes you need to split them apart. At the edge node, I think you're probably going to merge them together. I know that whenever I tinker with an Arduino, I think to myself, oh, like that's just my code running on this chip. It's just my C code. There's no other thing. It's kind of crazy to me. But yeah, I think you might have to go the same approach.
I was wondering if you are only thinking of performance as one of the reasons where you merge these layers, as though that's a trade-off for separation of concerns. Because separation of concerns sort of, I think the thing that it gives you is manageability long-term. And so you're risking that when you seek performance, and sometimes that's a very good reason to do so. Are there other examples that come to mind for you besides performance that are also good reasons to merge layers?
I've mostly been using the word performance in a very loose way, of course. When you merge the DevOps layers, for example, the type of performance you get is in the performance of the individual developer team. You lose some performance in terms of you lose the performance of an ops team, maybe. The performance that you get out of Quick, for example, the Quick protocol, you're right, it absolutely does come at a cost of manageability, because now you have just one company, Google. Granted, it's open source, but it's a protocol. But the manageability that we've had with the OSI layer model, we've definitely gotten decades out of that, and it's been pretty good. Time will have to tell whether this monolithic approach is also sustainable. Likewise, with the Rails app can't be sustained in a merged way for the long term. It has to be scaled out if you're going to maintain it long term. But I'm skeptical of whether that longevity comes from the fact that you've split apart the layers into different code bases, or is it really a function of scaling it to more people? How many people have to develop on Quick on any given time? Maybe not that many. How many people have to develop on the Twitter code base at a given time? Thousands. So how many people have to iterate on the Linux kernel? Also many, but it's also a monolithic too. Like, it's not really, they haven't split out the Linux kernel into different code bases, but they split it in a different way by having deputies and that kind of thing. So I'm not super sure. I'm skeptical that you must split out layers for maintainability in the long term. I think we've got a couple of good counterexamples, but I'm not super sure. As far as other benefits, I've mostly been thinking about performance for some definition of performance. Other than that, I don't think so. I mean, certainly it's cleaner, but when you run your code, the computer doesn't care about code cleanliness. It just cares about the binary. I think the abstraction layers we build are really for humans, not for the computers, of course. And if we could somehow make it so that we don't need the abstractions and that they just magically worked and compilers do this and that kind of thing, then maybe we could have the best of both worlds by having separate layers, but also they get merged together into a thing that gets deployed like Quick. I'm reminded of biology, if you allow me to ramble for a while. I'm reminded of biology when you think about the source code that is our DNA. It's not really source code. It's really binary. It's not exactly the thing. You think about, well, where is the source code to our DNA? It doesn't exist. Nature doesn't care. And where are the abstraction layers that nature is building upon? To build. Surely it must be building complex things out of simpler things, but in practice, it doesn't. It doesn't care. Nature doesn't care about that kind of thing, and these are only for us humans. So it's us humans that need to get by with the getting away with the fact that that the Linux kernel is monolithic, or Quick is monolithic, or ZFS is monolithic, because from the computer's perspective, it sure works great. So if we can just live with that, then I think we'll be okay. Thanks for ramble.
All right, to the couple of the earlier points, there was Eddie talking about the DevOps perspective on this, and God, I didn't catch his name, that was talking about his shop and their container debacle, and like we're far enough along in the hype cycle now that like we are, conferences like this, like people are starting to go, yeah, it's a tire fire, what a mess, right? Like there's some people that have like done some really cool things with containers in Kubernetes, and there's some people that have built themselves a morass of technical debt that you're just going to have to like light a match and throw it away at some point, or Mesos or any of them, right? Like there's some total messes. So when the question, I guess I didn't quite understand, and maybe I just didn't understand, but when the question is, when removing developer friction has been the priority for so long that we have like absolute garbage containers getting pulled off Docker Hub and put into production, people just forklifting crap into containers and like, oh, it got blown away, what happened to my file system, page, right? Like there's some total messes out there. And that's because it's been made very, very easy for developers to kind of muddle along and build something awful. So if that's the question, how is making the developer experience is number one, and we just got to make the developer experience better, how does that address that problem?
It's a great question. Maybe if I could summarize it, when you split up the layers and make it really easy for developers to iterate on this top layer 7, the process itself, it becomes under no supervision, whereas before you had maybe a different team that was in charge of the rest of the stuff and whatever. It can lead to some bad stuff. I think the answer to this is collaboration with an infrastructure team. Again, I'm a big fan of infrastructure teams. If you can have your infrastructure teams curate the best practices and make it really easy to do the right thing and not allow a wild west of freedom, then I think you'll benefit. We do this at Yelp. We're big on having opinionated best practices enforced and out of the box, and like we make it really hard to deviate from that. Again, answer to is weird. I describe it as, I'd like to think that our devs love our infrastructure teams because we make it so easy for them to get their code out, because the Docker image templates that we give them are ready to go out of the box. If you can imagine this, so at Yelp, we don't even allow you to launch arbitrary Docker containers. You just can't. You can't just launch like from Nginx. But no developer ever has asked us to do that because they don't need to. They don't need that flexibility because we've given them such great scaffolding to build upon. I think the reason that you have the tire fires is because developers have been given to the wolves or whatever, and they haven't been given the right tooling. I think with a little bit of TLC from even just a small infrastructure team, you can kind of avoid that problem, and then give them a really good blessed layer 7 to build upon.
So thank you very much.
Sure. Thank you.
Next up, we have container security. So stay seated. If you're actually staying for container security, there are sort of holes in the middle here. So please either scoot down or make it possible for people to fill those in, because we have lots more folks coming in. Thanks.
I need HDMI, just some basic HDMI, not.
Hey, how are you?
It goes on this side. I'm just routing up this side.
I brought the comic books.
Yeah, we did. Well, we only had a few, so hopefully if they come ask a good question.
Well, have it right. I'll keep them out till you can ask a question.
Yeah. Hershey, I'm just going to get mine up as a backup just in case. I mean, we won't. Sounds good.
Okay, so there's only one clip mic. So one of you is going to need to use the handheld mic.
Okay, so.
And so that means when it comes to Q&A, you'll just need to repeat the question.
Okay.
Because I won't have a mic for the audience.
I might want to just practice a bit, like to make sure I'm not too loud. Do you want me to use the handheld? Because you can.
Yeah, I'll be typing. So.
Okay. Oh, I'll let you get set up first.
Okay.
Right. We got a couple of minutes. It is a little chilly here, which is good because we're about to be 100% full, which means it'll start getting warm. So,
For my mom.
I think somebody bumped the projector, so I'll fix that as soon as people stop filtering in. I'm standing in front of it.
I want one of these.
Okay. Video looks good.
Yeah.
You don't need power?
Not really.
Okay.
It was fully charged.
Okay, so this will go behind your ear.
Oh god, how?
Yeah, and we don't have a sound tech, so once you turn it on, it's on.
Okay.
So
I'm doing this wrong, aren't I? There you go.
it's tough with long hair, let me tell you. So, okay, hold on just a second, because let me announce something here. Hey folks, there are some seats in the middle towards the front here. So if people want to come forward, if you're in a row with an empty seat, please scoot one way or the other so people can get in. We're live.
Hello? Okay. Can you hear me?
Yeah, a little bit louder.
Hello? Okay.
Yeah.
Cool.
So you'll have the handheld mic.
Hello.
Yes, it's being recorded. Folks, there are a few seats left in here in the center and the front. So if ready to be standing in the back, there are two places for you to sit down. Yes, it means you can't leave before the presentation is over, but it's also a presentation. So you won't want to leave.
You will not want to leave. Can everyone hear me? Yeah? Okay, awesome. I'm not accustomed to speaking into a microphone.
So welcome everybody. This is Sally and Urvashi who are going to explain to us all about the things that you can do to secure your containers. So welcome.
Thank you.
Thanks. Yeah, maybe I want to walk down there. Not sure. I'll stay up here for a little while. All right, I'm Sally. I work at Red Hat. I'm a software engineer. I work with OpenShift. I've been on a few different teams with OpenShift, but when I started, I was an intern on the containers team. And that was an exciting time because OpenShift was being rewritten to incorporate Kubernetes. So on the containers team, we were submitting pull requests to upstream Docker, and carrying some patches on the side for things that didn't fit in with upstream Docker. But a lot has changed since then. Over the past few years, Red Hat has started some open source projects with a focus on security around containers, and that's really what we're here to talk about today.
Yeah. Can you hear me all right? Okay, awesome. So hello everyone, I'm Urvashi Munani. I am a software engineer on the Runtimes team, the team that Sally has an intern on. What our team does is we work on container tools that we need to run, that run under Kubernetes and OpenShift, and I work on tools such as Cryo, Podman Builder. And yeah, today we're here to talk to you about how you can secure container workloads and why it's really important to do so. So back to you, Sally.
Thanks. Yeah, so before we get started, a brief history. It all started with Docker. Docker made containers accessible to the average user. The SCaLE, it was easy to build and share containers with the Docker Hub. It was a revolution of sorts. So everybody was using containers. Docker became so popular that the word Docker became synonymous with containers, and in fact, like many people believe that Docker created or invented containers. So this was great because we all realized that containers were a great way of deploying applications. Lightweight, portable, scalable with Kubernetes, portable because everything you need to run your program is packaged along with it. It runs the same on my laptop as it does on yours, as it does in production. So yeah, other companies started, the use cases for containers started building up, and other companies like CoreOS was working on Rocket and wanted to be able to use Rocket with Kubernetes. And as I mentioned, Red Hat was carrying a bunch of patches also. So it just became apparent that we needed a set of open industry standards around containers. And so the OCI was created at about this time. Docker donated their code for runtime and container image format, and Google and Red Hat and CoreOS and Docker all came together. So now we have a set of standards that defines what is a container image and what is a container runtime. And that's great because now any OCI image will run with any OCI runtime. And even Kubernetes, the largest orchestration platform, now leaves that choice up to the user. As long as it's an OCI runtime, it plugs in nicely to Kubernetes. So step aside even further, let's talk about, so we're all on the same page, what is a container? Maybe you haven't, maybe this is just a reminder or whatever. But it's a normal Linux process. It's constrained with C groups. Linux C groups put limits on the amount of resources a process can consume on your system, like CPU and memory. They're isolated with Linux namespaces. Linux namespaces give you an isolated view of your system with regards to different aspects. So for instance, I'm in a container, I'm in a PID namespace, and if I run PS from inside that container, I will only see the processes in that PID namespace in that container. I won't have any access or view of the list of processes running on the host outside the PID namespace. Same thing with mount namespace. If I'm running in an Ubuntu container, I have the root file system of Ubuntu mounted in the container, and I feel as though I'm on an Ubuntu system. I might not have any idea that I'm actually running on a RHEL or Fedora host. So namespaces, and then also there's seccomp for syscall filtering, Linux capabilities, and AppArmor or SE Linux. All of these things together make up what is a running container. What do you need to run a container? A container image. That's a tarball. Really, that's all it is. You have a base layer, that's a root file system, plus a JSON description, a file that describes how to run that root file system. Things like environment variables or working directory, what user it is. So these are listed in a JSON file that adheres to the spec, the OCI spec for what is a container image. You can add additional layers like packages and dependencies, and then you update the JSON file. And all of these layers tarred up, that's your container image. How do you run a container image? You need a container runtime engine. Things like Podman, Docker, Containerd, these are container runtime engines, and they're programs that know how to do these things. They reassemble the root file system onto your local container storage. Usually local container storage is copy on write or COW, and that's because it has the ability to share layers among different images. So say I have 10 different Fedora images on my system. With copy on write, I only need one copy of the base image, and that can be shared among the 10 images. Otherwise, without copy on write, you need 10 copies of that Fedora base layer, and you can see that would quickly fill up your container storage. So copy on write, and then it creates a runtime config. That's a JSON blob. That JSON adheres to the OCI spec for what is a container runtime. It takes user input. Anything you pass to the Docker run command or the Podman run command gets put into this JSON blob, and then finally it launches the container runtime. Most of the containers that you've used or that I've used or we've talked about today is the runtime is runC. There are other runtimes like Kata containers or clear containers, but so that's it. That's my brief history and overview of containers.
Okay, so now that we know what containers are and what all you need to run your containers, the container toolchain can actually be broken down into 4 different categories. These are 1, building your container images, 2, running and testing these containers locally, 3, storing and sharing your containers, for example, moving it from a local host to a remote registry or from one registry to another, and finally 4, running your container in a production cluster such as in Kubernetes or OpenShift. Now, we argue here that each of these steps require different security features. For example, you don't need as many permissions to run a container in a production cluster as you need to build a container image. So now you can imagine if we have all these functions in one tool, you'll end up compromising your containers running in a production cluster, right? You won't be locking it down enough. So when we go back in the history of Unix, we can see the Unix philosophy states that you should design a program to do one thing, to do it really well, and to work well with other programs. As you can see here, the Unix founders are pretty happy that we decided to follow the philosophy and create a tool for each of those categories I mentioned before. So these tools are Builda, obviously, for building your container images, Podman for running and developing your containers locally, Scopio for storing and sharing these containers, and finally Cryo, a container runtime interface for running these containers in a production cluster. And now we're going to delve into how breaking these down into these multiple categories helps with the security and how each of our tools offer different security features that are really helpful when you're running your containers overall in a cluster.
Well, so yep, when you first start working with containers, you need an image, and the tool that we use for that is Builda. First thing you think about with a secure image is build a minimal image. Only put in the image exactly what you need to run your program. So the more you have in your image, the more that can go wrong. It's that simple. And with Builda, it's very easy to build minimal images, and we'll show you that in the demo in a few minutes.
Yeah, so one thing I forgot to mention before is that all the tools that we mentioned previously are being organized into OpenShift 4.0 now. So by default, your container runtime will be Cryo. All the builds that happen, your source to image builds will be using Builda. And on the nodes, you'll have Podman, Scopio, and Cryo and Builda, obviously, for any debugging you need to do. Moving on with Builda, so the next thing that you need for building securely is that you want to have a secure way of building your images. So how to do this? Basically, you can run Builda inside a container. So in this way, you're isolating your build process from your host system. So your build process in the container can have elevated privileges, while on the system, it won't have that. So if it does break out, it won't be able to cause any havoc on the system. So there, an extra layer of isolation. And as you'll see with our other tools, Podman and Scopio, Builda can also be run without root privileges. We will delve a bit into this more when we go into Podman.
All right, so we've given this talk a few times, and we thought about taking this out because it's kind of getting to be an old joke, but we don't know what's going to happen if we do take it out, so here it is. Let's give our respect to the demo gods, because we're about to start a live demo.
Yeah, we like living life on edge, so live demos for all of you.
Actually, we started this demo just a minute ago because you were using a Fedora, a DNF install, so we want to make sure that completed.
1 second. Can everyone see it in the back? Should I increase the font size? Is it good? Okay, continue.
Oh, great. So building minimal images with Builda. You can use a command Builda from scratch. Builda from scratch sets up a working container with no content in it. It sets up the scaffolding of what is a Linux container, and then from there you can create a mount point to your container file system. And once you have the mount point set up, you can use your host system package manager, like DNF, and pass the install route to the mount point to install a single package. And if you do that, the only thing that will be in your image is that single package that you needed. You can also use your host system build tools to build an executable and just move or copy that into the mount point. Builda makes this really easy. So once we have our package installed, you can use Builda unmount, and then you just commit the image. Here we're committing it to an image called minimal image. So you can see, the majority of images you pull down from Docker Hub would have ping in it. If I try to run ping in this image, I get an error because there is no ping. I can't run a Python script in this image. There's no Python. The only thing in this image is BusyBox, and that's good because that's exactly what I needed. So use your host system package manager or build tools to populate your container image.
And to only put what exactly you need in your container image. Okay, so as I mentioned, you can run Builda inside a container. So I've already built an image that has Builda installed inside it and set the entry point to Builda for that. That's the Docker file of what that looks like. And this is a simple Docker file that I'm going to build inside my container. Pretty simple, it'll be super fast. So using Podman again, I'm going to run a container. I'm going to run the Builda container image and build the second Docker file I have over there. I know the command looks pretty scary, but I'm just volume mounting some stuff inside so I can access my Docker file and access the images that are built inside the container. So let's do that. Come on, internet. Okay.
So yeah, just pointing out that Builda, you can use a Docker file just the same, and the command is bud, build using Docker file. Is copying.
Okay, cool. So yeah, so the image was built, thank God. And then now I'm going to list the images, and as you can see, my image that's listed below there, that was the image that I built inside the container, and this is my way of accessing it and seeing it. And now from here, I can move this image to a registry, I can move it to my host if I want it on my host, I can do everything I need to do with it. So yeah.
And in OpenShift 4.0, that's exactly what we'll be doing. So we won't be giving root access to the Docker daemon within OpenShift when we allow our users to build images.
Yeah. Okay. So now I don't know about you all, but once I build my container images, I like to test them locally to ensure that I have everything I need in them. And for this, we have a tool called Podman, which stands for Pod Manager, because it lets you do everything from building your containers to running containers and pods locally. Podman replicates the Docker CLI, so you can do everything that you do with Docker with Podman, as well as the pod stuff. Yeah, it's a pretty handy, all-in-one tool for using. So as I mentioned before with Builda, you can run without root. Same with Podman, you don't need to have root privileges to run. This way, admins can get away without giving developers root privilege with the system for when they were developing containers. An added advantage to this is compartmentalization, which I will delve into more when we go to the demos. And another thing is that Podman takes advantage of user namespaces. So you can have isolation between your host and your containers, but it also adds isolation between multiple containers, which we will talk about when we go back to the demos.
Yeah, and Podman runs with a fork exec model rather than a client server There's no daemon, there's no Docker daemon like the client server, and this is really important when auditing your system, like for knowing who's running what on your system, and I think we'll show that in our demo.
Yeah, and as our good friend Dan Walsh would say, hashtag no big fat demons. Oops. Okay, so podman is rootless. So now, as you can see here, I don't have the sudo in front of my podman commands anymore. I promise I'm not doing that in the back and fooling you guys. I'll prove that to you in a bit. So I'm going to pull the Alpine image pretty quickly as non-root.
It's going.
It's going, yeah. Yeah, so now I'll do podman images as non-root, and you can see that I have the Alpine image that I just pulled. So now to prove that I wasn't actually using sudo, I'm going to do sudo podman images instead. And as you can see here, I have a completely different set of images as root. So what podman does as non-root is that it actually stores all your containers and images in your home directory. So talking back about the compartmentalization, if you have multiple users on the same system, theirs will be in their own home directory, so they won't have access or knowledge of each other's containers and images. And so to show you that that's actually the case, I'm going to run the Alpine image. And as you can see, inside the container, it's UID 0, but on the host, it's UID 1000, which is my UID. So how this happens is that we're actually fooling podman to believe that it's running as root with user namespaces. Every modern Linux system has this file called sc_subuid now, which shows the mapping that your user namespace has. Your user has. So here I have everything from 100,000 to 165,500. And so let's take a quick look at my directory here. So as you can see, I have a bunch of files that are owned by Yumhonani, which is my user, and I just have one file that's owned by root. So let's do a build on share command. So what build on share does, it basically puts my account into a user namespace. It does a mapping. It maps UID 0 on the user namespace to 1000 on the host. So now I'm on the host, I'm Yumhonani, and inside the user namespace, I will be root. And as you can see, all the files that were owned by me are now owned by root inside that user namespace. And yeah, that's how the mapping does. If you want to see what your mapping looks like, you can cat proc self UID map. And as you can see here, it's mapping UID 0 on the user namespace to 1000 on the host. And that's me, I'm doing it for one UID. And then it's doing mapping 1 in the user namespace to 100,000 on the host and doing it for the next 65,000. So this way, inside my user namespace or container, I can create files that are owned by 1, 2, 3, and on the host it'll be 100,001, 100,002, 100,003 respectively due to the mapping. So yeah, we're fooling it to think it's root, but it's actually not. And so this is isolation between your host and your container, but now we have isolation between multiple containers. So with podman, we can use the UID map and create a mapping. And the example here, the mapping is I'm mapping 0 in the container to 100,000 on the host, doing it for the next 5,000. So when I run that container, and we can, so podman top is a pretty cool command that you can use to look at different security features you have enabled for your containers. And the -- latest flag is pretty dandy because you don't have to go back and pick up your container's name or ID. It picks up the most recent container you created. So more efficiency there. And here you can see that the user inside the container is root, but on the host is 100,000 as the mapping says it should be. To prove that, I'm going to run ps on the host and it's 100,000. Ta-da! So now I'm going to run another container, but I'm going to have a different mapping here. So 0 to 200,000 instead. Same thing, 200,000 on the host, prove with the ps. And now, so let's say a process breaks out of the first container and tries to attack the second container. It won't be able to because they have different permissions, you have different UIDs on the host. So there you have more layers of isolation between your multiple containers. Yeah, that's it. Oops.
Yeah, so you can see that the podman commands, what you're used to with the Docker CLI. There was a joke on Twitter that you could alias Docker equals podman, and you probably wouldn't notice. Yeah, so for the most part, but they're different under the hood.
Yeah.
Okay, so like I mentioned, it's a fork exec model. And that means that the login UID of the child process is inherited from the parent process. And the way you can see your login UID on a system is to look at the file proc self login UID. That tells the system who's currently logged in. Whether or not you gain root access, you're still the same login UID. So with the Podman, as you'd expect, when I start a Podman container and from inside that container, cat proc self login UID, it's still 1000, same as on the host, because that's a child process of Podman and it was inherited. If I do the same thing with Docker, here I'll always get the same number, and that number signifies the 32-bit unsigned int. It means this user has not logged on to the system, so it doesn't know who it is. It's the Docker daemon. So I can show this in another way. If I have some audit rules set up on a system and I want to monitor any changes to a sensitive file like Etsy Shadow, and I have a user who has access to running privileged containers, there's nothing stopping that user from running a privileged container, mounting the host, and then making a change to Etsy Shadow. When I audit the system, I can clearly see, though, that Urbashi's been messing around with Etsy Shadow, and I'd probably go and yell at her. Or not, I don't know. But if you do the same thing with the Docker command, you know, run a privileged container, mount the host, and make a change to Etsy Shadow, here you just can see that it's the unset user. So for auditing systems, knowing who's running what, that fork exec model is, has benefits.
Yeah. One more thing I forgot to mention earlier was that Podman actually uses Builder under the hood for its build processes. So tying back to our Unix philosophy of making programs do one task and work well together.
Yeah, and before we move on from Podman, let's show this feature that prints out in a nice, pretty way security information of running containers. So it's the Podman top command. And you can see if I pass the PID or host PID, it just very nicely prints out that information. I can get information about what SE Linux labels are currently running in my running containers. And so notice that, I almost want to step down here, that container underscore T type. We'll talk about that later with SE Linux, but yeah, it's printing out SE Linux information. You can see that seccomp filtering is currently turned on in this container. You can get information about what Linux capabilities are currently enabled. We'll talk about Linux capabilities a little bit later also, but it's just a nice, easy way. You can go through your whole system and run through all of your containers to make sure it's what you expect security-wise. Urvashi mentioned that latest flag, but don't underestimate how convenient that is. You all know you have to go and copy that container ID or the funny container name when you're working with running containers. So this is just super convenient that we added that.
Yeah, also keep in mind how long this list of effective capabilities we have with Podman. When we go to Cryo, you will see the difference there.
All right, so, okay, now we have built a container image very securely. We've run it locally, we've iterated upon it, and now it's time to share it with the world or push it to a registry or, switch it from our test registry to our production registry. We have a tool for that, and it's Scopio. Scopio in Greek means remote viewing. And that's where we got the name. And it was originally meant just to go out to a remote registry and show you information, show you that JSON file that describes the image without having to pull the image down to your system. Before this tool, you had to pull it down to your system.
Yeah, and sometimes people would pull down pretty huge images of like 2 gigabytes and realize this is not what they wanted, and they have to sit through another download to get what they actually want. So this helps with that issue there. So yeah, and with Scopio, you can easily move your images around from one system to another. For example, let's say you push an image to your private registry, and now you want to push it to your production registry, and you don't have it on your local system anymore. You don't have to download it first and then push. With Scopio, you can just say, push from this image registry to that registry, and it will do that for you pretty quickly. So there. And as I mentioned before, with our Podman and Builder tools, Scopio can also be run without root, so you don't need root privileges.
Yep, and if you're working with a private registry, you can pass your credentials to that private registry to Scopio also.
Yeah.
So yeah, here's the help menu for Scopio. Just to give you an idea of what you can do with it. Again, it really started as a patch to upstream Docker and it turned into this tool, and then we've added to the tool to be able to move the images around. So you can run Scopio inspect on any image on the Docker Hub, and it will give you information about the different tags, if it feels like it. It'll give you, it'll print out all the different tags and the owner of the image. You can make sure that it's the image that you were expecting before you pull it down. You might, oh yeah.
Okay, the internet, something happened there. But
Sorry.
I promise that works.
Yes,
it would just
it
give you
does.
like a JSON file with all the tags you have, the maintainer, the digest, the name, and just all the information you need to determine if this is the image you want.
Yeah, so sometimes there's a whole bunch of tags and you can't remember the one that you needed. You can go print them out and then, copy and paste it to pull down the one that you need.
Let's try that again, actually.
Or are you outside of the script?
Yeah.
Yeah, it should work.
Okay, we can continue. I'll come back to this and see if it works. So now, if you guys after this talk are convinced that you want to go and play around with the tools we have, I'm going to show you the pretty easy way of moving your images from the storage Docker uses on your system to the storage that all our tools use. As you can see here, these are the images I have with Podman right now, and those are the images I have with Docker on my system right now. So the Scopio copy command, so Docker daemon is that's just telling Scopio that take the image from the Docker storage and move it to container storage, which is the storage that all our tools use. So I'm going to move the Ubuntu image and save it in my storage and save it as Ubuntu with a demo tag. So now when we run sudo podman images again, you can see that it actually copied over, and now I have the image for me to use with podman builder cryo Scopio. So yeah, pretty easy. You can move stuff around.
Yeah, we didn't need to go out to the Docker Hub to do that, so it worked.
I don't know why it's doing that. Okay, so now we have built our secure images. We have tested them and played around with them locally. We have pushed them to the registries we want them to be on. The final step in running your container workloads is running them in a production cluster, and this is where cryo comes in. So cryo is a container runtime interface. The O stands for OCI, meaning it's OCI compliant. It will work with any OCI compliant runtime, OCI compliant image. Cryo just works with the Kubernetes API. The Kubernetes will tell cryo that I want to launch this Fedora container, do all the stuff you need to do for me, right? So what's the difference between cryo and runC? Just to explain the overview of that. So what the container runtime interface or engine does is that it gets that request, and then it says, okay, do I have this image locally? No, I don't. It will pull it down. It will store it onto your disk. Then it will tell runC that launch this container. It will set up all the networking and everything you need for it. So that's what a container runtime interface does. It's the interface between your cluster operator, not operator, cluster API server, and your container runtime, like runC, for example. And cryo runs with runC by default right now, but you can change it. It can run with Kata, with Clear. We actually have tests on our GitHub repo that work with Kata, so it's always compliant with Kata with whatever changes we make. Yeah.
I didn't know that. That's pretty cool.
Yeah. So that's cryo. And so now we firmly believe that when you run your containers in a production cluster, you should run them with read-only container file system and possibly on a host that has a read-only file system as well. This way, so if your container ends up being broken into, what the first thing that a bad actor would want to do would be to place a backdoor in your container, right? So that next time the container restarts, they will have access to it and can do stuff. But with a read-only file system, your important paths like /var/user are all blocked off, and they can't make any changes there. The only place you should be able to write would be any volumes you have mounted in or any temporary file systems you have in the container. And an added advantage to this is that you won't end up shooting yourself in the foot if you save vital information to your container path, and when the container is destroyed, you will lose it. So if you save in your volume ones that are binded in, you will always have a copy on your host. So there's that.
Yeah, containers are meant to just be disposable.
Yeah.
So, another thing, it's really easy to disable Linux capabilities system-wide for all of your containers and pods with cryo. The idea with Linux capabilities, you should run with as few as you possibly need, if you even have to run as root at all. With CRYO by default is a very short list of Linux capabilities that are enabled. Linux capabilities, they're parcels of pseudo power. So if I could be UID 0 on a system, but if I have no Linux capabilities enabled, I have no root power. So you should know exactly, especially in production, you should know exactly what your container is doing and only enable that specific privilege that you need. And we'll show you how easy it is to do that.
And we wanted to make users, we wanted users to know about this, so that's why we've exposed this in our config file for them to easily configure the capabilities. Same with Podman. CRYO has the user namespace support as well. It's still a work in progress on Kubernetes right now, so once Kubernetes catches up to that, we'll be taking advantage of it in CRYO.
And last but not least, CRYO is your only container runtime engine that can enforce FIPS mode. So if you work for the government or otherwise care, CRYO can detect if your host system is running in FIPS mode, and if you're running a container image that is FIPS compliant, it can enforce inside the container that FIPS mode. So if you're in the container and you try to run with a weak crypto algorithm, you'll get the same error inside your container as you would on your host system.
Yeah. So last demos, we promise. So read-only mode with CRYO. So CRYO has a config file that you can go and edit. We have a bunch of options you can tune around to however you want your CRYO service to run with. So I'm going to go in here and change the read-only mode. Okay, it's actually set to true already. So save this. We can restart the CRYO service. And since CRYO is made to run with Kubernetes and OpenShift, testing it locally, we use a tool called CryCTL, which is a CRI-CTL tool. And it's a bit more complicated than with Podman and Builder. You have to have the JSON files for the pod and container and all to test it locally. It's just a convenient tool for developers to test when they're developing CRYO. So I started my pod, I started my container, and now I'm going to try and install Builder inside this container. I have a Fedora container, so I'm going to try and install Builder inside it. And as you'll see, it will fail because it's a read-only file system. When you install stuff, you expect to write to /var and other paths that are logged off, and the first thing it does is probably log it. So that's why it fails, because it can't log it. It's a read-only file system. So yeah.
Well, yeah, so CRYO is just meant to run in Kubernetes. So if you look at maybe if we have time, we can show you those JSON files.
Yeah.
It's just wonky to run CRYO locally. You usually wouldn't want to do it. So let's go back into CryoConf and see that list of capabilities that are enabled by default. Out of the 40 or so possible Linux capabilities, there's that short list there. And again, we just recommend that you disable all of them and see what blows up and then add it back in as you need it. But let's remove DAC override here. And if we go and restart the CRYO service and then create a container, you'll see that if you print out the capabilities, that DAC override is not listed there.
Those are the capabilities.
Yeah. And also, if you go and create a pod, you'll see that that's carried in through all the pods, all the containers in the pod. There's no DAC override. It's very easy system-wide to shut things off.
And that's it for demos.
Oh, cool.
Okay, so now we have given you an overview of all the security features we have to offer and how they're important to use and why you should use them. This is Dan Walsh. We mentioned him earlier. He is our security guy, and using this will make him really happy, and he deserves to be happy. So please keep this in mind next time you're using containers and creating container workloads, that you should try to make them as secure as possible, obviously.
Yes, and one thing we didn't mention too much in our talk is SE Linux. So he'd be very happy if you run your containers with SE Linux enforcing mode. So a few weeks ago, or maybe a month ago by now, this CVE was announced. Has anyone heard of it? Or it affects all run C containers, like Cryo, Docker, Containerd, Build a Podman, all containers were affected by this CVE. It was pretty scary. It was shown that a process could escape the container and overwrite the runc executable and replace it with whatever they wanted. So it would just write random, run random programs on the host system. This was not good. Like in the halls of Red Hat, people were like, "Did you hear about that CVE? Like, affects all containers. We might as well just like quit now." And not really, but not really because, first of all, it affects containers run as root, and at Red Hat we have a really good habit of not doing that, especially in OpenShift, and we don't run containers as root, and SCLinux really saves the day with this too, and Urvashi will tell you about that.
Yeah, so since this was a file system exploit, basically if you had any containers running as root, it would have the root privileges when it breaks out onto your host, and it could go into the runc exec and change that. The only real thing that was actually stopping this from happening was having your SCLinux in a enforcing mode, because you remember from earlier we said keep in mind the containerd label. So the containerd label can only write to files labeled container file t, while the runc file is labeled container runtime exec t. So SCLinux was like, this is not where I can write this, I'm going to block it off. So SCLinux was really the main thing that was sort of stopping that vulnerability from happening on all hosts that had this enabled. And as Sally mentioned, we always pushed everyone to run your containers as non-root. We do this by default in OpenShift as well. So if your process is running without root and it broke out, it wouldn't have been able to make any changes to the runc exec. And again, just to reiterate, do not just download random images of the internet, double check what you're using. You might have a compromised image that can cause problems on your host and all. So there's that. Yeah, and actually what we found out was that all the containers that were using runc, about 95% of them had this vulnerability because they were not using SCLinux on the host system. So it was a pretty huge number that were vulnerable. Yeah, and very quickly runc submitted a patch. So as long as you run with the latest version of runc, you're protected anyways. Yeah. But most exploits that have come out with containers are file system exploits. Yeah. And so SCLinux goes a long way in preventing like all of those. Yeah. So as annoying as SCLinux can be sometimes, please keep them in enforcing mode when you're running your containers. Yeah. So these are the resources we have. We have the websites for Cryo, Build a Podman. We put blogs up there all the time. They will link you to our GitHub pages if you ever feel like you want to contribute. We're always looking for contributors, obviously. The demo script, that's the link to the demo script. If you want to run it on your system locally, you can go through the whole thing. And we actually have a coloring book that shows what each of our products does. And they each have a pretty cute avatar. That's why we do at Red Hat, we make coloring books. And we have some over here right now. You feel free to grab some of them. If you ask good questions, we'll pass them out right now. And then whatever we have left over, feel free to grab them. We also have another kind. That's just a container coloring book, just talking about containers in general. We stole them from Dan's cubicle. Yeah. That's his job, making coloring books. Oh, we should mention that Maureen Duffy at Red Hat is a wonderful artist. She's on the Fedora team, the UX team, and she illustrates these coloring books. So yeah, coloring is very relaxing. So if you're stressed, color. And that's all we have for you today. Thank you. Yeah, thanks. Any questions? Yes.
Well, probably she doesn't have a mic. You can take that.
Sorry, wait. Say again. Do we use this process in a CI/CD pipeline? I love this question because I can answer it. This is awesome. We use Kubernetes Prow in our CI/CD pipeline. It's like amazing. We have stickers too. So all of our CI is run in an OpenShift cluster, and it incorporates Prow, Kubernetes Prow. I'm trying to clear my thoughts. But yes, we use all of this in our CI/CD. Yeah. Internally we do. Yeah. Yep. Internally. Any other questions? One there. Yeah. Have any of these things been put into Ansible roles? Our install process for OpenShift 3 is, oh, that's OpenShift.
Yeah.
Oh, Ansible Bender.
Yeah.
Yeah, there's a new tool, if you can find it, if you Google it, it's called Ansible Bender. And that is a tool like Builda. It builds container images using Ansible.
Yeah.
And that's brand new. It was just announced like a month or two ago.
Yeah.
So look that up on.
Yeah, so we have been migrating all our tools to use Podman, Builda, and all internally. We're eating our own cake, obviously, so all the Red Hat stuff is moving towards that. Yeah. We didn't choose to do that. They just told us they didn't want to accept it there, and we should just create another tool for it, so that's what we ended up doing. And Scopio was born. Sorry?
Oh, like Podman Inspect?
Oh.
Can you Podman Inspect?
So Podman Inspect does it for local images. Scopio is for remote stuff. Hence the remote viewing. That's what the name means. Yeah. So that's why it's a different tool.
I'm sorry?
What was that CI/CD tool called you just mentioned?
Oh, Prow. Prow. P-R-O-W.
Yeah.
Yep.
No. You can just DNF install. If you're in Fedora, just DNF install.
Any other questions? Yes.
Systemctl? Yeah, that should already be on your system if you're in Fedora. Yeah. Yeah. Yeah, for credit.
For health checks?
So if you want to run Cryo with
gonna ask,
Kubernetes, you have to set
Arvishi,
up
I'm
the
not
cluster
sure.
to pick Cryo up for you, and there are guidelines for this on our GitHub page. Yeah. So to run everything, we have on our GitHub page all the tutorials and all to get you
Oh,
started.
the slides. Yeah, we have to just figure that out. Yeah, we'll update it. How can we update the link to our slides? It's still private.
Oh, it's still. So.
Yeah,
Okay,
yeah.
we'll try to get it out there. Josh, do you know anything about that? Yeah.
We could update maybe the GitHub
Oh, yeah,
repo
the demo
with
script
a link to our
and with the link to
slides.
slides.
Once
Yep.
we figure it out. Sorry.
Yeah.
The coloring books you can download because they
ran out.
Yeah, they ran
Sorry,
out.
but you can download it. We have it online.
You can download the PDF there.
Yeah. All
Yep.
of them are there.
Yeah. If you're not using the Docker daemon.
So we're adding health checks to Podman right now. It's a work in progress. So you can use Podman for it. Yeah, and Cry also has some health checks in place. Yeah.
Okay, awesome.
Yeah.
Oh, cool.
Yeah.
Yeah. Yeah.
So the patch you guys discussed, right?
Yeah.
So we received an update. We worked through Red Hat, and they only say yum update run C and not the SCLNX.
Oh, you mean for the CVE?
Yeah.
Oh.
Sorry, I can disconnect this.
5736 2019.
Yeah.
5736.
Oh.
I recently updated like Jan.
You updated the Run C version?
Yeah.
C version.
And it's not
Well,
fixed?
Well, it's applied.
Okay.
But my question is, are we still in the problem?
So with the latest run C, the problem is not there anymore.
With the
They
latest
fixed it.
run
There's
C,
a
they
patch
fixed
for
it.
it. But for future, if there's any problem that comes out, if you have SCLinux enabled, you are safe from usually.
You're asking is, do you need also a patch on the latest? I think that's what you're. I think as long as you're running the latest, it's all set.
It's all set, yeah. But do keep SCLinux enforced, since that would prevent any future file system exploits that may come out.
Okay.
Yeah.
So if in the direction that either the boss or the company doesn't appreciate SCLNX, they don't in some cases.
Yeah. I know.
Run your containers as non-root as
Non-root,
much as possible,
yeah.
and in the future there will be way more support for user namespaces, and that can also
That would be helpful
because you can be root in your container and not root on the system.
You summarized that for everybody here? All right, thank you.
Yep. With the
patch and user namespaces.
the fact that user namespace is not a done deal, like
Some people in the audience who are trying to hear what you were saying.
Okay.
Oh, okay.
Okay, so with user namespaces, it's possible you can be root inside your container, but if any process breaks out of the container, then you're not root on the system. That's the benefit of using user namespaces.
So with any like file system exploits that come out in future, if you're running as non-root, on your host, but root inside the user inside your container. That's sort of a UID mapping thing. So you're usually safer from the exploits that happen. And if you have SLinux enforcing, it's definitely more safe. Like it would keep it. You would not be as vulnerable.
Thank you.
Thank you.
So these two are for you.
Oh, thank you. Thank you very much. Hi.
That was really great, thank you.
Oh, thank you so much.
I was wondering that, did you use some tool to do that demo? That was where you had like.
Oh, it's just bash.
It's a bash script. You can
Okay,
just go on there and
And
use it.
go to
That's a
if
good
you took
idea.
a picture of it, you can go and look at the script. It's in our GitHub repo.
Oh, awesome.
Yeah, just take it, seal it, run it, whatever.
really smart.
Yeah.
To install all these packages, if you're on Fedora or Realm, you can just do DNF for yum install, and you get all of that.
There's a bunch of us that have worked on the script, so adding the colors and stuff, yeah, it's all just in bash.
Yeah, it's all
Very
bash.
cool. Yeah, check it out.
It has some stickers if you want.
Oh, nice.
We just leave them around for people to grab.
I'm glad you appreciate it.
Yeah.
Well, thanks a lot for coming out to the West Coast here. And I was like, that would be really cool. So. Beautiful house, yeah. Thanks. I mean, you can take a look, because you should, if you use the CLE link that you originally followed, and so you can't navigate to the home website right now, you should still be able to log in and see your call, whether or not it's public. Yeah.
Testing 1, 2.
Awesome, thanks.
For you guys walking in, there's some seats in the front 4 rows here. We'll get started in 2 minutes.
Okay, everyone. Next up, we have Stephen Wong from VMware, who's going to explain how you can have your own private container registry, which is kind of like having your own private Idaho, only with an API. So, welcome, Stephen.
Thanks, Josh. So I'm Steve Wong. I'm a software engineer. I work in this business unit of VMware, a long title, Cloud Native Applications. It basically means I'm in the part of VMware that does Kubernetes. I'm assigned to work on the open source end of the Kubernetes project itself. I've been active there since 2015. I've also worked on a number of other open source things related to the container space, like Mesos and DCOS. The agenda today, we're going to get into life cycle. Well, you can read it quick because I've got a lot of slides and I'm going to move along. This is sort of a rehash if you were here for the presentation just before mine. Thanks to Urvashi and Sally for covering this pretty well, but we're going to start with a primer, just a refresher on container lifecycle, where your containers start with a Docker file, a textual description. I'm going to call it a blueprint. Picture it as if I had a blueprint, if I'm Dr. Frankenstein, it's going to tell me I want a green arm stitched to whatever, and it's just the instructions for building it. There's a build process that actually takes those instructions and builds something, but it isn't living yet. It needs to be struck by lightning bolts to come to life, and that's the act of actually starting, stopping, restarting your containers. These containers, after being built, live in something called a registry up there on the upper right. The most well-known version of this, I'd contend, is Docker Hub that hangs out there on the internet. The process is that you build these container images, push them to a registry, and then when you want to use them, and they can be used in a different location than where they were built, and in a big container-based installation like a Kubernetes, they typically would be used in a different place, and the act of using them involves a pull out of the registry and then starting that image. This is just an example, but my point here is that this Docker file looks like this. But one of the aspects of these are that if you're not careful, what your Docker file produces tomorrow might not be the same thing as today. You see this example just references Ubuntu. What does that mean? Well, it means a different thing tomorrow compared to today potentially. Interestingly enough, even if you attempt to lock this down to put a tag on here, which you have the option to do, whoever owns where this is being pulled from, if it was being pulled from Docker Hub, the person with credentials to that can blow away what's under that specific label and replace it with something else, and you don't know that that isn't going to happen. So, like I say, if your goal is to produce consistent, immutable, reproducible deployments, you potentially aren't going to get there from Docker files alone. You perhaps need something to help you out there, and this it's not until it builds into an image that it's static. So why does this matter? Well, getting valid results throughout the whole software lifecycle of dev, test, staging, production translates into consistency in production. You want to verify that if you have a test organization in your enterprise, that what you tested actually is what got deployed in production. So a bad idea would be to have these things rebuilt from Docker files every time they're deployed. So you need some kind of governance over this. You need auditing, you need snowflake avoidance. So what's involved here is a registry. And what I'm going to advocate is that many organizations would be best served by having several of these registries. Have your developers push them into a dev registry, have these things QA'd, and then replicated over to a test registry. And finally, as you're going to stage it for production, you might put it in staging and production registries. So, you know, the bad advice would be to use things directly off of Docker Hub going right into production. I think that that is really dubious. You might not need this number of registries, but this might help you to govern your use of containers in your organization. So one of the things you have to worry about when deploying these container images is security. And I guess this is a repeat of what was in the session before you, but there are stages of protection here. Linux itself has C groups, namespaces, security constraints. Then the container runtime has some levels of isolation that are designed specifically to protect you. So is this a situation where the world is seashells and balloons, a day at the beach, don't worry, be happy? Well, there's more to it than this, because you're sucking in ingredients when you build this container. You know, there was a pretty well-known incident a few years ago with OpenSSL that resulted in things all over the world being rebuilt and exposures in websites. And what's in your container might well draw in something like OpenSSL. And if it isn't OpenSSL, it could be some other thing with known exploits. There are organizations that track these. They're called CVEs, or Common Vulnerabilities and Exposures. And these organizations that do this publish databases of exposures. This is just an example for OpenSSL, but the bottom line is that if your container is built and draws in something with a security exposure, you can go from that happy face balloon to the deflated one on the ground pretty easily. Now, what's your worst case? You know, if you, sooner or later, you're probably going to draw in a component that has some risk, but you do have Linux and your container runtime acting to protect you. What's your worst case? Is it that somebody breaks your bike and you end up with this scenario in the picture. Well, it could be a little worse than that, because the way containers work, what's in your container shares the same kernel as the host it's running on. So if you've got a host that is running 10 containers at the same time, they're all sharing that Linux kernel. Now we're relying on CNAMEs for protection, which shields a lot, but not everything. For example, devices aren't protected by CNAMEs. So if Linux itself was to have an exploit where you could have an escalation of privilege, you could have some fairly ugly scenario, like the whole bike rack gets defeated and you lose every bike in the rack. So assuming the kernel and container engine are bug-free, or nobody else out there ever exploits bugs, you should be safe. And thankfully, we all know Linux started way back in 1991. It's had a quarter of a century to become solid. So I'm sure at this point that thing is fine. But it can't hurt to look at some actual data. So this is an interesting article. There's a link. I'll give a link to this deck later on by Keys Cook out of Google, that he produced this report on the number of security flaws in Linux releases and how long they existed before they were detected and patched. I know this thing is an eye chart and hard to read, but that access, the vertical axis is actually Linux release numbers. And the bottom line on this is that there's absolutely no evidence whatsoever that the Linux kernel has become bug-free. And their latent defects in every release have been present for years before they're first reported. And even after they're reported, it can take a while to fix them. What about images in vulnerabilities in, even if you think you're okay with the kernel, what about vulnerabilities in Docker images themselves? This is a report that was just published a couple weeks ago by, I don't even know how you pronounce this, SNYK, but they went and produced this report, and there's a link to it in the deck, that goes and looks at the most popular Docker images, and you have there this eyesore on the left is Node, but there's a lot of other popular things in there. I see Postgres, Nginx, and the number of vulnerabilities in these things. So there's a lot of potentially bad ingredients, you know, things in your sandwich with salmonella lurking out there. And you know, if you don't think this is widespread, in the past year, Docker Hub itself removed 17 backdoor Docker images, and this included MySQL and Tomcat images that had crypto mining botnet backdoors. And these things were left in that condition for a year. And they were discovered when people reported strange behaviors, but this stuff is clearly out there, or at least it has been historically, and I think that you'd have to be pretty optimistic to assume that we finally cleaned this up and it's never going to happen again. So, in addition to bad stuff that can be in these images, there are some other security-related issues regarding these images. One of them is your own in-house images. You generate your own code, you containerize it. For many organizations, this is considered intellectual property that you don't want to get outside. You might want to apply some levels of governance on who can actually get at those images and use them, who can replace them in your own organization. With third-party images, you know, we've got this problem where you don't want the summer intern to come into your organization and start grabbing random images off Docker Hub and introduce them into your production workflow. Well, how can you shut that kind of thing down? Because you don't want to shut down all of Docker Hub potentially. You need to have a mechanism where people internal to your organization can vet these and sign off on them, just like maybe the QA organization signs off on things coming out of your dev organization. What about licensing risk? It isn't all about security. Your organization might not want to take in some things like commercial code that could be in containers out on Docker Hub, and somebody might want to evaluate that. When you put this system of permissions and controls, it's sometimes valuable to have this be role-based, so that if you have a big organization with 1,000 people, you're not maintaining these based on individuals' names, because that can be high overhead to maintain. Instead, you'd like to give permissions based on people's job role or title, and then put people into those groups of the roles. It would be nice if you're the typical business enterprise to even integrate this into your existing LDAP or Active Directory. Access control just makes it easier to manage at scale. So you want these kinds of role-based accounting acts to be enforced when your images are pushed, pulled, and based on what people's roles are within your organization. In order to enforce this, what you want to do is apply signing to these images. And there's something called the Notary Project, an open source project that enables you to do this, both for provenance, so you know who produced this image, or for sign-offs on the appropriate people authorizing the use of these images and the context of those usages. So having this feature of signing and enforcement of these signatures is potentially something that you really want to have as you take containers into production. Image scanning is another one. This is similar to virus products that you might find in the PC world. They would analyze what's in a container based on digging in and doing analysis, comparing them against signatures. So there's an open source project called SCaLE that is very popular in this space. It identifies, potentially this can be engaged, this would be a registry feature, to identify images with vulnerabilities when you push, maybe rescan them again when you're pulled, because the fact is that these CVEs often are kind of late events where the latent defect has been in there for months or years, but it gets discovered, and maybe it didn't get discovered until after you put this image into your registry. And if you really want to wear the belt and suspenders, maybe you rescan them on a timer basis and rescan them every time these vulnerability databases get updated. There's a number of these databases, so I've got some examples here coming out of Debian, Ubuntu, Red Hat, Oracle, Alpine, and there are others. Another valuable feature when it comes to running these container image repositories is replication. And replication is useful for a number of benefits. One is scale. If you're really running a large data center and potentially pulling these out for a horizontal scale out where you're running thousands or tens of thousands of instances in parallel behind a load balancer, maybe a single container image registry isn't up to up to your workload, but by having the ability to replicate, you can put multiple instances of your container image registry behind a load balancer to achieve scale. At the same time you're doing this, you'd also be achieving high availability. If one of these image registries goes down because of the hardware it's running on has a fault, some software in that system crashes, you bring it down for maintenance, the rest can carry on. So this replication is valuable. It's also potentially valuable if you're somebody using multi-cloud in a multinational organization that's scaling across multiple geo-regions. You can have your organization push up authoritative container images and have these get replicated around the world. Maybe you're using Amazon's cloud in the United States, but you're using Alibaba in China, for example. Standing up private registries that replicate these can lower your operational expenses by taking care of this kind of thing under the covers. My summary of the features you want or maybe require in a container registry: multiple registry support for dev, test, production, authentication, integration into your existing role-based accounting system. You want governance, permission, enforcement image signing, audit logs. I didn't cover audit in a slide, but audit logs are the concept that you have logging of when these container images are pushed, who did it, where they're being used, who's using them. And this is kind of the equivalent in the physical security world of having security cameras. You know, ultimately, things can't be bulletproof. That history has proven that. But having this camera available to scope what your exposure actually is. You know, there have been incidents in the past where credit reporting agencies, retail stores have been hacked. And you could expect that you're going to get hit by the press, your customers, your management as to, you know, who's at risk here, what really happened. Having a rich set of these audit logs can constrain this, where you could say perhaps authoritatively that, gee, I can prove that even though this image was detected with a flaw, it only ever ran on these 3 servers during this 3-month window, and only these customers could possibly have been involved. That could save you a lot of work hours. It could actually allow you to put out a press release that would save you some customers. You know, acquiring customers is really expensive, but I know me personally, when people I deal with have told me that my accounts have been hacked, I go do business somewhere else. And as expensive as customer acquisition is, reacquisition is even more expensive. So this could be super valuable. You want something that has automated configurable security scans against popular CV databases and lets you control the knobs and dials as to which of those databases you use, how often you do these scans. You want something that supports replication for SCaLE, high availability, multi-cloud geo-distribution. Maybe you want these additional features of running on-prem, running with air gap where you have no internet connection, maybe even a web UI to make this thing easier to use for people in your organization. Now, ultimately, you have some choices here. I mean, you could sanction downloading container images right off Docker Hub and putting them in production, or you could lock things down like a prison. There's a continuum here, and you can choose what you want to do. You know, on the left, we've got the Burning Man Festival. And there is something called chaos engineering, where failures are intentionally induced in random production servers during normal business hours to prove your resiliency. Suppose a news story broke saying your policy is to run random software off Docker Hub continuously just to prove your security measures are bulletproof. Maybe your boss, Wall Street, and your customers are tolerant enough to approve that. I know where I work, they wouldn't be. But if this is how your IT department rolls, I'd wonder if you really go that full Burning Man and Friday nights in your organization have people microdosing acid and chucking random burning servers out 6-story windows, because that's what this is like if you don't use any form of governance on your containers. Now, you don't have to go all the way into the full prison lockdown, but you'd like to have some ability to have governance and maybe have it be configurable in your whatever image repository you use. And you may indeed want to have or need to have a private image registry. So let's check out what's out there. It turns out there's a lot of them. I'm going to wrap up this talk covering one in specific, but I aspired in this talk to actually do an inventory of every container image registry out there. Yeah, take a picture, but we've got hosted ones that run in a public cloud. We've got some that have the option of you running it on-prem or in a cloud. They kind of all have standard features of access control of some sort, an API. The original Docker Hub, in a way, standardized the API for these, but there might be extensions to the API that would add valuable features that might be useful in your CI/CD scenario. Features of some what I call enterprise registries are that they support both cloud and on-prem. They have cross-site support with replication. They do the security scanning of the images, integrate with your existing access controls. some of these, a small number, are actually adding the feature of also becoming a Helm chart repository, which if you use Helm, might be valuable to you. My suggested eval criteria, I mean, this is an open source conference. Is it open source? Not all of these you see here are. Strangely enough, I aspired, as part of this talk, to do a spreadsheet with links to where the source lives on these. Started to do Google search on some of these that have had press releases saying they're open source, and in the first page or two of Google search, I couldn't find where that repo is. I mean, there's open source and there's real open source that has like a governance model and some scenario where the full product is open source, not some trial version. And this can be used as a criteria for sorting these things out on the left side here. There is a concept that the CNCF promotes called velocity that measures the health of an open source project by the number of contributors. You know, there's sort of like measures I consider to be BS, to put it bluntly, like GitHub stars. You know, you could have engines that go there and give yourself your own stars. But there are some things that are much harder to fake, like the number of contributors, the number of PRs being merged per month, whether the contributors are coming from multiple organizations, what the size of your user base is. And these enter into that concept of velocity. Governance is another thing. Is it open to outside contributors? There is a project called Harbor that is a CNCF hosted project that I think has very good measures based on velocity. It has 121 contributors from 25 different companies. I went and just looked this up 2 days ago. 60 plus merge pull requests in the past month. I give the figure there that there's 20 plus independent production users. Now, I'm sure there's way more than that, but these are all users who put their logo in the GitHub repository to publicly announce that they are backing this project. And I suspect that many of these production users fall in that category of the 25 companies where these contributors are coming from. Many of these users, by the way, are people using it in actual supported products like Kubernetes distributions or Kubernetes as a service offerings. So they're not like a single one-off enterprise users. These are real organizations kind of betting business units of their company on Harbor. So let's get to some key features that are found in the Harbor image registry. It uses SCaLE, the open source project for vulnerability scanning. It uses Notary, another CNCF project, for signing. It has integrated user management and access control, policy-based replication, so you can take it across geo-regions. You can do replication for HA or SCaLE. It has a nice web UI, which I'll show you in a bit. Full audits and logs, the security camera aspect, watching what was going on so that you can go back should something happen and try to establish root causes so that kind of thing can't happen again, and scope the damage you might have suffered. A REST API for integration, and we'll get into the architecture. It uses the standard Docker interface, and I'll cover that in slides to come. Browser for UI. There are multiple backends. I believe that there is an active issue to change some of these. Right now, by virtue of the fact that it sucked in SCaLE, Notary, some of these other things, each of which they had their own state repository, resulted in the internals of these being, let's say, suboptimal, and they're trying to potentially re-architect this to clean up the back-end store used by this thing. But you can go find this on the project website, by the way. So how to install it? It's pretty easy because it runs in a Docker container itself. Essentially, it's an eat your own dog food scenario. There's an online installer that you download that includes the Docker image, or you can do a very small offline installer. There is also a Helm chart available to host it in Kubernetes. So I'm going to do a demo, or at least I'm not going to do all the steps of this demo, but you can, as it turns out, you can do your own demo. So I'm going to publish this deck, but there's an online demo of a harbor images registry online. You can go to that link, get your own account there, and play around with it. Now, if everybody in this room goes and hits it at once, I'm not sure how big the server is behind this, so potentially it might act slow, and the whole point of this isn't that you use the demo one, it's that it's pretty easy to stand it up on your own. In fact, if you have a fairly high-powered laptop, you can run it there on your own laptop to check it out. So if you're new to the whole concept of even a private image registry and have only used Docker Hub, these are the steps involved. You would do a Docker pull. This would be pulling Nginx out of Docker Hub. And I'm intentionally taking a label there, by the way, 1.13, that's a few months old, because I wanted to pull one that has some flaws in it that are going to show up on the security scan. So what I'm doing here, and you can recreate this on your own, is pulling a slightly old Nginx that I log into my private image registry. I relabel or retag this Nginx to associate it with my new private registry under even a new version level. And this would be the act of taking what might have originally been public, sanctioning it for use in my organization, potentially under my own tag, and keeping it in my own private registry. And finally, I push into the private registry, in this case, the demo goharbor.io. But if you stand it up in your own laptop, this would be the host name of wherever you stood up a Harbor registry. So I'm not covering in this demo, by the way, signing and advanced topics, but it's well covered in the docs for the Harbor project itself. There's actually really good docs there with plenty of examples. So the demo here, let me cut away from my slide deck because I'm going to show you this live. So I already did the steps here of pulling Nginx, logging into the online demo Go Harbor, and pushing it up there. So let me cut over to show you that. Oh, I didn't test this on the low resolution projector, so hopefully this is going to be visible. Okay, so I'm logged on. This is the web user interface for that demo goharbor.io. I previously logged on as a user. You just go there, create your own username and password, and then you can create your own project. I created one called private in this case. I'm going to drill down into private. For some reason, it's not working. Let me do a refresh on this web page and see what happens. Oh, my login expired. Let me log back in. It looks like maybe somebody in the audience just did this quickly and I see a new registry created. But inside private, I see the Nginx that I pushed. And you see here there's I apologize for the low res, but this actually is a nice bar chart that conveys the security vulnerabilities that the scanner detected when this thing was pushed. And I can drill down on this by just clicking on it with the mouse. And I actually see the list of CVEs. And they're color-coded by, negligible risk, medium. We'll just take one of these as an example. It opens up the CVE itself and explains, the details of what this vulnerability is. So, like I say, it's got a nice UI here that lets you get your head around this and see what's going on in your organization. And if you're going to allow within your organization a lot of end user self-help with devs who are going to get notified that, hey, you seem to be the owner of this image that our registry is flagging as having security risks, giving this ability to go in there and see just what this thing is complaining about is a potential time saver that makes your organization more efficient. So let me get back to my deck here. So how do you use it with Kubernetes? Well, I'm not going to demo this live, but the steps for using it with Kubernetes are that you have to take the certificate of authority cert file from the Harbor registry and put it on your Kubernetes worker nodes. And of course, I think if you're familiar with this, you could use your own organization CA if you wanted, but the idea is you need to have some kind of CA at your Kubernetes worker nodes. And then under the covers, when Kubernetes is scheduling these pods that contain these, that start up these container images, it's going to need to log into that private registry. So you need to keep this in a Kubernetes secret. And with kubectl, there is a create secret, and there's a specific form of the create secret made for Docker registry credentials. So that's what you use here. You specify the host name of your web server. Optionally, you can put a port there if you're at a non-standard port, a username, an email, and a password. Once you set this up, we'll move on to what your pod. My mic went dead. I think the battery died. I'll yell.
Okay, we'll hear you. The handheld.
Okay, thanks. So in the pod spec, what you do is down here in the container portion, and you're referencing your private registry to pull the container images, and you also reference the credentials. Now, if you wanted to make this cloud native, meaning that my goal is to develop Kubernetes apps, you're probably not going to want to hard code this IP, but you can use DNS things like CNAMEs and aliases to potentially put a name there that is going to map to the appropriate private registry wherever this might land in the world, just in case you're one of these multinationals that runs independent data centers, US, Europe, Asia. So here are some curated sources of where you go to learn more. I've got the GitHub repo itself, which is also where you can get a link to that demo. There's a blog article that's reasonably fresh from 2018, a YouTube video that maybe did a better demo than what I just did. There are community meetings. So this is a CNCF sponsored project. You can get involved. A lot of these features are being added. For example, the Helm registry feature was added in the last 6 months. And people are coming to the table with great ideas for how this might be extended. You know, when you get down to it, a container image registry could be viewed, and this is what the discussion entailed when people discussed turning into something that would hold Helm charts, as a feature that would be a blob store with a catalog and some form of governance in front of it. Well, there's a lot of things beyond container images that might potentially take advantage of that. Helm charts are one example, but people are talking about using it for some other things in that space too. So this is a growing community, and I think we'd welcome other participants in here. There's a lot of users showing up, a lot of developers, and you can come on board yourself. And that is the best way to get involved. If you're a big user that's serious about this, and I think if you're serious about containers, the container image registry is going to become a key part of your business. It might be worth your while to look into these meetings. There's a wiki with a roadmap link there too. So thank you. And here's a link to the deck and my personal contact information.
Is it possible for you to show how notary operation look like? Is it?
I don't have it ready, so I don't want to try to do it live on stage because you have to create security signing keys. That's one of the precursors of that process. And if you go look at those Harbor docs, there are really good examples of it, but I didn't want to, at this point, trying to do it ad hoc with the time remaining, I don't think I could get it in there. Sorry.
This is a super cool talk. Thank you for sharing this. This is really good. This really lays bare that containers are really good for last mile, like inside your infrastructure, getting software around and deployed in milliseconds. But as a software distribution mechanism, they're a horrible, horrible way to do things. Assuming that all containers, except for naked ones that are running Go binders or something, since pretty much any container is going to have a base image underneath it, Red Hat, Debian, Ubuntu, CentOS, you can pretty much you can pretty much accept there's going to be security updates to your base image daily. So if your software is getting distributed on top of a base image, basically any Docker container that's over 24 hours old is basically stale and you don't want to run it ever, right?
Well, it's kind of up to you. Like I say, like that diagram of this continuum from Burning Man all the way to the prison lockdown. I think that if you're a financial institution, you're going to really tighten things down, and you might be right that these things get updated. I'm not sure if it's literally daily, but certainly a lot of these major components have CVs coming out weekly. It's kind of up to you, and what you want, a key element here is that the tooling you use is configurable to let you make that choice. And for some aspects, when it's still in dev, maybe you have a different policy where that was my whole point for why you might need multiple private registries in your organization, not just one, that the dev organization probably can operate more loosely, and you even allow people to experiment with things that got sucked in from outside that haven't been thoroughly examined yet, because somebody has to get them in order to examine them. But by the time they move closer to production, you really need to operate on a tighter basis, and different departments within your companies might have whole different policies. The financial aspects could be a whole lot different from something that really are just advertising distribution or something.
Since you're going to be using Harbor as your Docker registry, can you talk a little bit about how to bootstrap Harbor, considering it is the registry? How do you deploy Harbor, given the fact that it's probably deployed inside a Docker with a Docker image? Which Docker images do you use? Do you bootstrap it with a insecured, unscanned image first, and then redeploy it later with another? Can you talk about that kind of process?
Well, there's a number of options. So I don't want to turn this into a sales pitch, but there are some commercial Kubernetes distributions that bundle Harbor into the distribution. And you can discover those by looking at the Harbor project. So one way to get it curated and maintained for you, maybe even with something that handles updates of Harbor itself, is to get it through a Kubernetes distro, or I believe it's also found in several Kubernetes as a service products. If you want to do it by yourself, it's a continuum of take the source from the repo, build it yourself, or download the Docker image for Harbor from Docker Hub, and it's kind of your choice as to what you're comfortable with. For bringing it up, go to the Go Harbor docs, and the bringing it up gives examples of taking it in a Docker image form, but nothing forces you to take it in that Docker image form if you don't consider that adequate.
My question is more along the lines of if I downloaded it as a Docker image form, that Docker image is not part of my Docker registry once I have Harbor set up.
Yeah, you're going to have to prime the pump of getting that image from some authoritative source, and there's no getting around it. It's kind of a chicken or egg, which comes first. But after that, you can put it under control.
Thank you. How would Harbor compare with something like Quay?
I'm not an expert in Quay, but I think that they do have similar features. So Josh here is from Red Hat. Do you? Yeah, I did. I told you before I was trying to do this spreadsheet. I had good intentions of listing all of these with links to where they live. And I certainly, Kay has more things publicly exposed than a lot of these things. I think just in the last week, if I'm not mistaken, Uber put out a press release for something called Kraken that purports to be in this space too. And there's a lot of it out there. So my sorting criteria would be to look at the features, and I think K is pretty full featured. And then look at that velocity measurement of how many active contributors are there and use that to sort of sort out. You could probably, by those two criteria, features plus how active is the community, throw out 90% of the contenders and be down with a really short list. And then look at them from that point for, for your own specific use cases. And by the way, if you want Harbor stickers, I think there's some available at the VMware booth in the expo.
Check, check.
We're going to get started in about 4 minutes.
Testing, testing. Yeah, that seems like it's making sound.
back to the second day of the container track afternoon session. Tim Pepper is a coworker of mine at VMware. He works in the open source office, and he is a very active participant in the Kubernetes community, active in Kubernetes releases, community activities. Take it away, Tim.
So this is maybe a slightly unusual talk compared to some of the other ones at the conference. A lot of the talks have been about technologies that you might be consuming, and I want to talk about collaborating and contributing back to communities with an example of Kubernetes. So we're going to talk about growing your Kubernetes contributor role, which maybe for you today is 0, but maybe we can turn it into something non-zero. So hopefully I'll be able to kind of demystify some of that process, and then I'm going to do it with kittens because kittens make everything better. So what I'm going to talk about, so this is going to kind of be a story of this large high-velocity open source project and how it's grown out of one particular company and how it's now this open source phenomenon. And that's maybe kind of buzzwordy, and yes, I agree, but I throw that out there because Kubernetes needs you. If you rely on open source, so say you're here learning about new technologies at the conference, but you're relying on it in your business, you actually should get involved. You owe it to the projects upon which you depend to give back and get involved and contribute to their overall quality. So hopefully this talk will give you some sense of how you might be able to do that in Kubernetes. And who am I? So as Steve mentioned, I am Tim Pepper. I work at VMware in the Open Source Technology Center, Twitter, GitHub, email there. But I'm actually kind of a Kubernetes newbie. So I only got involved in Kubernetes about 1.5 years ago, and I've been what's called an org member since 1 year ago, and I'll go into what that means in a little bit more detail. But once I got involved, my contributions started progressing, and I got involved in the 110 release team as the issue triage shadow role, and I kind of got promoted up to leading that role in the 1.11 release, and then last summer and fall for the 1.12 release, I actually led the release team. And once you start doing more stuff, people start putting you in charge of things, so now I'm one of the co-chairs of SIG release and also a co-organizer on the working group around long-term support questions for the projects. So you're kind of saying, well, like, how does that happen so quickly? Like, how do you go from like 0 to that level of involvement? And part of the answer is I'm an experienced software engineer. I've been doing open source system software development for 20 years. This is what I do. Prior to VMware's open source group, I worked in Intel's open source group. Prior to that, IBM's open source group. I've done everything from driver development through kernel, Linux distro work, software update, storage, security, HPC, all sorts of system stuff. But cloud orchestration is actually system stuff, so there's a lot of overlaps. And I'm hoping to be able to sort of tell a story where you may have similar experiences or you've got something that you know about and you can bring that to bear in this open source project as a contributor. So first to sort of just level set, like what is Kubernetes? I think at this point probably everybody knows what it is, but Kubernetes is this containerization, orchestration, automation system. You've got something you want to run, it's in a container, this helps you get it running, right? But I think people don't always remember, just a short time ago, Kubernetes wasn't just Kubernetes, it was Kubernetes by Google. And I call this out because we've actually gone through a transformation as a project in recent years. It's now community driven, it's more than just Google, it's just plain Kubernetes. It's no longer Kubernetes by Google. And across this time span, it's actually been formalized into being part of a foundation, the CNCF, so you have sort of a neutral body if you're wondering whether you could or should contribute. This isn't just a Google thing anymore, it's so much beyond that. Now, if you want to get involved, our most frequently asked question is, what is a SIG? So yes, Kubernetes is this big open source project, but organizationally, how does that work? And the answer is special interest groups, or SIGs for short. And these are really our collaboration forums. This is where the people in the projects get together and they're doing their shared technical thing for whatever it is. And that shared technical thing, it could be a vertical, a specific technology, so networking, storage, compute nodes, or scheduling, or something like big data. you may have that experience already. So I've been doing system software. I see all of these things and are like, oh, I could do that. Probably you have something like that that could be a natural affinity from what you've been doing as a developer or a member of the tech ecosystem. But that's not always the case. You may be interested more in some horizontal. We have people who specialize in scalability, or we have people who are senior devs who are architects. You don't just have to approach Kubernetes as a newcomer who's new to software development or new to Kubernetes. We have a need for skilled, experienced people too. There's a need to define architectural questions and problems and drive those towards actual solutions. And then there's things that span the project as well, like testing and release and documentation. Those are also a big need of area for contribution. So what are the SIGs? This is especially for people a little bit further back, but regardless, this is like an eye chart. There's a document online that shows all of the SIGs. But I like to call this out because there's a ton of them. This is just some of the A's. It's in alphabetical order. API machinery, apps, architecture, authentication. And you see chair names next to those. Those are people who are sort of involved in the leadership of that technical area. But then you also see contact information. Each of these groups has a Slack channel. You can go hang out there, ask questions, answer questions. There's a mailing list, similarly a place to ask and answer questions to start getting involved. And then there's regular meetings. All of our SIGs have this openness where they regularly meet on Zoom. The meetings are open. You could dial in, listen. And then they're also all on YouTube. So if you're coming as a newcomer and you're like, wow, there's just like this 5-year plus history of complexity, how would I ever approach that? You can actually go back and watch some of the prior meetings. Or if you're coming at it from a specific technology area, like, hey, I'm interested in this new networking feature. Where is it in its development? And I wonder if they've thought about this particular problem that I've run into in industry before. You can go back and read the meeting minutes. You can go back and look at the Zoom recordings on YouTube and really get a sense of the design thinking. And within that, you may even see gaps, and you might want to then use that as your entry path to start a discussion and start becoming a collaborator within that. So a bunch of SIGs, all sorts of different topics. There's a cloud provider that covers different actual providers, so sort of an umbrella is what it's becoming. So it includes things like VMware underneath, or Google's platform underneath, or Amazon's platform underneath Kubernetes. And the little kitty there reading the newspaper is a reminder that docs are a thing. Even if you're just using Kubernetes, you want high quality docs, right? But somebody has to write those docs, and there are people who are specialists in documentation, or as a newcomer, you're almost guaranteed to read the docs and find something wrong. This is a high velocity project. Things are changing. There's a lot of complexity. Or even if it's not wrong, it's just unclear. This can be a great entry point to open an issue ticket, or even if maybe you know the answer, open a pull request against the documentation and give something back, improve the ecosystem for others. And then if you know another language, the docs started out in English. We're talking English here, but the Kubernetes community now has meetups all around the world. We have a conference in China, a conference in Europe, and we're getting more and more people coming in and translating the docs, localizing them into other languages. And that's a huge amount of work. But it's something that if you're reading the docs and not loving them in English, or have peers who aren't as good as English but know some language that you share in your work environment, this again is a great place to contribute. Networking node, talked about that, other cloud providers, the release-focused SIG that I'm involved in particular. Tons and tons of SIGs, all sorts of stuff going on. It can almost be sort of like mind-blowing, eye-popping, hard to wrap your head around. And then it gets even more complex because there's a whole bunch of sub-projects within each of these SIGs. There's working groups also, and there's committees. And as you think about all of this complexity, you might start to question, well, like, how does this all come together? Like, what is the governance, or what's the glue that fits this stuff together? Because SIGs aren't necessarily governance for the project. They're specific topical areas. So we also have a steering committee, and it actually doesn't say a whole lot about the details of the governance, and they really try to defer to the SIGs. They're kind of like a lazy governance system. So we got our lazy cat there. So if you don't have a whole lot of command and control from the top down. Things are going to be a little more federated across the different SIGs and areas, and it's a large and rapidly growing project, right? Like, so here's some statistics. That's a graph from a tool we have called DevStats showing contributions just going up. I went through Git yesterday, and the year preceding yesterday, there's over 2,000 commit authors have generated almost 25,000 commits in the project. There is a lot going on. And then we also track broader contributions, and this is a thing that you could think about as maybe a first engagement step. Just opening an issue, that's something that we track. Or seeing an issue and putting a little heart emoji or a thumbs up in GitHub on it. Like, we track all of those. 15,000 people nearly have done some type of contribution like that on the project in the last year. And there have been over 500,000 GitHub events of that sort. So we've got a lot going on, right? But that could lead to a little bit of chaos. You don't want to be the cat on that little thing there. So we still need to have quality and some type of a schedule, and this is where SIG release comes in, and that's what I've been focused on a lot this last year. And I like to quote our mission statement that, like, as you think about all the different types of users of Kubernetes or people who operate clusters or being a developer contributor on the project, you need high quality releases on a reliable schedule, and that's the goal of SIG release. We don't want any of those personas there to have just this crazy wild ride. So I talked about cross-functional areas, and I like to highlight these in particular. A project this size has to have a lot of effort going into testing. For something that's becoming, like people say, the Linux of the cloud, this big abstracted underlying layer for all of the stuff you're doing in the cloud, it's got to have good docs. You can't just deploy and run that without having a lot of knowledge documented. And you need project managers, people helping glue all these different things together. You need a release cadence, stable release branches for security updates, and you need an overarching architecture. And one of the things that I really love about this community and that really helped me get involved in it is that there was a conscious decision to care about the contributor experience. So if you're thinking about becoming a collaborator, getting involved in giving back to Kubernetes, we try to make sure that you have a positive, efficient experience in that, and there's a SIG dedicated actually to that. So across all of this, I really hope that you can take away the sense that whether you're a new developer, like somebody new to industry, or you're an experienced developer, there could be a place for you within this. And whether you're new to Kubernetes or experienced in Kubernetes, also there's possibilities. So I mentioned that I was an org member. So nowadays you have to be a little cautious. So everybody's got stuff on GitHub, maybe it's Travis or Circle CI. Somebody submits a PR to your project, and it's not a legitimate PR, it's actually something that's a cryptocurrency miner or something like that. That's kind of our lowest level worry on the project. So if somebody, just a random GitHub person, proposes a PR, we don't run automated CI on it. Unless somebody who's a member glances over it, makes sure, like, yeah, this is real, and then gives it a label on GitHub that says it's okay to test. But once you've been around and doing some things for a little bit, you can demonstrate that you're an active contributor, and you get to the next level on this ladder, which is membership. You have somebody that vouches for you and says this person's here, they're active, they should be considered a member. And the sort of the first badge of honor you get is your PRs then automatically get CI run against them. So that's kind of cool. But if you're already in the project, you also still have this roadmap of places you can go as an engineer or a contributor in your sort of career within the project. We need people who do reviews. If you imagine these 20,000 commits, somebody had to look at that and say whether that code was quality or good. So it can be a bottleneck if we don't have enough reviewers. Skilled engineers can look at code and do these types of things. And you don't have to formally be like told, hey, you're a reviewer. You can just show up. This is all on GitHub. It's an open process. Ask questions. And then eventually, if you've been doing that type of thing, you start to be recognized as a leader in it. We have a formal approver status, and this is documented in what we call owner's files. And when you say code is ready to go, you approve it. It's actually approving for merge because you've been given that authority. And then we have folks also, the next level of leadership, people who are doing that top level organizing around the different SIGs or projects. So if you approach Kubernetes, one of the first hiccups we have, so you understand what a SIG is, you've decided to make some sort of a contribution somewhere, you make your PR and nothing happens. Somebody's been assigned to review it and it just kind of sits there. And if you did this today, this is probably what would happen, like literally today. Because we have a release cycle. We make 4 releases a year in the project, and as we do that, we have sort of a stabilization period. So we go through some upfront enhancements, definitions in this, and eventually we draw a line and say, okay, enhancements are frozen, this is the content that aspires to be in the release. And this maybe sounds a little bit waterfall-y model, but it is much more agile. These are just the things that are potentially going to be in the release. We do have kind of a deferred commitment. Eventually what's ready is what makes it into the release. So then enhancement work's going on across the span of a couple months, and then we hit a code freeze. And this happened yesterday. So we're 17 days, I think, from the next release for 1.14. And over those 17 days, we really want everybody on the project focused on bug resolution and ensuring high stability of our tests. So if you open up a PR today, even if it's something relatively simple and you think, hey, this ought to merge really quickly, it might not merge right now because our master branch is frozen. And then around the 12th or 13th week, depending on the quarter of the year, we actually make our release and we reopen the branch to normal development. So you kind of have these phases, figuring out what we might do, getting that stuff done, and then ensuring quality. And ideally, all of that's kind of going on in an open source way. You can come along and make a proposal for an idea at any point, not just during this initial phase. So if you want to do that, we've just formalized, as of this release cycle, a process for this. It used to be much more ad hoc and what you might, the way you might experience in a smaller project, where kind of anything goes and it's a little chaotic. But we're getting past that whirlpool and having a much more formalized process, and it's called the Kubernetes Enhancement Proposal Process. This is more than just GitHub projects, so yes, we're a GitHub-based project, but if you use the project boards on GitHub, those don't necessarily track the lifetime of an idea very well. So what we've done with the Kubernetes enhancement process is to do this with a PR workflow. You get some benefits from that. You see people's design thinking as the idea goes through review and is eventually approved for being an implementable KEP and starts to move on to implementation. But you build a history of that rationale and design thinking over time too. And like I said, this has been required as of the current release, and it's good. It's not done. We still need to add rigor, but this is a great sign of maturity or maturation, I think, for the project, that we have ways to better formalize quality software engineering. And this is also a great opportunity as someone new to the project or trying to get involved. Read a KEP. Maybe you don't feel confident to submit a review on it, but read it and think about it, kind of do a review. And maybe within it too, you get some ideas like, hey, that's something that I could do. I could help implement this. I'll watch and see when it becomes implementable. I'll volunteer to be a contributor on that particular KEP. If you've seen Python PEPs or OpenStack blueprints, it's a similar sort of concept. But maybe compared to OpenStack, we try to have a faster velocity on this stuff as well. And these are living documents. You'll see even a sort of approved KEP is going to be getting edited as time goes by and tracking status, tracking changes to the thinking. Because often as engineers, we go and start implementing something and realize our design was maybe a little wrong. So we refine that. More day-to-day, you're going to encounter as a developer what looks like a kind of normal Git or GitHub workflow. But we have this really unique thing called prow. And like any project on GitHub, you'll see a lot of labels on issues and PRs and the status. What's really cool about prow is that it's adding a layer of automation. So you get GitHub events that drive jobs. And those jobs could be test CI, or they could be things like controlling how a issue or PR works through the issue or PR lifecycle. So we end up through prow with something that's kind of like RBAC in terms of how reviews and approvals work. There's a mechanism. You open up a PR and automatically you're going to get a robot that comes back and says, hey, I suggest these people would be good reviewers for this. You also get CI testing automatically, and then as review happens and CI results come in, these are all adding labels automatically through Prow to a PR. And we've really worked as a project towards getting our quality criteria codified. So this helps as a new contributor because it can be hard to know whether your code was good or why hasn't it merged yet. But we've tried to automate basically all of that. We don't have a merge button that humans press on PRs. It's the automation, and when a PR is ready to merge, the automation will just merge it. So that's cool. But it begs the question of stability. And as a new contributor, this can be one of the hiccups that you'll run into as well. Kubernetes is a cluster orchestrator. This is a big, complex piece of software. How do you test that? Maybe if you're making a small, simple change, you can run a unit test. And this is all Go-based stuff, so you have your standard Golang unit tests. You can run those pretty easily locally. But if you want to do an end-to-end test and see, did I break the cluster functionality, you need to set up and run a cluster. And not just set up and run a cluster, but you need to set up and run a cluster with a specific commit of code. And that gets more complicated. Prow at least gives you some automation around that if you push the PR to GitHub and you're either an org member or somebody glances over your code and says, yes, thumbs up, we can safely test that. So you move sort of from local test on your laptop to something that's more in the cloud. And then we also have time-based testing where kind of at periodic times some larger test will run. Because your PR pre-submit, you want that stuff to happen quickly so developers get fast feedback. But other things like, say, a scalability test on a 5,000 node cluster, you're not going to probably run those on every single commit. And if they take 3 days to run, you're going to need to kind of stage things in and run them later in it's like nightly testing type of a scenario. But people will run into this initially because we also have a lot of test flakes. And the pictures at the bottom are showing a tool we have called Test Grid that gives a readout of health. And you'll see failures that sort of ripple and flicker through because some test isn't really a deterministic test. And as a contributor, this is often a first pain point. I know my first pain point, I found an URL that was incorrect. At 404, it went nowhere. Pretty easily, I found where it was supposed to go, and I submitted a PR to update the docs. Yay! Immediately, it failed on the test. Like, well, this is non-functional code. How can the test fail? Well, tests are flaky. So this is a bit of a hurdle as a new developer, but it's also an opportunity. I like to look at all of these things as opportunities. Say you are skilled in testing. You're a QA engineer. We would love to have your help. There's test design, there's test implementation that could use being made more robust. So that's day to day, and I talked a little bit about kind of quarter to quarter in a release, but there's also a release lifecycle or lifetime. So the 1.14 release is going to come out at the end of this month, and we will give it 9 months of community support. But that means it's followed on by a next release. 1.15 will be ramping up here fairly soon, and it's got its support life cycle, and this is just constantly happening. And again, this is an opportunity. As you start using Kubernetes more, start contributing more, each new cycle in this could be a new point for you to sort of level up how you're engaging or contributing. So we give 9 months of support to 3 releases. So right now, with 1.14 coming out, we have support for 1.13, 1.12, and 1.11. There's discussions around changing it, but I think, again, that's a place where major changes require a different level of staffing and engagement in the community. So it could be a opportunity to engage as well. We have a branching model. We've been asked about this, but it's fairly straightforward. We mostly develop on master, and if you're contributing things, you should always make sure your code is applicable to current master. But at times, like right now, as we're preparing for a release, we have a stabilization branch that will be the support stream for that we've forked off. And it's mostly just something to be aware of. Now, I bring it up, though, because as another area of opportunity, we have a really good development feedback cycle, I feel like, in the project. We have all this automation that runs on the Kubernetes repo and GitHub. Each build, each commit, you're getting CI feedback, and this is awesome. It feeds a bunch of automation and good stuff happens. But we have a split. As we make a branch and we go to release the project, we actually use different code right now to do that. And instead of mostly being automated, there's a bunch of manual stuff here. So this is kind of a classic split, I feel like, in software development and release engineering, that you have this dev flow and production flow. And it's becoming a fairly universally recognized bad thing to do. You want a single flow. So this is an area of opportunity if you're a release engineer to maybe get engaged as we try to modify this workflow to get something more like this, where you have one flow that's about building and testing and staging and publication, and periodically across that you have points where you do testing and are ensuring in a deliberate, consistent way the quality of the project. This doesn't exist yet. We have the prior slide, so there's a lot of code that needs written, a lot of tools that need invented, things need pipeline through automation. So again, there's a whole bunch of opportunity here for people to get engaged. There's simple tasks here if you're a new developer or new to Kubernetes, or if you're a skilled developer who really understands release engineering or DevOps or GitOps, there's a lot of opportunity, and we would love to have you contributing here. I've talked a little bit about testing. We have one large repository, github.com/Kubernetes/Kubernetes. But that monolithic repository is slowly getting split out into more repositories. And that adds some complexity as well. Both as a developer coming to contribute, you don't maybe know where to contribute because Kubernetes isn't just this one thing. But also when it gets to testing. So this is the kind of the classic picture. It's a bit out of date at this point, but what Kubernetes running looks like architecturally. You have some control plane nodes, or what used to be called master nodes in green, where you've got your API servers, your scheduler, things like that are the control plane. And then you have a bunch of nodes where actual work happens. Pods get deployed there, pods run there. This is fairly conceptually easy. Like, you could understand this, you could imagine how you might integrate and test this. And like I said earlier, if you're going to develop and change something, you have to test it on a running cluster. This you can conceptualize. You might be able to think, I'm modifying this part, I can understand what it's going to interact with. But the reality today is actually more like this. This is the CNCF's landscape, and this is actually a dated one. There's a whole bunch more boxes on it. This shows a whole bunch of different projects and products in the cloud-native ecosystem that interact with Kubernetes. So how do you test this? How do you do integration tests? And how much do you need to do? And this is a big challenge for our community as we try to figure out how to scale. If we're high velocity, we can't also be highly broken. We have to be able to work with this stuff. We have to ensure stability and prove stability. So again, like, making sure I keep some kittens in the pictures. This isn't quite a kitten. And this could be the kitten that's eating you for lunch because you're overwhelmed by all of that complexity. Or it could be the, like, I am a lion, hear me roar. Like, this is opportunity again. There's all sorts of technical challenges here. And regardless of where you're coming from, skilled developer, early career developer, or new to Kubernetes, or somewhere along a journey with Kubernetes, even maybe just having deployed it and using it, or working towards using Kubernetes in production, all of this is an opportunity where you could give back to the project, give to the project to help make it better in these different areas. So I've talked about the release lifecycle. The release for 1.15 is going to start ramping up its release team soon. And if you're one of the many cats in the Kubernetes sandbox, you've got all these little puzzle pieces that you're trying to figure out, and you're sitting there maybe overwhelmed. I like to encourage people to look at the release team. Now, obviously I'm biased because I work on it, but we have a set of roles and leads within those roles and shadows. So the shadow roles are a place where you could learn about something new, and ideally over time our shadows start to take over the lead roles, but this is sort of an entry path onto our ladder within the contribution. So we're a team that meets regularly. We're trying to look at the state of things coming into master, the stability of features and enhancements, all the bugs going on. But I like to say we don't do real work. that's done by the SIGs. SIG release is about trying to figure out where there's gaps, where there's problems, and generate focus there. So we might have to go to any or all of those SIG meetings, all the different SIG channels, mailing lists, kind of have our eyes on all of what's going on. And it can be daunting because you've got 25,000 commits going by, or I guess a quarter of that in a given release maybe. So there's a lot going on. And it can be, you can approach it as sort of a negative, like the only time you reach out and talk to somebody from this team is because they have a problem. You're always the bearer of bad news. So we try to do this with sort of a sense of humility, but also a sense of fun. And as much as I've had the cats, and our current lead, Aaron Krickenberger for 114 is Mr. Cat. He's always got cat shirts on. I've got a token dog in the presentation for the dog people in the crowd, and ironically it comes from Aaron's Slack presence. It's "This is fine dog" with a rainbow saying, "This is unbearable." So we're at times a little goofy fun, but we try to have some levity in what we do so that we're not always the bearer of bad news and bad tidings, and we try to be a reminder that there's a human process here and a human element, and you have to keep things real in that sense as well. So I want to just kind of briefly go through the specific roles on the team. We have an overarching lead, and I was the lead for 112's release, and each of these leads has a shadow. And there's somebody who focuses on features, or now called enhancements, somebody who's looking at the CI signal, or managing our test infrastructure, doing triage on new incoming bugs, managing the branching and the flow of patches between our master and our stable branches. Somebody who's in charge of getting all of the new coming enhancements properly documented out on the web at the time of release. Pulling together release notes, and also doing communications. We're a big project now. When we put out a new release, the press wants to interview people, and as an open source project or as an engineer, prior to getting involved with this, I'd never done an interview. It was something new to learn, but it's actually a discipline, and we have people who know how to do PR, and they help us on this. So as a lead, you're sort of a cat herder. You've got a whole set of cats on every release. And like I mentioned, we try to have shadows who move up to become the leads in the next successive release, so that we don't have burnout, that we have something that's a sustainable, long-lived process here, that we're spreading the load and spreading the work. So my shadow from 112 moved on to lead for 113, and a variety of others did as well for 113. Again, from 113, various people moved up and contributed. For 114, now being led by Aaron Krickenberger, and this happens repeatedly. And it's a chance maybe for you to get involved and to grow what you're doing, grow your impact in the community, give back as a corporate consumer of the project. All of these things are really beneficial and drive sustainability of a project and an ecosystem in open source. So maybe you want to be one of these cats. If so, let me know. Contact us. We'd love to hear more about you. So that's kind of my main message, is like, get stuck in, figure out what you could do, give back. The 115 release team is about to start forming. Maybe this is a chance to contribute, or maybe having learned about this maybe for the first time right now, just be aware that it's happening. Watch. Maybe you'll see some opportunity where there's some particular issue. Especially over the next couple of weeks right now, Aaron's going to be pulling his hair out trying to figure out, like, is the release on track? Where are the problems? And there's always some particular problem on any release. For my release, there were some scalability problems. And that's a key area where we could use help. If you're a performance expert, lots of opportunity there to get engaged. The release before mine had some issues where just before we released, we had an embargoed CVE come in. And that threw a monkey wrench in all of the timing and planning. The fall release in December similarly had a CVE that came through. So our security team, which I haven't really talked about here, is similarly going through this process. A year ago, there were sort of 4 people who were handling security for the project, but we've gotten much bigger and there's more eyes on the project. It's becoming much more business critical. That team also needs to grow. So if you have a lot of experience in security lifecycle management, security auditing, threat modeling, those are all things where we could use contributors, and there's a sub-team focused on that work as well. And to sort of circle back around to contributor experience, this is kind of why I give the talk. Earlier in my career, I was a heads down developer engineer, but as I've progressed, I've started to realize that a lot of this is about human factors, that there's more than just code. There's a bunch of other disciplines as well beyond the human part. So as a leader in SIG release for this project, I need to think about those things, and it then sort of drives me back to the contributor experience side of things. What can I do to make this easier for people to approach? So if you have skills in these things, project management, documentation, testing, release management, communication, these are all areas that you can make a dramatic impact on this community or other open source communities as well. Or as a corporate member of the ecosystem or consuming Kubernetes, maybe you employ people with these skills. As you head back after the conference to your office, maybe you give somebody a poke and say, hey, maybe we should be giving back more to open source. Maybe we should be giving back more to Kubernetes. There are these specific needs. We should get involved. We should collaborate. So I want you to all leave with this kind of call to action. There's a real opportunity, both for individuals who are engaged or companies who want to improve the health of the software they depend on, give back to the ecosystem. Like I said, we try to do this with humility, where we like to have fun. We use a bunch of crazy emoji on Slack. So hopefully if you try to engage, you'll hopefully have a positive experience and find us welcoming. So that's basically what I wanted to share. Thanks to my employer and the foundations that are involved, my contact info. Feel free to reach out if any of this resonates with you. And if you have questions on this, obviously a lot of broad information on how we do software engineering, we'll run around the mic. And while the mic's running around, I'm gonna, in honor of our code freeze yesterday, I'm gonna roll a little video.
Hello. Hi.
Mm-hmm.
So, I mean, this could be a very basic question. So there are around like 67 repositories in Kubernetes, right? Like client-go is one, kubectl, etc. And then there are like 47 repositories in SIG, in Kubernetes SIGs, right? How are they? Do they have any relationship, or are they not?
Yes, the relationship can be hard to find depending on what the particular thing is. There's a huge umbrella. GitHub.com/Kubernetes is the org, right? And there's a ton of different repos under that. And then there's that whole peripheral of stuff. So like if you're looking at Helm charts or Envoy or Istio or different things, those are also in different places. So when you deploy a cluster, you have all sorts of components. So those are potentially scattered to the wind. Within Kubernetes itself, if you look at our master SIG list, the SIGs have their own sort of landing pages, and from those landing pages are references to their sub-projects and repositories. And we're working more towards having that codified some, and maybe eventually this is all clearly in YAML and things are more relatable. But as you get split out from the core, the dependency tracking and relations are a little harder to figure out. But this is something that you don't have to stress over. Like you could just hop into a Slack channel and ask a question, and people will help you find the things you're looking for.
Yeah, I mean, most of them are busy, right? Like, I've been involved in few of the SIG channels, like Cluster API is one. But it's very hard to figure out what that group is really trying to do. Then you have to go search.
Yeah, if you're trying to kind of recreate, like you come in as a newcomer, like understand what's going on right now. More than looking at code, like code is for computers, and people aren't necessarily going to consume code from the beginning. So like show up at the meeting, see what people are talking about, what they're doing. Do that for a few weeks or for a month. Read back through the past meetings notes, and you can build a sense of what's going on. And those notes are going to be littered with hyperlinks to repositories and issues and PRs. And you can sort of start to orient and understand what's going on. And this isn't necessarily unique to Kubernetes with its variety of repositories. Like if you're wanting to get involved with Linux, you have the same thing. Code's all over the place, artifacts are all over the place, and you have to kind of come and know that you don't have to just work on bugs or read the documentation or something for years, but show up and kind of do your due diligence and homework and look at what's there and how a given group is operating. And you'll pretty quickly get a sense of it, I think, and what's going on. And within that, a bunch of opportunity because as big as this project is, there is so much going on that there's bottlenecks all over the place where the bottleneck is people. We need more hands on deck. We need more skilled people doing reviews and contributing code.
So Tim, what do you think of this piece of advice? So personally, I'd suggest that rather than going right to the code, that you go to figure out the SIG structure and what SIG you might be most interested in, and then go look at the meetings. Now, the meetings are on Zoom, but they're also recorded on YouTube. So you can go look at the last few meetings up on YouTube and just watch those meetings for the flow of what's going on. That would be kind of where I might lead people. What do you think, Tim?
Yeah, I think our most frequently asked question is, what is a SIG? And after that, it's, how can I get involved? And for me, what I recommend to people is, like, go to where you have an affinity. If your affinity is networking or storage, like, go there. And go there means, like, subscribe to their mailing list, which is a Google group, and that automatically is going to cause you to have a meeting invite sent to your calendar. That meeting invite's going to have the Zoom information. It's going to have the agenda and minutes documents, and from there you can read back through years of discussion. You'll have links to playlists of potentially years worth of Zoom meetings every week or two, or more often depending on the type of thing. And you can, with a few hours even of sort of research or reading, you can kind of build a sense of what's going on in the project and where their needs are.
One last question on the releases. From a Kubernetes point of view, we clearly know, like, it does 1 year life cycle, you have 4 releases a year, and etc., right? But for all the 6 projects that are going on, it's not very clear when are they going to actually be in alpha or in beta stage, etc. They say it's still in development, but sometimes it's very hard whether can we use that projects in a code for our use cases.
Yep.
That question actually prompts whether to go and use the project or not.
Yeah, so kind of from a consumption standpoint, how do we know whether something is ready to be
I even
used?
asked questions about it, but there's no answer to it.
As much as this is a super high velocity project, it's also open source, and I think having been around open source for 20 plus years, there's this fallacy that open source and high velocity means, like, if you want something, you'll get it soon. It's more like a birthday paradox, or the inverse maybe of that, where anything that you care about probably is going to take a long time. In aggregate, everything's moving fast, but anything that was landing today is stable, done, awesome, it could have 18 months worth of history behind it where it built to that. So even though we have the alpha, beta, and like lots of things are moving towards V1 stable designation in the APIs, what stable actually means and how we demonstrate that over the long term to consumers is still fuzzy, and it's a problem. I think, though, as part of this working group around the long-term support or support term discussions, whether it's longer or shorter, like we've talked about shortening the cadence in addition to elongating it, those questions are driving this realization that, yeah, we need to really step up the stabilization effort, get all of our core APIs to stable, so that you don't have to ask the question. You know that the core is solid, and then for the other things, as they're coming through the KEP process, you'd be able to refer back to the KEP process, see when it was introduced as alpha, see what its beta graduation criteria are, see what its stable graduation criteria are, and watch the PR process as the KEP is updated to record that progress.
One fundamental problem I noticed is people are actually committing the code without having a proper testing so it's very hard to find out which release, which date actually really worked. So that was surprising to see, I mean, to find a proper release pointer, stable image on that. So what I noticed is there's no proper unit testing there. Even it's like in the SIG API repository, people commit code into it. When you try updating it, then you run into different issue. There's no like unit test packaging or something you could run to verify it. Then you have to go back day after day or somewhere to figure out where it worked, like that. I'm just sharing my concerns, so yeah.
Is there like a formal mentorship program for new contributors?
Yes, there is, and We have people you can talk to. This is Gwen
There's
Sanger.
a microphone. Oh dear. Hi everyone, I'm Guinevere. I actually run a new contributor workshop for Kubernetes folks. So if you want me to come give a talk at your event, I will come talk to me. I will be more than happy to help you out and help out the community. And I'm currently building on my previous experience to get a 2.0 workshop ready for KubeCon Barcelona as well. But that does not mean you have to go all the way to Spain. We can also just talk right here, and I can help get you started.
We've got a variety of things, both formal and informal. So there's our new contributor workshop. We're sort of bridging out from that, from having sort of a 101 level class that's basics to maybe a 201 or 102 level class. There has been an effort to build out a more formalized mentorship program within the SIGs. We're pushing for SIG chairs and leads to maybe also proactively reach out and grab some of their people who've been active and say like, hey, I want to mentor you up to and get you to a reviewer level in an owner's file because I need help. I need more people to delegate. Or take people who are reviewers, pull them up to be approvers, and work with them to get whatever skills gaps might be there or experience. And then there's a couple of other things, but if you look on the web, we have GitHub/Kubernetes/community, and within that repo, there's a variety of nuggets of information with links towards these. Or check out the contributor experience meetings. We talk about our status on these things as well. And if you're interested in giving this type of education, it's another opportunity to get engaged as well.
We have time for one or two more. If anybody has any last questions?
Aaron Krickenberger is back there, yes. We have a couple of people from various release teams in the audience here today, yeah. Mm-hmm. We also call him Aaron of Sick Beard because he has a full and luscious beard. We're goofballs, yes.
Okay, thank you for coming.
Thank you all.
we've got some seats up here in front. I think as soon as this badge comes in the door, let's get started.
Sure, whenever you're ready.
Looks like you got about 100 people in here. Okay, let's get started. Rob Bull here came all the way from New York. It's actually his first time in Los Angeles, first time at the SCaLE conference. And he's a lead engineer at Datadog who runs their data center operations. I'll let Rob take on from here.
Cool, thank you. Can you hear me all right? Cool, thanks for coming. I'm glad we have a little bit of an audience. I was a little worried with shooting a human out of a catapult outside. It's maybe a little more entertaining than computers. So yeah, let me start by introducing myself. I'm Rob, I work at Datadog, and at Datadog I'm in charge of some of our compute infrastructure. So for those of us who haven't heard about Datadog, Datadog is a monitoring platform. It's a software as a service, and we run entirely in the cloud. And so everywhere where we're running the Datadog service, I'm in charge of the infrastructure. My team is in charge of the infrastructure that runs it. So you might have guessed, we're doing a lot with Kubernetes, and I want to tell you a little bit about our experience there. But first, a little bit of background on sort of why we're here and the way that we approached it. So going back to 2016, around the time that I started at Datadog, very different place than it is right now. This was entirely on AWS, all in a single region. We're running Chef to manage our EC2 instances, and our deployments are very sort of difficult to deal with, right? It's a combination of Capistrano and several homegrown tools, and engineers are starting to realize that this is sort of a difficult situation for them, right? There's a lack of platform focus, and teams are spread very thin. Deploys are slow and they're very opaque. We don't have good visibility into what's going on while we're rolling out software. Provisioning is slow and really brittle, so we may wait 10 minutes to provision a new instance only to find out that it broke at the last step and our application isn't running on it. And this is a major pain point, especially during incidents. So when we've got everybody with their eyes on what's going on here, we can see it breaking down. Company's growing, teams are growing. It's pretty clear that the platform won't scale. And then one day we got a little bit of a curveball from leadership. They asked us to replicate Datadog. We wanted to run an EU. It's a bunch of customer asks and a sort of business case for that. That's not super important to where we are. And then they also wanted to run on a separate cloud provider. Well, this is kind of daunting. There's a lot of new surface area there, a lot of stuff that we didn't have a lot of expertise with. We were a little freaked out, but tried to look at it as an opportunity. And so this was the opportunity for us to provide a proper platform, right? Push for a big investment in setting up something that could work across both of these cloud providers, work natively for some of our stateful workloads, and be sort of container-centric at the same time. Build something that was API-driven and automation-friendly so our engineers could help themselves when they end up in situations like we had been in traditionally, where there wasn't a lot of levers, there wasn't a lot of ability for them to change the way things were working. We wanted it to meet our scale now and projected scale of the next 2 years or something like that. It was really important to us that it be a sort of self-service platform, so we didn't want this to be a centralized system where you've got to come through one team who knows how to work on it. Teams should be able to really sort of help themselves, and so that comes back to that, API-driven and automation-friendly. And our final major requirement there was that we don't want to build it ourselves. We're sort of at the core of our company is using open source. It's important for us because we want to be the best at monitoring all this software, and so we have to have experience with it. And so dogfooding really came back into, how do we use our product to build the best monitoring platform for whatever we choose? And so, of course, we chose Kubernetes, and we're bringing a lot of that feedback back into how to make Datadog good for Kubernetes. So anyway, what is this talk actually about? Well, it's a little bit of an experience report over the past roughly 1.5 years, 2 years since we started thinking about Kubernetes to where we are right now, running a lot of Kubernetes in production. What have we found that works? What's maybe doesn't work that well? What's broken? And then maybe some of the surprises that we've come up with, stuff that we expected would work better than it does, or things that we didn't think that we were going to have to think about. We'll talk a little bit about that. And then a little bit at the end, we'll dig into what I hope the future of Kubernetes at Datadog looks like. Hopefully you can come away with this knowing kind of what type of risk tolerance you need to really dive in and take on Kubernetes at the scale, and especially for us using it in ways that really not many other people are using it, or at least they're not talking about it. So ultimately, this is really just what we wish that we had at the beginning when we started this journey to see a little bit into into the future, what we were gonna have to encounter. Yeah, so getting right into it, we'll start by talking about some of the good things, what works well. And the first one is the toolbox pattern. So what is a toolbox? A toolbox is really simple, right? It's just it's a container, it's a pod that's running in Kubernetes, and it's doing nothing. You put something like a pause binary in it, and it sits and waits and does nothing. And inside that image, you've got a bunch of tools. So common places where we're using toolboxes are for something like Postgres or Cassandra or Kafka, where we might have some CLI tools in there. And the main reason we're doing this is to allow that sort of gradual steps towards being cloud native. We don't want to take all of our experience, throw it out, and start from scratch on how to run some of these particularly data stores in the cloud. We want to build on top of that experience, and so keep those familiar tools there, allow operators to keep control exec and sort of have that workflow that they're used to, or at least semi, and then work on using that, using the base API to continue to automate most of that away until we don't need them anymore. So yeah, we're sort of like trying to embrace the fact that this transition is not going to happen overnight, right? This is a long journey, and we need to sort of plan for that. Another area where we've seen a ton of success are using Kubernetes admission webhooks. And so, for those of you who don't know, what are admission webhooks? It's sort of an extension mechanism for Kubernetes, and so what this lets you do is configure the API so that every time it receives an API request, it can forward out to services that you're running to make programmatic decisions about how it should operate on a resource. And so there's two main types of that. One is a validating admission webhook, and this is a webhook that, given an API payload and operation, determines whether or not it should continue, returns just a simple true or false. And then there's mutating webhook configuration, or mutating webhooks, which take the payload and actually modify it and return a modified instance of it. So you can see how this is a sort of really powerful idea. And a couple of the ways that we're using this. We try to enforce that every workload that we run in Kubernetes has a team label. This allows us to do a little bit of like really high-level cost accounting and understand who's running what where. It also allows us to identify like when something's going wrong, what team owns it, come back, right on-call rotation and things like that. So we enforce that the team label has to be there on all workloads, and so we have a validating admission webhook that looks at deployments and stateful sets and daemon sets and ensures that the team label is there. We also enforce explicit opt-in on some dangerous API objects, and so one in particular is creating an external load balancer. So by default in Kubernetes, if you create a load balancer, it'll create the necessary firewall rules, make it accessible from the internet, wire it right up to your application, and we don't really want people doing that by mistake. And so we sort of enforce an explicit opt-in so that when we have an object that's going to create a public load balancer, if it's missing an annotation that explicitly says, I want a public load balancer, we fail it. And some of the ways we're using mutating admission webhooks, which are, I think, a little bit more powerful, are sort of geared towards making the user experience in Kubernetes a little bit more approachable. And so load balancers is another great example here. When you want to create a load balancer, all of the code to drive that is in the core Kubernetes controllers, but Many of the different cloud provider specific behaviors are driven by annotations, so they're not part of that core API. And asking users to understand across 2 different cloud platforms which annotations they want to configure their load balancers in specific ways is very complicated. We can't expect anybody to be an expert on both of these systems, and yet we're asking them to run it across both. And so what we do is we come up with these sort of groups of supported configuration, and we use an annotation like we have here, datadoghq.com/load balancer, public or private, where users can choose one of the 2 supported configurations for load balancers, and then the mutating webhook puts all the right set of annotations on those objects so that they get configured properly by the load balancer controllers. Another use case we use for mutating admission webhooks for pods, where we inject a series of commonly used environment variables. So in this case, what vault instance should the pod be using? We'll inject that as an environment variable. Our users don't need to worry about what config map, where do they have to go look and find this piece of information. It's just there for them by default. So jumping into a slightly different area, sort of same theme of how we keep the user experience simple in Kubernetes. We use kubectl plugins a lot, and this helps us ensure that users can run the same commands as we are during our automation, so it's a really simple way of bringing in more complex functionality into the toolchain that users are familiar with, and we do a variety of different things with them. So one example is the kubectl template plugin, which we use Helm, and we don't use the Helm server, and so we want to run Helm template, and we want to run it with these variable files from this configuration repo, and a variety of different things. This sort of encapsulates that all, looks in a commonly known place for that configuration, brings it all together, and gives users a consistent experience that is much simpler than what they might have if they tried to figure out what was going on with each of the individual tools. Another example is using Vault, and so we use Vault to store all of our secrets. And we don't want to have users have to figure out, a new authentication flow, a new command tool, all this different things going on when ultimately they're doing the same thing. They're authenticating with their Google account to Vault the same way they do with Kubernetes. And so we built a plugin for kubectl to access Vault that piggybacks on top of that same authentication system and allows users to interact with it through that common tool chain. So bringing together the different parts of the platform all into a common tool. And then we also try to use it to simplify the operator experience. So a lot of the stuff that you might find that users have some shell scripts in a repo somewhere that they're sharing with their different team members. SSH is a good example here. We have a kubectl SSH plugin that lets us just simply pass in a node name, and we can go in and find node names are not resolvable from DNS from our user laptops, and so we can go in and get the internal IP and SSH to them over a VPN. Sort of offers a drastically simplified experience. So shifting focus a little bit now, I want to talk about some of the success running Kubernetes itself. So one of our biggest success stories was switching from Docker to Containerd. And so when we first started running Kubernetes, the obvious choice is Docker. Everybody uses it, and Containerd is a part of Docker, and we're going to be running Containerd no matter what. And so we sort of looked at this and started experiencing a lot of instability in production from Docker, and immediately sort of freaked out, right? What do we do? So there were two sort of competing tools that we could have used, and we looked at Containerd, and because it's the same sort of base, it's the same code underlying Docker, and it's a drastically simplified code base, really much more accessible after a couple of hours of looking into it and trying to understand, how we could contribute to that code base if we needed to. We found that it was, we felt like we were in a better place than we would be with Docker, and so we switched over pretty quickly. There is a downside to that. Containerd as a standalone with the CRI plugin is much younger. So we have hit some bad bugs, unfortunately. So we worked pretty closely with Containerd, with the team responsible there. Super responsive. We found solutions to most of our bugs there. But ultimately, we see this as a huge success story. Much less surface area, a little bit less mature, but really sort of positive direction that we go in there. Next thing I want to talk about is native pod routing. But first, a quick primer on Kubernetes pod networking. So when you schedule a new workload in Kubernetes, the kubelet execs out to a series of CNI plugins that you've configured on your host in order to set up networking for your pods. And so we've got this sort of abstraction layer of CNI between the kubelet and your actual runtime. And this is what's responsible for figuring out how to get an IP address into your sandbox, right? So they configure the network, you know, the interface and routing to the pod network. And most of the time, the default setups are for overlay networks. So you've got something like Flannel or Calico, and you've got CNI plugins that are setting up the configuration there, though. When we looked at Kubernetes, we knew that we wanted to retain as much as possible native performance. And so looking at how expensive an overlay network is, at the cost of encapsulation and bridging from the host and things like this, that wasn't really a direction that we wanted to go in. It was a non-starter. So the good news is that CNI provides a ton of flexibility there. And so we put pods right on the native network. We're using PTP in Google, and on AWS we're using IPVLAN custom plugin there to set up our pods as if they're running on the VPC network, which means they're routable from anywhere, from other pods, from hosts, even from our developer laptops over a VPN. And so this is a super powerful idea where we retain like a much simpler networking model. We don't have to think about overlays and, you know, how is the network segmented. It's all simple and flat. And we get the sort of performance and simplicity that we want when we're thinking about the network. I'll talk about the control plane a little bit. So the Kubernetes control plane is 4 main components. The first is etcd, it's a data store. Then there's an API server, scheduler, and controller manager. Right? On its face, it looks simple enough. It's just 4 components that you run. There's about, I don't know, 100 controllers running in the controller manager, so it's a little bit more complex than that, but you know, relatively simple to understand. By default, they all run on the same host, and so when we started doing some scalability tests, we found, you know, scaling up from 100 to 4,000 nodes in a cluster within a few hours. We realized that there's quite a lot of contention between those components running on the same host, and so the good news, though, is that that topology is very flexible. We're able to pull out each of those components onto their own hosts, and so that means we've got a separate host with the scheduler and controller manager. Each of those is leader elected, so there's only ever one of them actually performing any work at a given time, but it does provide the isolation, and we're able to scale them independently. And then we've got a sort of fleet of API servers. In this diagram, we're looking at 3, but we're able to scale them out horizontally. And then, you know, a 5-node etcd cluster. It's pretty easy to scale out the API server. There is a little bit of a caveat that it keeps the entire etcd data set in memory, and so while you can scale it out horizontally, you also need to scale it up vertically to at least the point where you're able to keep that full data set. You have enough memory there. But otherwise, you know, this is a pretty ideal setup. Things just work pretty well. Okay, on to the fun part now. What's broken? Some of the stuff that we're a little bit surprised about, you know, some stuff that we had, you know, we faced some challenges with. Load balancers, they've come up a couple times already. So load balancers are really tightly integrated in Kubernetes. You know, sort of basic cloud provider load balancers are routed using kube proxy, so it creates a node port, hooks that up to a traditional load balancer, routes the traffic from the node port on a host to pods, and all of this is just sort of part of the base Kubernetes model, right? There's one way where we can control the way that routing happens, and that's with an external traffic policy, and for that there's 2 options. With the cluster external traffic policy, every host in the cluster that's running kube proxy is receiving traffic from a load balancer, and then they're load balancing that traffic that comes in on the node port to the backends of the service within the cluster. And with the local policy, what this means is that every kube proxy in the cluster that doesn't have an instance of the application running on the same host as it will fail its health checks. And so that allows us to make sure that traffic coming from the load balancer to a host is not then incurring a second hop to another host, which has an instance of the application. This is still super complicated, right? This is kind of what that looks like, right? We've got a lot of traffic coming from a load balancer going to this 3rd node down here and jumping back up to the 1st or 2nd node where there's an instance of the pod. We've got a lot of complex behaviors through node ports and, you know, IP tables rules to configure them. This is a super difficult thing to explain to someone who's used to giving an instance group back by a load balancer and have it just work. So the good news is there is a better solution. Sort of idea of pod native ingress, and what this means is that traffic from a load balancer is directed directly to a pod IP, rather than going through a node port, rather than dealing with the routing cost on the host. Of course, in this case, we need to have the sort of predecessor there of native pod routing, where pods are available on that network. And it also requires an integration with load balancers, which is available on both Google and AWS, but I don't know about elsewhere, that allows you to put sort of IP backends on a load balancer as opposed to traditional instance groups. So we're using, this is called network endpoint groups in Google and target groups in AWS, and we're able to basically have load balancers that forward directly to our pods. Again, like drastically simpler network configuration. People are able to understand what's going on here. The downside here is that there's no support for TCP load balancers for this on either of the cloud providers that we operate in, and so we're working on that right now. It's sort of like a gray area of what the right abstraction should be. Should it be driven by custom resources? Should it be driven by Kubernetes core API objects like the core load balancer stuff is driven right now? But yeah, so that's kind of where we are. Closer look at what that looks like, where you can see traffic here is going from the load balancer directly to pods, no host routing cost, no extra hops, no traffic going to that third node where there's not an instance of the application. And so, much better situation. Cool, so another broken area in Kubernetes, or not really broken, but really frustrating as an operator, is dealing with certificates. There's PKI everywhere. The control plane, kubelet, webhook configurations, aggregated APIs, everything authenticates and authorizes the traffic with MTLS, and so that's a lot of certificates to deal with. And unfortunately, none of these systems account well for rotating them. And so when you want to rotate a certificate for the kubelet or for the controller manager or scheduler for their communications with the API server, you actually got to restart those components. And that doesn't seem like a huge deal, but when you're in a period of sort of high traffic and you've got to restart your controller manager and fail over to the other one, like it's not great. You start watching your SLOs. And so, really I think etcd handles this really nicely. Every time, because it deals predominantly with long-lived connections, every time a new connection is established, it reads its certificate and private key off disk. This was always like the time to optimize it has not come yet, and so I think that's like sort of a great example of wishing that we had that kind of ease of use in Kubernetes in most of these components. What can we do about it? Well, unfortunately, not much. We've got a lot of careful orchestration to enable rotating things, and so we're taking API servers out of rotation from a load balancer before we're bouncing them. We've got to fail over the scheduler and controller manager carefully, and we want to do this as often as possible because we want to exercise these code paths. But at the same time, there's that downside of impacting production performance, and so this is kind of the best we can do right now. There's good news is that there's several issues with work in progress, and so hopefully we'll get to a point where that core client Go can rotate credentials a little bit easier. So I'm going to jump in a little bit and talk about kind of the ecosystem, not Kubernetes core. The ecosystem is really dynamic. There's no shortage of people who are willing to engage and get really excited about all the different use cases and all the different things you can do with Kubernetes, and so that's been really awesome. The downside is that we found a lot of these components lack production use at scale, and so a couple examples here are the autoscaler, the cluster autoscaler. When we're using more than 50 node groups, just sort of crawls to a halt. We've got like 10-minute sync loops in the cluster. Our users are saying, hey, am I actually going to get the nodes I need? Is it going to scale up, or what's going on? And then, of course, like often when we're looking for auto-scaling, it's probably because of a traffic spike, and if we don't scale up in time, we're going to have an outage, and so that's been a little bit lame, but we've been doing a lot of work there to try to improve the performance, and anticipate that we'll be doing a lot of work upstream there to sort of improve that situation. External DNS is another one where we had very long sync times on some of our larger clusters. It's sort of like the default configuration when you install this is to create records for every service in your cluster and every ingress in your cluster. And as it turns out, in large clusters, that's not great. And so we've had to sort of pare that down, and also looking into doing some work around making that based on informers rather than a sync loop. And so hopefully end up with better performance there. And this is just sort of like core things that are maintained by the Kubernetes community at large. There's this whole other area of like things that are popping up every day that are Kubernetes native in somebody's weekend project because it's so easily automatable and so sort of like approachable. And it's really easy to find something that, it looks like solves your problem and has 20 stars on GitHub and you think it's going to be great, and then, realize that there's no actual humans behind it and it's a disaster. We found several of these things deployed by some of our users into the clusters, and so the lesson there is sort of like carefully vet your dependencies. Don't put things with 20 GitHub stars in the sort of critical path of your applications in production. It's easy to do by accident, or have a user do it because they have this power, and it's not great. So be careful what you pick up off the shelf. Cool. So I'm going to move on to next section, which is about some of the surprises or stuff that we expected to work differently or be easier or just sort of like work by default in Kubernetes, and it didn't. The first one is about cargo culting. And so, whenever we're working with new technology with teams who are not experts on it, which I don't think any company can say that all of their users are experts on Kubernetes or containers at all. We've got this sort of tendency of engineers to go and find solutions to their problems. And so what we're looking at here is an example from when we first started recommending that toolbox pattern. And we recommended the pattern without an explicit example of it. And so one of our engineers went to go try to find a solution to it and found this, the top Stack Overflow post. This is not how you get a container to do nothing and wait. This is actually like the main cause of our issues with Containerd, where this is forking off and creating zombie processes constantly. A lot of them are holding on to file descriptors. This is why Containerd is hanging. And so there are better ways to do this. There's a well-publicized binary called pause that does exactly this in the most performant way that you can. And so, sort of lesson here is invest in training. Right? When you've got new technology, it's new for everyone, and engineers are going to find a way, and it's not going to be pretty. Just you've got to sort of define those best practices early on and be explicit with documentation and examples that go with the documentation. Don't leave your users to hang out to dry and try to figure it out for themselves. We try to use tools to reinforce those best practices. We talked a little bit about kube control plugins earlier. We try to integrate some linting and some sort of suggestive review in CI in an automated way, and then we use validating webhooks to disable or disallow some of these forbidden configurations, and alerting to discover some of them. So we've got an application that runs on our clusters, constantly looking for some of these disallowed configurations and creating alerts based on it so that we can send humans to go figure out what's going on and encourage teams to sort of modernize what they're up to. Namespace organization is another one that really bit us. So at the onset of this project, we said a single namespace is easy. Let's just make a Datadog namespace. Nobody will have to think about it. Why complicate things? We're not concerned with isolation, and so we couldn't see a need for it. As it turns out, data in etcd is actually organized by path, and that includes the namespace. And so when you have everything in a single namespace, you end up with like a very large tree of nodes in etcd, and that impacts performance pretty negatively. And so the lesson here is that namespaces are more than just access control. They're more than just isolation. They're actually pretty core concept, important to retain the performance of your clusters. And so when you have a large namespace, API responses are slow. CLI output becomes totally unreadable. When you've got 20,000 pods coming back in your requests with kube control, like there's nothing you can do there to make that more usable. We ran into several issues with Spinnaker as a result of this, with very large namespaces and deserializing those payloads that are very large. So a lot of complicated situation coming out of there. So how big should a namespace be? I mean, the guidelines, there's kind of a lot of different axes to think about here. But we found a guideline that works for us is 3,000 pods or less per namespace, and it still stays mostly usable. And at that level, like large clusters should be able to support hundreds of namespaces easily, so there's probably not going to be too much of an issue. But again, this is like really sort of heuristics. We're guessing and hoping that it doesn't break on us. There's no hard rules around this one. Cool. So user came to us one day and said, one of my pods isn't running. And so, trying to provide good support, we dig in a little bit and, we go kube control describe pod and look at the events, and we see that there's a failure there, a validating failure. And so our admission webhook is saying this is not allowed because it uses the latest tag. So that makes sense. We run an admission controller that doesn't allow using the latest tag. It validates workloads and makes sure that users are not using any dynamic tags. And this makes sense. But why is it surfacing at runtime? Why is it surfacing in a way where it's manifesting when people are scaling up? Well, as it turns out, this controller was just installed, and it was installed with a workload already existing in the cluster using the latest tag. And so, the validating webhook was configured to operate not just on workloads, not just on daemon sets, stateful sets, deployments, and things of this nature, but also on pods. And there's a problem there, and it's that humans don't drive the operations of pods. Validating webhooks are useful for driving like human-centric feedback, but there has to be a reaction, right? You're looking at this state that doesn't change without a human changing something. And so the lesson here is that validating admission webhooks on pods don't make any sense. You want to make sure that these are applying only to user-facing things where a human can take action on them, and on pods, this really, this is not the case. This is sort of unpredictable life cycle and things like this where we're getting paged because something at runtime where there's seemingly no deployment that we can point to, no changes in the system that we can point to that indicate what the problem is. So yeah, focus on making sure that you can give actionable feedback to users using these webhooks. Another sort of incident report. So we get an alert that there's a sustained increase in image pulls. Not uncommon, right? Something's going wrong on one of our clusters. We find out that there's a daemon site crash looping on every cluster in a region. And then things escalate and all of our image pulls start failing. And as it turns out, we're being rate limited by our image registry. And now no applications in the entire region can pull their images. It's totally out of our hands because we're using a registry that's managed by someone else. And so we're in full-on panic mode. As it turns out, the crash looping application was using image pull policy always, right? This is common when you're using dynamic tags like latest, where you want to make sure that you've got the latest version of latest on the host every time it runs. This is a bad idea. Use static tags, don't relabel things. This leads to a ton of unpredictability and also, an abuse of downstream systems here where when we've got 4,000 nodes all like every 10 seconds trying to pull an image, of course we're going to get rate limited. If we didn't get rate limited, we probably would have taken the registry down. And so, one way or another, we would have been in bad shape. But yeah, so lesson here is avoid dynamic tags and image pull policy always. Nothing good comes from that. Cool. Transition a little bit to some of the lessons learned we use, lessons we learned using Kubernetes and sort of some of our takeaways that are not specific to some of the more practical, technical things that we've just seen, but also like, on a sort of decision-making level, like, what it means to be an early adopter using this cutting-edge software in ways that, no one else is. One of the biggest takeaways, which we all know the answer, is that multi-cloud is hard. Even when we have a good business case for it, even when we're able to put the resources behind it, the cost is still extremely high. And we're finding consistently that features differ across different cloud providers in Kubernetes, and you've got different people interested in different feature sets. And this doesn't make it easier for users or operators to figure out how to get it to run consistently across cloud providers. So we found it like extremely important to automate that minutia. So we talked a little bit about how we configure load balancers across across the 2 different cloud providers that we're using, and we need to keep doing that, right? We need to give our users a consistent view of the API and do all the bridging work that Kubernetes is doing large parts of it for us, but we need to have even another layer that allows users to understand what they're getting across different cloud providers. We can't expect everybody to become an expert on 2 different ways of doing everything. We often end up in a situation also where we've got to hide some advanced functionalities and things like this. So this is common with, load balancers, for example, that underlying functionality is working drastically differently across the 2 different cloud providers. And so if we want to have a user-facing representation of that works the same, then that means we've got to disable some of that advanced functionality that may only be available in one place and not the other. Which is kind of a shame, but just sort of part of the deal when you want to come up with that common abstraction. Another area that has been super hard is keeping up with upstream, and we run several Kubernetes versions behind. We're still running several 1.10 and 1.11 clusters, and that's because Kubernetes moves really fast. The flags is easy, right? Like figuring out how to run the control plane and what configurations you want. That's, we can get past that, but features are really hard. When we've got new features coming out that we want all of our engineering teams to use, we have to invest that effort up front in making sure that we figure out what the right way to use those features are. Things like, pod priority or a lot of the new scheduling features coming out now. We don't want all of our teams figuring out how to do that themselves. We want to come up with one sort of well-supported way, know what all of the edge cases are, and present them with an example of how to do it. And that's extremely time-consuming, very challenging, and often means that we've got to hustle to make sure that we can provide support for all of the features that we're putting, that we're enabling on our clusters in advance before we're able to upgrade to the latest. Otherwise, we're going to be chasing down these, especially beta changes, beta API groups that start coming into use. And then, of course, like this all sort of comes together as paying an early adopter tax, right? This is super expensive, right? Progress slows down and users get frustrated. The entire org knows what kind of effort we're going through to make this work, and yet, they're focused on delivering their product and not, the platform like we are. And so, some really big lessons there are that you need to, we need to communicate a lot with our users. We need to, share the successes, but also the failures and what we're working on, what we're planning. I think this applies to all sort of software development where you've got dependencies like that, but particularly here where, the Kubernetes ecosystem is very visible to everyone. There's a really low barrier to entry, and so we've got hundreds of users within our org all using our clusters and wanting to be able to do everything that the internet tells them that they can do. And we've got to sort of pull that back and pare it down to what we can actually support in a predictable way for production. And so that type of communication is super important because they can go elsewhere and get contradicting information. As an early adopter, your sort of process needs to change a little bit too. So I think, normally when we're dealing with incidents, there's, I guess, 2 different schools of thought, right? Like everybody wants to just rely on, debug with forensics after the fact and restore service as soon as possible. Sometimes, with new software that you're not super comfortable with, or you don't know, that you're getting the right forensic data out of it, you've got to sort of step back and do a little bit of debugging in production. And so we try to limit the times where we do this, and obviously it can impact our users, and we don't do it in those cases. But, we've got to sort of change our thinking here so that we're, investing in the learning, not just in the service that we're providing. And so, yeah. Sort of process needs to change, and so let's talk a little bit about the future of Kubernetes at Datadog. So taking away from all of this, like, all the complexity and all the difficulties that we've gone through, what do we hope, or where are we investing our time to make things better? One of the biggest areas that our team struggles with is cluster provisioning and teardown, and so we came up with this rule at the beginning of our journey that we would never take a cluster and upgrade it, right? We'll upgrade it on point releases only, but we won't go from 110 to 111, we won't go from 111 to 112. And so that means that we've got a little bit higher churn in our clusters than other folks might have at the cost of a little bit of safety and predictability. and so, you know, a lot of time is going into provisioning and teardown of these. So our plans here are to run a sort of self-hosted Kubernetes, not the variety that you might find in something like Bootkube or some of these other projects where they're running a temporary control plane in order to bootstrap itself. That's, I don't think, like something that I would be super comfortable with in production. What we will do is run a separate cluster, and we'll either run that how we're running our clusters right now, with this sort of like systemd non-containerized approach, and then run the control planes for all the other clusters within that sort of meta cluster. And ideally, in the medium term, we'd be able to use managed clusters like a GKE or an EKS to run that meta cluster and remove the need for that like different infrastructure. And once we're able to run those meta clusters within a different Kubernetes cluster, we're able to start taking more advantage of the tools that we're building for everyone else, sort of dogfooding that a little bit more, feeling the same pain that they're feeling. And it also gives us a huge benefit that, you know, we're a little bit more agile in how we can spin up and tear down clusters, and you know, feeling a little bit better about that. We also feel quite a bit of pain around managing applications that are deployed across many clusters, and so CoreDNS is a great example here. We run this in every single one of our clusters. Every time we do a release of it, we go deploy it to one cluster, run a Spinnaker pipeline, make sure everything's okay, then go run 10 other Spinnaker pipelines. Inevitably, we forget one, or one fails, or something happened. And so we've got this splay of different versions of the applications running across all these clusters. And so, you know, we think we have the tools necessary to be able to solve this problem and build global deployment pipelines. You know, but this is a major area of investment for us, is figuring out exactly what they should look like. How should canaries work across multiple clusters? You know, what should a sort of progressive or phased rollout look like? And how can we balance between, you know, meeting SLOs and considering availability versus having sane rollouts that people are not waiting several hours and waiting for an alert to go off. I've got another major area of focus, and that's using a container optimized image. And so right now we run everything on immutable Ubuntu images. We run Ansible and Packer and configure them in this very traditional way. And what we end up with is nodes that are very difficult to upgrade in place. That's by design. We don't want to upgrade them in place all the time because we want predictability. We want to know exactly what's running here. But the downside of that is we lose any type of, you know, any ability to roll out changes sort of progressively. And so if we want to change a single flag on our kubelet, or if we want to change a configuration for containerd or roll out an upgraded version, you know, we're not able to do that really easily. And so what we want to do is focus on something that we can update in place, but update atomically. And so we still have the predictability of like an immutable image, right? We know what the contents of it are going to be, but we're able to roll it out in a progressive way. And so we're looking at Flatcar for this as a sort of fork of container Linux that is able to do this pretty well, and that's, you know, another major area of focus for us right now. Yeah, so that's just about all. Just a quick, you know, in summary, like, it's extremely flexible and powerful, you know, Kubernetes as a tool, and, you know, just be careful. Many parts of the ecosystem are still very immature, and, you know, it's not easy to just pick things up and run them and have it work exactly as you want when you're running several thousand nodes in production and need to be on call for them. But the good news is the community is accessible and eager to help. I mean, you just heard the talk right before here from Tim talking about, you know, how you can get involved, and it is easy to do that. But just be ready. You know, you'll have to get your hands dirty and actually put in a significant amount of effort to be successful with this. And that's all.
Okay, we got a question here.
Hi, this is about the pod native use case using external load balancer. I think you mentioned in the beginning.
Yeah.
So you try to solve the problem by directly talking to the pods from the external load balancer, right?
Yep.
By solving that problem, are we not actually exposing another problem that if pods die, then the external load balancer has to be updated with the right set of pods?
Yep.
As it's going to cause traffic loss.
So you've got basically the same situation where kubeproxy needs to already keep track of all the backends for a service and update the IP tables rules, except now we're offloading that to the cloud provider. And so you do need a controller constantly updating The good news is like you can get around that a lot by using health checks in your load balancers, and so like as long as you don't churn every backend or a significant number of backends where you're losing capacity within the window that it takes your controller to sync, you're safe. But there's definitely a lot more we can do there to make it more resilient, because yeah, right now there is a possibility that if you do a quick deployment and it's quicker than the time it takes the load balancer controller to sync with the external, either the NIG or target group or whatever, then you could remove all the capacity from your load balancer.
Yeah, thanks.
Thank you. So it sounds like you guys have quite a queue going of work stacking up. How big a Kubernetes support team do you have? So you're all, no on-prem, all in cloud, right? So
we're 100% in the cloud.
Okay, so 100% in cloud Kubernetes team. Like, how big is it, and how big do you wish it was?
We have a couple of teams that are working sort of in the area of Kubernetes, and so we have an engineering tools team that focuses on a lot of the Spinnaker and sort of delivery workflows. That's not core Kubernetes. The compute team, which runs the clusters, is 8 people right now. I don't think it should be any bigger than that. I think like we've got a sort of big hump to get over in the work that we're doing, but on an ongoing basis, I don't think we're going to continue to be innovators in the Kubernetes space. We kind of just want it to work and use upstream Kubernetes. But in the sort of user experience, workflows, delivery, stuff like that, I think we've got probably about 7 or 8 total people working on that right now, and that could easily double. I think this is a really immature area. We're using tools like Helm that we look at, we see all the deficiencies, but there's nothing better, and we would love to invest in figuring out what the right user experience is there, but it's just always going to take a backseat to like actual production needs. And so if we could put more people on that, I think that's where we would focus. Yeah.
And what's the minimum, you think?
The minimum to be successful with Kubernetes, I mean, I guess it sort of depends on if you're facing the same challenges as us, but I would say like no less than a couple of individuals dedicated to just running clusters, and that's like if you're running them in a well-supported and known way, which we're not. So, yeah, no problem. Thanks.
So you were talking about the multiple clusters within like a mega cluster. Do you have any leads on any type of software that you're going to use to manage that mega cluster, or are you planning on writing it in-house or other?
Yeah, so our first stab at this is actually just running that meta cluster exactly as we run all of our other clusters, and then using our existing tooling, which is all based on Helm, but only for templating, not using the Helm server, and just building charts for the the control planes within that cluster and deploying it using our existing tooling with Spinnaker. When we want to, we still have an aspect of like Terraform and cloud provider resources and setting up like the subnets and the VPCs and everything else that we need there. And when we move towards that, like I think we'll need to write a little bit of software that runs in that parent cluster to do it for us. But right now, we're not focused on that yet. Right? That's not the biggest pain point for us. The biggest pain point is changing the application configuration, not changing the cloud provider configuration.
Well, yeah, you mentioned that you use the Vault in
I don't know where I'm looking. Where are you? Ah, okay.
Sorry. So you mentioned that you use the Vault for storing Kubernetes secrets. Is it the HashiCorp Vault you talk about? Okay. So what's the pros and cons of using Vault versus Kubernetes secret?
So we knew we needed like a good like sort of compliance and audit story, and so Vault was really excellent in that area. In addition, there's a lot of PKI, and Vault serves as an online PKI for us, a CA, and so that was a big benefit. Whereas in Kubernetes, we would have needed to statically generate them and put them into secrets. So it was less about, how, like the secret storage is a small piece of the puzzle, and the larger piece is all the advanced functionalities that we get from Vault, and the tight integration that it has with Kubernetes already to be able to authenticate using Kubernetes service account tokens, using token review API and stuff like that. So yeah, that's kind of where we're at.
Hey, I was a little curious. You were talking about the load balancers and kind of the model that you use with the pod routing and some of the problems you're facing there. What kind of went into your decision to go this route as opposed to just having like an ingress and then an external load balancer pointing to that and then simplifying the routing? That way?
Yeah, so we actually do use ingress resources, but ingress is still ultimately backed by a load balancer, and the cost of the load balancer going through both like the mental model, the cost of understanding it, as well as the performance cost of it going through kube-proxy and node ports, I think is still like, that's sort of what drove us there. Ultimately, it's all still backed by, either way, ingress is still backed by a load balancer, and in this case on AWS, we're using ALBs that are pointed directly at pods rather than running an ingress controller in Kubernetes that's actually running like a server, an Nginx or HA proxy or something like that.
Okay, I think we have time for one more if anybody's got a last question. Looks like that's it, but thanks a lot.
Cool, thanks a lot.
market is quite fragmented, but people from the cloud space say, hey, I'm using FluentD, but for some special cases, I need something like that. And there's a special difference because FluentBit is fully written in C language. If you want to ask why we didn't wrote it in Golang, we can talk later. Or Rust. People is always asking that. And well, it had a very low memory footprint in CPU. We consume like 500 kilobytes in memory, unless, of course, you're ingesting a lot of data and your memory will go up. We support around 50 plugins, but FluentD support 800. Well, 900, sorry. So there's a big difference between the two projects that can work together also in a Kubernetes cluster and has built-in security with embed TLS and networking I/O. So one of the things to deal with back pressure is basically be aware and handle all of the details when you are sending the data out. For example, if I'm sending my data to Elasticsearch, I'm going to send that data, and maybe at what point Elasticsearch could say, hey, oh, well, we will not say anything, right? It will not respond. It will stale. But what we can do from a log processor side, because this problem of back pressure is not just Elasticsearch. It can be Kafka or can be any kind of service. Maybe your network is too slow or saturated, or maybe it's down. But you are getting more data, and more data. So to deal with back pressure, we decided a system which is pretty simple. Basically, I'm going to consume an amount of data, and this data, I'm going to try to process this data and flush this data. But if I impose a limit for that data, imagine like 5 megabytes, those 5 megabytes of data, we're not going to consume more data until those specific 5 megabytes of data are flushed. So if you think about Kubernetes, all your log or your log messages, where are they coming from? Well, they're coming from containers. But for real, they're coming from the file system, because that is the point from where you are reading the whole information. So what we did with the back pressure is just impose a memory buffer limit, meaning that I'm not going to ingest more data until my current buffer is empty. And from a configuration perspective, this is a configuration file where we are reading the container logs. We just put memory buffer limit 5 megabyte. So don't use more than 5 megabyte of RAM. And sometimes this is too much for some special databases. Some people are saying, please use 1 megabyte or just get it lower. But it's something that you can tune and you can try for yourself. And this is not to protect FluentBit. It's to make sure that your data can be delivered to the old destination. You can say, okay, you can use a database that acknowledges you that the data has been processed. But we support like 10 databases. So creating a workaround for each one of them is more hard, and it's better to just pause data ingestion, just wait a second, so a couple of minutes, and then retry again. When we talked about logging context, we said that many data also was coming from the file system, but also the API server. So how do you make your log processor to correlate all that information? In FluentBit, we have a filter, which is called Kubernetes. And what it basically does, every time that it looks up from a file, from the tail section, like this before, it goes to input filter. The filter, what it does, it goes to the master API server and query the whole metadata that belongs to the special pod container, that file that we are monitoring at that moment. And what we can do with that then is that your log message is going to get the whole labels, annotations, and information which is relevant for you to do data analysis, because that is your end. So in practical terms, it works like this. It can be FluentBit or FluentD, or any log processor in Kubernetes needs to be deployed as a daemon set. And basically, a daemon set is a pod that runs on every node. So we run the log processor on every node, and what we do is to let this log processor to consume the logs from the file system. Okay? Okay, the first part of the job is done. And after that, what we do is to go to the API server to get all the data that we care about as labels and annotations. So we have the full context for one message. And just after that, we can ship the logs out to a database. That is how it works. But as you know, if we go back, we can get problems reading from the file system, we can get problems talking to the API server, and we can get problems when flushing the data to the database. So things can go wrong in many ways, but we try to overcome that. So a simple message that started like this, after the whole login processing, becomes like this. So this is a full context. If you look carefully, there's a whole section called Kubernetes, a map key, where you have information about the host, the pod name, pod ID, container name, namespace, and so on. And why this is relevant? Because when you are doing data analysis in your database, you're going to say, please show me all the logs that belongs to pod name SCaLE 17x. Okay? So we get a notion about the context and why this is important. And also, like a year or 2 years ago, we implemented another feature, because you can say, my pod is running Apache, my pod is running MySQL, my pod is running any kind of application. And you are sure that every application has a different format for their logs. Not everybody is using JSON as a format, just a few applications. So how we can deal with unstructured data versus structured data? So we come up with a solution where now, if you're going to deploy your application, you can suggest in your pod YAML file the parser that FluentBit will use when it's processing that specific data. So you can annotate the pods, and it's very easy. So the only restriction is that FluentBit must to be aware about this parser here. A parser is just in the configuration file. And also you can make many combinations. You can annotate like fluentbit.io parser for one specific container that comes from a specific stream, or a parser for all of them, or maybe exclude. If you're going to deploy a pod just for testing and you don't care about the logs for that pod, you can enable exclude through, and that's it. So the logs for that specific pod will be skipped, will not be processed in the pipeline. Another feature is monitoring and metrics. Everybody likes to use Prometheus to monitor all your applications and your clusters, but also it's really important to see how your logging tool is behaving. So we provide a full endpoint for Prometheus so you can pull the metrics and see how it's behaving internally. If you like to do, for example, advanced filtering, you said, right now FluentBit is reading in C language. So if you wanted to have a special filter for some special case, like, or my data is all about credit card transactions, and I need to obfuscate the data, the answer a year ago was write your own plugin. Today the answer is, okay, write your own plugin, or write a simple Lua script function that you can load in your config map or in your configuration file. And that specific function is going to get the tag for the record, the timestamp, the record, and you can modify it simply in your config map and just make it return a value to replace all the values. And the performance penalty is really low, and everybody's happy about this. So if you don't know Lua, you have a good excuse to learn now. So, time for a quick demo. We will see how all this works together. We're going to use micro Kubernetes. Do you know what it is? Okay, there is Kubernetes. Do you know Minikube? Okay, Minikube runs in a VM. Micro Kubernetes is similar, but runs just in containers, and is a solution provided by Canonical. Okay? So there's not like a VM, so you can run your own single cluster Kubernetes in your computer, but using containers only, no VM. So, let's hear. I'm using K for kubectl or kube control. Ooh, me too. Come on, this cannot happen on the... Sometimes you have to wait. Patience is everything, you know? There you go. Well, it took like 20 seconds. If you spin up a Minikube, it will take a minute. So... Elasticsearch, I have Kubernetes running. I'm going to start database and process the logs from a pod and send them to a database so we can query the information. Okay, our friend is running. We're going to query the Elasticsearch indexes. Okay, we just have a Kibana information. This is how we query Elasticsearch over the HTTP interface. Perfect. And I'm going to check that Kibana it's working too. Okay. So Kubernetes is running. Right now I'm going to deploy my setup, which in that case is FluentBed. This is the daemon set file. If you want to get it, let me know later. Okay. So the container is being created. Okay. So FluentBed, it's already running. And if we query right now the indices of Elasticsearch, we will not see anything yet because we don't have any pod running in our cluster. So here I have a really small pod, which is Apache YAML, which basically emulates Apache logs. Okay, it's not Apache itself. So I'm going to deploy that one. And if we get the pods here, we're going to query the logs locally. We can see that it's generating one message every second. Okay, perfect. And now we're going to query FluentBed status just to make sure that everything is running. We have a separate namespace for the log processor. Ooh, we got a problem here connecting to Elasticsearch in my local network. So how we can solve this? Because here's running. Give me 1 second, please. Yeah, we have a problem here because inside the Kubernetes, the FluentBed is not able to reach the network or Elasticsearch, which is running in the host service. And if you see the errors here, this is a TCP connection error. So, okay, this is the cluster. Okay, we will do something here. Okay, so we're in troubles because I have a network restriction to access my Elasticsearch, which is a shame, which did not happen this morning. And at the moment, honestly, I don't know how to fix it because that was the address. Yeah, this interface, let me check. Actually, I'm looking for the address that connects my container interface with my local service, my local host. But I cannot see it at the moment. Sorry? Should I try this one? Okay. Let's change the config map. Here. Ten? This config. You were looking at the IP addresses? Oh, you say that it's running on the wireless. Let's try the wireless, right? Let's try this one, otherwise we move forward with a different thing. Oh, this is it. So I will have to open a bug with micro Kubernetes. I wanted to showcase that today, but well. Okay. So okay, we destroy our pod. We are daemon set. Ah, I want to destroy everything too. So we're going to recreate the configuration with the new value, the config map, and the daemon set. We are not sure if the pod will be able to reach the wireless interface. Oh, there you go. Thank you. You saved my day. I owe you a beer. Okay. Okay, so the logs are being ingested into Elasticsearch here. As you can see, we are being created one new file, so one new record each time. And here what I want to show you is a Kibana, which is like the graphical interface to query Elasticsearch. Let me create here. I'm going to create the index. Oh, this is a really bad resolution. Can you see something there? Yeah, okay. So if we look at the records that we're getting from the Kubernetes side, we're going to focus like in the JSON representation. And this part is what I talked about some minutes ago, is that where we're getting the logs, right, from the database, but now that a simple line like the Apache log right now have a full context of Kubernetes. But this is not, this is useful, but it could be better. As you can see, the whole log message here is a whole string. There's no structure. Can we create a structure? Can you use our annotation pods feature? Yes, we can do it. So in the same example, I have a different Apache YAML. It's the same pod, but here we have a special annotation, which says basically, please use the parser, which is called Apache. So I'm going to deploy that one. Okay. And now we're going to query the whole logs for that specific pod. Okay, these are the records for the new pod that I just created. And you will notice the difference here. There is a new section which is called PERSLog. And PERSLog contains the host name, the user, the method, the path, the code, and the size for the message that was here on top. As you can see, and why this is important? Because now we have a structure. And with that structure, you can say, please show me all the logs that parse log the host belongs to this IP address or to this specific field version of variation. So this is a way that you can use to process your log properly, and it doesn't matter which format do you have in your application. Well, if you have Java stack traces, that is a mess. It's really complex, and we cannot handle that at the moment. So I'm crossing my fingers that you're not using Java. Or at least your Java application is writing JSON maps as logs. That is a good solution. Okay. So, a bit of the internals. This is mostly development stuff. Internally, which is just a single thread, FluentBit, how it works, we have input plugins filters, and once it gets the data, it flushes data to the output plugins. And for data processing, we have different backends to process our logs with regex, JSON, LTSV, log format, and we can also look up for time resolution. All of these things are expected. It's not like all of this is fancy new, no. So if you have a log processor, at least you need to support this. And every time that FluentBit get one message from one log file, if you understand how this works, you can fix everything related to logging. Every time you get one input plugin, it consumes some message. That message becomes a record, and that record has a timestamp, meaning when it was generated, plus the message. And internally, what we do, we don't do JSON stuff internally. We just use, which is called message pack, which is a kind of binary JSON. Then the records get grouped by, which is called tag. And a tag allows you to send those messages to some special destination based on rules. So once the records get grouped, they go to the storage phase. And the storage can be either memory, or they're always in memory, but also you can use like a failover mechanism in the file system. Meaning that if I processed a bunch of logs, I have not flushed these logs yet, and for some reason I had to restart my service, my processed logs are there, and you're not going to face data loss. And after the storage phase, we go to the router, which said, okay, everything that it starts with Apache needs to go to output plugin 1, and everything else that match syslog to output plugin 2. So you can create a tag from the input and a matching rule in the output, and that's why you can send one message to the same place or to multiple places. And buffering, as said, is really important because that's where you're handling your data, and using the storage is really something that you have to consider. And for the storage layer, we have a structure which you said, well, the root path for your storage, you have a separation for streams and data chunks. Each chunk basically is a bunch of records being consumed, being generated by some input plugin. And if you want to learn more about internals, each chunk has its own format, which is basically, well, a format type, a CRC checksum, if you want to enable. Just for performance reasons, you can disable. It uses 2 bytes for metadata, the metadata, and the content from the records. This is the format of the data once it's in the file system. So if you're consuming a lot of data or you're flushing data every 10 minutes, you don't want to have all that information in memory. You want to have that in the file system, and when it's time to flush the data, you just read it from the storage and just send it out, put it on memory, and then you send it out to the database. And one thing that is really interesting, do you know what is stream processing? Please raise your hands. Okay, what is the difference stream processing with logging? Who knows? 1 beer, 2 beers, 1 coffee. The data is? Exactly. The data, okay, when you do login, you take data, you process data, and you shoot the data out. And when you do data analysis, at the end, right? After, store all your data. Stream processing is the ability of do data processing while the data is still in motion, meaning has not hit the database yet. Have you heard about Apache Spark? Kafka KSQL? Kind of similar thing. But here we're talking about stream processing on the edge. This is something really new that is not related to login, but we're implementing this and it's been really, really useful. And it's still under development, but I'm going to show you now. So the concept is really simple. Input plugins generate data. Can be the file system, TCP, or whatever. So, but right after we pass the storage phase, we can do stream processing. And that means run SQL queries over the data. That is in memory. And this does not mean that you have a database on top of that. It's just running queries on top of the data that is flowing before to go to the routing phase to the output destination. And maybe what you can do is create new stream of data using results of your queries. And how this is useful? For example, you can say, give me all the keys from stream Apache. Or select special keys like host status site from stream Apache. And we support aggregation functions for count, max, average, minimum. And you can do things really fancy like this. For example, in the first sample, it said create a stream. This is just SQL. We are going to create a stream called events that is going to be created using the whole results from this query, select ABC from stream Apache. So that means that we can create data streams using a subset of data using a query. Or also, we can say, hey, I don't want to do filtering stuff, I just want to do data processing, so please create a new stream, attach it a new tag, and use the results as if it were like a new log file or something that is ingesting data. And let me show you that really quickly. We are really we are actively developing this. So let me show you how the configuration looks like. Okay, this is a configuration file for FluentBit, really simple. The service section. What I want that you focus is in here, where we are defining our streams configuration file. Here we have an input section that we're using the plugin Tell, and Tell what it does is to read log files. And then I'm going to read the whole, so I'm going to send to the standard output all the records that match a tag called results. But as you can see here, all the tags are samples. They are different things. And here I'm going to show you a simple query which says I'm going to create, it's the first section that is uncommented, and create a new stream called temp using all the fields from the stream samples, where the ID be greater than 5. And our data samples will be this, with internal stream processor, data stream processor. This is our data samples. This is our data set that we are going to process. Okay, we are going to simulate this with this. So as you can see, this is not like tables. There's not a fixed schema, but everything has a key value, and maybe some columns are missing, and that is fine. It will not fail. So the first thing is that our first query, we are going to create a new stream called temp using all the fields. And this is commented, but what we care about is the second one. Here we have two SQL queries, and the second one is going to use the input for the first one. But if you look at the query here, we are creating a new stream called results, but we are using aggregation functions. Okay, so we have one query, it's going to process the data, and that input will be the input for the second one. So as you can see, we just got the result on the standard output up using just stream processing. And right now you can ask yourself, hey, why this is important? Okay, imagine that you have a web server. That web server is handling like transactions from credit cards. And you want to avoid that your lovely user pays the same item twice in a fraction of seconds. So if somebody makes a click in my web server and processes a transaction, I don't know, this guy maybe paid like $100 for something. But likely you want to invalidate or detect if this person is trying to pay the same amount of money within 5 seconds. How do you do that? Are you going to store all the data into your database, wait a minute, and then query for that exception? Or you can trap that within 5 seconds. That's why stream processing is really important. The other use case is like, imagine that you are getting data from sensors. This is just not cluster. Can be applied to edge devices. You have sensors, and these sensors are capturing measurements and metrics every minute. So every second you have a lot of metrics. One way that you have to calculate average and do all this processing is send the data from these devices to your cluster, to your database, and after that do data processing. But what about if you make your login tool do the stream processing for you, and you just send 1 record per minute, and not 60 per minute? You're going to decrease the load in your database, and you're going to optimize for data processing. This is really new because this is not something like, imagine that you have a kind of Apache Spark or KSQL from Kafka, but be able to send a Raspberry Pi to a Kubernetes cluster. And where are we going with this? We are going to a point where you're running your Kubernetes cluster, and you're seeing that you have some problem with some logs, but you don't want to wait until your logs hit your database because your cluster is huge. So we will have some kind of client model where you can attach to the log processor and run a stream processing query on that moment where you can gather the results while the data is still in motion. That is stream processing, and that is something that we are implementing now. Well, that was the presentation. Thanks for coming. So if you have some questions, thanks. Just on time. Everybody's going to the show. Oh, thank you. OpenShift. Thanks for the help. Oh, you have aggregation stuff, more aggregation?
Let's get started. Neil here is going to talk about the service catalog. He came down to Los Angeles from Seattle and works for Microsoft. I'll let him take the mic and give his bio from here.
Great, thanks a lot. Is this on? Can y'all hear me? Awesome, so I know it's super duper late. Thanks for coming out. My name is Neil Peterson. I work for Microsoft. This talk is on consuming cloud services with the Kubernetes service catalog, and we'll get into what exactly that means. I did put a kind of a subtitle on this just today, and that's deploying cloud distributed applications. And I'll kind of go into why I've got a subtitle there. Real quick on the agenda, and this is a full hour's worth of content. I think I'm actually going to try to blaze through a bunch of it pretty quickly so that we can, I guess somebody's going to get shot out of a cannon out front potentially this afternoon, so maybe we can catch that. But quick agenda, you know, the first thing I want to do is like talk about cloud distributed applications and really kind of lay out the problem statement as I see it that Service Catalog and some other technologies that we're going to talk about is trying to solve. So what is the issue here? Touch on Kubernetes. Is everybody somewhat familiar with Kubernetes in the room? Maybe just a hand if you've worked with Kubernetes. Cool, that's awesome. So I'm going to kind of like blaze through any kind of the Kubernetes basics, but I'll make sure to call out things to help where it makes sense. We'll talk about how we can integrate Kubernetes with cloud providers. And then we'll really dig in and look at how Service Catalog changes Kubernetes, what it adds to Kubernetes, and how we utilize that. I've got an end-to-end demo. And then I've got this section that I just added to this talk this week on alternative solutions. As we'll see, there's a lot here, but it does what it does, and there might be other potential solutions to achieve the same goal. So that said, let's talk about cloud distributed applications. And I don't have a long career in development. Really, my career has been in systems management and really particularly around deployment. So I've been deploying applications for 20 years, and it's something that I really enjoy doing. However, I've learned quite a bit around development. I have kind of this unique situation where I'm joining, you know, I've been developing applications really in this age of, or learning to develop applications in kind of this age of microservices. So I take a lot of this for granted. But when we look at cloud distributed applications, you know, we're really looking at applications that really span, you know, a diverse technical stack or technical runtime. So instead of just having like one big piece of compiled code, we might have an application that's, you know, several containers and then several other cloud services. So they're not, you know, this single entity anymore. And that really, you know, really, it's great as we're developing these applications. I mean, it simplifies the development process. We can compartmentalize things, but it introduces some deployment and management challenges. I try to kind of just like break these down into 4 buckets here. We've got multiple deployment routines. So, you know, if I've got cloud services, I've got one routine to deploy my cloud services, and if I've got container images that I need to run and those work as a single application, I might have a second deployment routine for my container images. Secondly, I've got multiple management tools. You know, so once I've got my application up and running, I want to manage that application as a single instance, not as a grouping of cloud services and a grouping of containers. And then these last 2 is where I think things get really interesting. I've got secrets management. So if I stand up some cloud services and then I stand up some containers that need to consume those cloud services, I need to make sure that I've got connection strings and I'm sharing the secrets appropriately between those 2. And then finally, I've got instance management. I think I'm just going to bring up this diagram and talk about instance management and dig into some of these a little bit deeper. So this is kind of the example application that we're going to see in this session. I'm actually going to deploy this application a couple times. What we've got here is on this side, my right-hand side, is a Kubernetes cluster with 3 containers running in that cluster. And the other side, I've got just a cloud provider. In the case of this talk, it's Azure, and 3 cloud services. So I've got a message queue, analytics API, so cognitive services, and then a data store. And it's a pretty simple canonical example of an application. First container pulls tweets off of the Twitter streaming API and stores the body of those tweets in a message queue. I've then got a second container that's pulling those tweets off the message queue, sending the body against a text analytics streaming API just to determine like, hey, was the sentiment behind this tweet positive or negative or neutral? It then stores the results in a database, Azure Cosmos database in this case. And then I've got another container that's just a simple little Flask app to visualize the results. So one application, 3 containers, 3 cloud services, potentially some of these containers, particularly this process tweet piece, I can horizontally scale that out. And kind of going back to the problem statement, I really want to deploy this as a single unit. I don't want to have to like do this, individually. And then really I want to dig into like the instance management piece a little bit, because I'm going to talk about that quite a bit throughout the session. What I mean by instance management is like if I only have one of these, life's probably pretty all right. In fact, I can probably just use my, my CI/CD system to, build and then manage the deployment of this application. And then if I update the application, that just goes through my build and deployment pipelines. If I've just got one of these, this talk probably isn't much use for us. Where things get interesting is, let's say I've got 1,000 of these. Like maybe this is a service that I sell, and consumers just they don't know what they're doing. They just sign up for my service. They're like, okay, I want to get some text sentiment analysis on this. Hit go on their phone, and then in the background I spin up one of these applications. So now I've got thousands of these things. Secrets management. How do I make sure that I've got the secrets and the connection strings properly positioned between the cloud service pieces and the container pieces? And then what happens when I need to delete one of those? So I've got 1,000 of these. I need to delete one of them. I need to make sure that when I delete one that I get the right database, right? Because these things aren't like logically all bucketed together. They're, the cloud pieces are spread across my cloud. The container pieces are spread across one or more Kubernetes clusters. So if I go and delete this, how do I ensure that I'm deleting the right containers, the right cloud services, and then the right secrets? Because I don't want those things hanging around either. So that's kind of like the problem statement. Like, how do we deploy these applications as a single unit, manage secrets, manage instances, etc. And we're going to kind of get into options for that. Before we dig into that, let's just really quickly, level set on Kubernetes. So Kubernetes is a platform for running applications. In fact, there were so many hands in the room. I'm just going to blaze through this one. One of the things I want to point out is that Kubernetes does have this extensible API that allows for really cool kind of cloud native integrations. And that's what we're going to see here with Service Catalog, is really kind of an extension of what Kubernetes does out of the box. I'd like to think of Kubernetes as a runtime for building and managing applications, not just containers in this case. And that's exactly what we're going to see. We're going to see managing these cloud services as almost native objects inside of Kubernetes. So that's really cool. That sounds great. But how can Kubernetes integrate with my cloud provider? Like, how can I deploy a database from Kubernetes as if a cloud service database, as if it's a Kubernetes object? Before we get into Service Catalog itself, though, I want to talk about Open Service Broker. Open Service Broker is really an API specification for a standard cloud provider interface. So what this means is I've got Azure, I've got AWS. The concept behind an Open Service Broker is like, let's create this API that can sit in front of that cloud so that I can provision resources in that cloud through that API. And that thing is standardized. Now that I've got that standardized API, I can have multiple different systems talk to it, whether that's Kubernetes or something that you've built in-house. So Open Service Broker, just an API specification for interfacing with a cloud. And this is important. I just wanted to get this out front, and we'll talk about how it lines up. The next piece is Kubernetes Service Catalog. Kubernetes Service Catalog is really an extension of Kubernetes that allows us to provision cloud services directly from Kubernetes. And how this works is that Service Catalog talks to that Open Service Broker API. That Open Service Broker API is what understands how to create a database in Azure or AWS. And I've got a diagram that's going to tie this all together in the very next slide. So what Service Catalog does is it extends Kubernetes to basically natively talk to an Open Service Broker. whether that open service broker is AWS or Azure or something you've built yourself. So Kubernetes Service Catalog is something that we install in Kubernetes. It's built on what's called a aggregated API extension, which basically mimics the Kubernetes API. It looks like it's just a piece of the Kubernetes API, but we're adding it on top. And you can install it just using Helm. When we add Service Catalog, we're basically adding 5 new types to Kubernetes. So if we think about like things like a pod, deployment, service, these are all types or object types that we can work with inside of Kubernetes. So things like kubectl get pod. Enabling Service Catalog adds 5 new types: cluster service broker, service class, service plan, service instance, and service binding. And these types, we can interact with them just like a pod. So I can do kubectl get service binding. And we're going to dig into what all 5 types and what they are and what they do. So I just talked a bunch. I just threw out all kinds of stuff. Let's just take a look at a diagram here. So we've got Kubernetes. We've enabled Service Catalog. So Kubernetes itself now knows how to talk or to interact with an open service broker. In the middle here, we can see I've got a service broker for Azure. And then I've got Azure on the other end. Cool thing here is like I can have multiple service brokers. Because Kubernetes now understands how to talk to service brokers, I can have multiples here. And then kind of like removing ourselves from the Kubernetes world just to kind of drive home the power of these open service brokers, I don't have to use Kubernetes to talk to these open service brokers. I could have something else, like Cloud Foundry or something that you build your own. And we're gonna talk about all the different objects that are added to Kubernetes, and then really look at like a diagram like of the API level diagram. So I talked about 5 different objects that are added to Kubernetes. I'm gonna go through these really quickly. The first one is the cluster service broker. And this is really just the registration. And we're going to look at all of these. We're going to jump into a Kubernetes cluster and look at all of this stuff. So the cluster service broker is really just we're registering that open service broker endpoint. So if I've, added open service broker for Azure, this shows up as an instance of the cluster service broker object. The classes and plans, so this is type 2 and 3. So what a class, this is basically our catalog of services that are available to us to provision from Kubernetes. So our service class is like an offering type. So that might be like MySQL database or storage account. The plan is then kind of like a subset of that. We can think of this as like pricing tiers or like enterprise, standard. And what we'll see is we're going to deploy things like, hey, I want to deploy this class and this plan. So I want to deploy a MySQL database of plan C3 or whatever that plan might be. So we got five objects. We've gone through 3 of them. The ones that we've talked about so far, you don't really interact with too much. It's the next 2 that are really important. The first one being the service instance. And this represents our intent to provision something in the cloud. I don't know, it might be really hard to see that YAML there. I might just jump over into a demo here and kind of go through that. But what we'll see is that when we are building Kubernetes manifest files, just like we would spec out a pod or a service, we can now spec out a service instance, and it's going to look very similar, and it can go straight in our Kubernetes manifest files to now provision something inside of that cloud provider. So if you really start to noodle through what we're doing here, and we'll see this in demonstration, is I can now write a Kubernetes manifest file that includes, a container or a pod, a service, and then a service instance. And that service instance is going to, be of a certain class and plan. So I can now provision cloud services directly within that manifest file. Again, sorry that YAML file that YAML is hard to see there. We'll jump into a demo and I'll zoom into it. So the service instance is the intent to provision something. And then finally, to bring this all home, the last object is a service binding. And this is where things get really, really super cool. So we've provisioned something, but we now need to get the connection strings and the secrets and anything that we need to interact with that something, we need to get that into Kubernetes so that our pods can consume that and then do stuff with it. And that's where the binding comes into place. So what a binding does is it basically gets those connection strings, secrets, whatever's been programmed on the open service broker side kind of as an output, it takes that and then stores that in a Kubernetes secret. So we've provisioned something, we've got the connection strings and the secrets for that something, we've stored them into a Kubernetes secret. The final piece is actually consuming that something. And again, I apologize for the resolution here. But so how do we, how do my pods inside of, I'm deploying this as a single manifest file. So how do my pods consume that cloud service? And basically just the same way you would reach into your Kubernetes cluster and get secrets out of it. So we just, inside of that pod spec, we set environment variables or, files to go and pull those connection strings from Kubernetes secrets. And then boom, we can access those services. So really, that was a really quick tour of the 5 objects. We'll look at them in practice. But what I wanted to do here is really tie it all together with kind of like an API level diagram. So this, it's kind of hard to see, but this dotted blue line represents my Kubernetes cluster. And then on the far side, I've got my cloud provider. Again, in this, the demonstrations, we're going to see Azure. So the first thing I'm going to do is install Service Catalog. And again, we can use Helm to do this. So there's a Helm chart to install Service Catalog. We can install it right on the Kubernetes cluster itself. And then we've got these 5 types that are added that we just went through. The next thing we need to do is install a service broker or multiple service brokers. This service broker contains that catalog that is the class and plans. So programmed inside of the service broker is like, hey, MySQL, Azure Cosmos DB, cognitive services. So we're basically providing that list of services or that catalog to the Kubernetes cluster. The next thing I can do is create a service instance. And again, that's my intent to provision something. And when I create that service instance, we will create something inside of that cloud provider. I just threw up a bunch of things just to kind of demonstrate. We've created a service instance. Now we have things inside of that cloud provider, but my applications still need to access them. So then we can create a service binding, which is going to grab the things I need to connect to those cloud services and store them in a Kubernetes secret. I can then start my pod, which is going to gather those secrets and now has access to interact with those cloud services. So if you go back to that diagram, the application that I had up front, we had 3 containers and 3 cloud services. So essentially using Service Catalog, I can create a single manifest file that includes all the specifications for my containers, the service instances, and the bindings for the 3 cloud services, and then just like single deployment, deploy that out there. And that's pretty cool. But where, in my opinion, it gets really, really, really cool is when you integrate that with Helm. Now I've got all these things bundled up into a single Helm chart. If you go back to my statement about having 1,000 instances of those, we've talked about provisioning stuff, but we haven't really talked about deprovisioning stuff. And Service Catalog handles that for you as well. So if I've got 1,000 instances of those things, I've got 1,000, Helm releases, I can just go delete one of those Helm releases, and that Helm release knows which containers are associated with it, which service instances are associated with it, and it's going to go and remove all that stuff for me. So pretty slick kind of way to manage these cloud distributed applications via a single solution, in this case being Helm as kind of that management layer. Before we go into the demonstration, I want to just call out a couple other little things. SVCat is a command line tool for managing Service Catalog objects. It's not a requirement. This kind of confused me when I first started playing around with Service Catalog. I was like, why do I need this additional tool? Like, I want to write manifest files. I want to write Helm charts. Is this thing required? And it's not required. It's just kind of more like a convenience mechanism for interacting with raw Service Catalog objects. And we'll see some reasons. We're going to use it throughout the demos, and we'll see where it comes in handy. But I did want to make a special call out that it's not a requirement. It's just a convenience tool. And then just a couple notes here based on my experiences. Service brokers may release on their own schedule. What I mean by this is that, and really my only experience is with the open service broker for Azure. I mean, we've got a ton of services inside of Azure. We release a service, somebody needs to go code that thing up in the open service broker themselves. And because of that, not all cloud services may be present, and I don't know a whole lot about the AWS or Google Service Broker. Cloud services take time to provision. I found this one kind of funny because, you know, over the last couple of years, I've been deploying containers, and it's like, whoa, you know, and you talk about containers, you're like, wow, they start so quick. It's just like instant on. Well, that's not, you know, that's not the same for Azure Cosmos DB, which we're going to provision today, which takes a couple minutes. So, you know, just a couple, you know, just something to chew on. I mean, we're deploying actual cloud services here. So, you know, some of those like instant on benefits, you know, we need to compensate for that. And then just, you know, just in general, there are some rough edges around some operations in Service Catalog. So that said, let's take a look at Service Catalog in depth. So I have got a couple different clusters here. My application, we're actually going to deploy that application, so the 3 containers and the 3 cloud services. It does take a couple minutes to provision, so I've already provisioned a copy. But what I want to do here is I'm just going to deploy this using a Helm chart. So I've got Helm installed, so I've built a Helm chart. I won't dig into it. It's pretty big and nasty, but I've got a Helm chart, and if we were to go look at it, we've got the containers, we've got the pods, we've got the service instances, we've got the service bindings. So everything in a single Helm chart to deploy that full application. Because the application pulls stuff off of the Twitter streaming API, I'm just going to pull any tweet that has the word cake in it. And notice here I've got this set resource group. If you've not used Azure, what a resource group is just kind of like a logical containment unit for Azure resources. This is important because we're going to see this thing kick off. So I've got a resource group name here of SVCat demo cake. So I'm just going to grab this, and now the screen resolution is going to make this a little hard to read, but we'll do what we can. Oh, let me see what cluster I'm on. Yeah, it's on the wrong cluster. Sorry about that. So if you've used Helm, you know that it spits out kind of what it's intending to do. So we can see typical stuff, a deployment. Down here we have some pods, but notice here we've got service binding and service instance. So here we can already see like, wow, we've got new objects inside of this Helm chart. And this is those 3 cloud services that are part of this application. So even before we do anything, if I come over here to my Azure portal, I'm going to go ahead and refresh this, and we can see right away, I already have a new resource group has been created. So SVCat demo cake. And if I drill into that, I've already got objects in here as well. So, I mean, that quick, like, think about what just happened there. We just deployed cloud services using a Helm chart. I mean, to me, that's incredible. That said, let's look at some of these objects and just kind of take a look around the infrastructural parts of Service Catalog. So I'm just going to do kubectl get pods, all namespaces. And this is really just, let me see if I can make this a little easier to read. I know that's a little hard. I'll go ahead and kind of walk through everything. So right here we can see the catalog. So again, the catalog was just installed as a Helm chart. There's a couple different pieces to it. And then here I've got my open service broker installed. So everything's running right on top of my Kubernetes cluster. I talked about the extension to Kubernetes. If we run kubectl get API service, you can see in here that we've got v1 beta 1 service catalog. So until we ran that Helm chart, until we installed service catalog, these API objects did not exist. That first object I talked about was the cluster service broker. If I run this, we can see OSBA. I've got the open service broker for Azure. I can, do typical Kubernetes operations. So kubectl describe cluster service broker OSBA. We can see some stuff in here like successfully fetched catalog entries from broker. So again, just giving kind of like the tour of service catalog. Let's dig in a little bit more. So recall cluster service classes was the first part of that catalog of services that I can provision in my cloud provider. So if I run kubectl get cluster service classes, we can see this is that catalog. Like this, I'm running the Open Service Broker for Azure. So what services are available for me to provision from this Kubernetes cluster? And I can just kind of go shopping. We can see Redis Cache, Cosmos DB SQL, Azure Text Analytics. So I talked about, not every service might be available inside of your service broker. This is one right here that I needed for my application that doesn't exist, so I had to go code that up myself. It's very easy to do. I mean, almost like boilerplate code, just copy and paste it and fixed up a couple other things. But so we can see that we've got this catalog. So from within my Kubernetes cluster, I'm able to see what type of cloud services I can provision. Service plans was kind of like going a little bit deeper on those, and this is the, the tier, pricing tier, or however the cloud provider has their services segregated. Now notice here that this thing is a little bit more difficult to read. I see this external name, memory optimized, but that really means, the rest of this means nothing to me. And this is where that SVCat tool comes in I talked about, and also kind of some of the rough edges around some of the rough edges. In fact, it's pretty funny. I was just preparing for this talk a couple days ago, and I'm going to rerun this command, kubectl get cluster service classes. Like this column right here, this external column name is new. This was just added recently. I don't know if you were involved or anything, but up until just recently, you just had these GUIDs, and this SVCat command line tool is almost necessary if you wanted to browse this stuff. So kind of going back to the plans, this doesn't mean a whole lot to me, but I can run this command, svcat get plans, and svcat is just, again, the service catalog command line tool, and I can get stuff that means a lot more to me. So I can actually now see a couple different columns, and the first one being, let me get to the top here, the class, and I'm sorry, this is hard to read. I'm getting quite a bit of wrapping here. But with svcat get plans, I can see both the class and the plan name. So Redis Cache Tier 1. All right, so let's dig in a little bit further. So that was kind of like the stuff that you don't interact with all the time. Now let's run this command, kubectl get service instances. Now recall, I just triggered a Helm chart to create 3 of these. So let's see what happens here. And man, that is hard to see. But we can see I've got 3 of these. Actually, let me do this. Let me use svcat to see if it displays a little bit better. All right, so we can see the 3 service instances that I had defined in my Helm chart. I can see that 2 are ready and that 1 is provisioning. So we're still in the process of provisioning this application. And that's the Azure Cosmos DB one. It does take a couple minutes to create. Now recall that I also had some service bindings, and that's where I get those secrets from those things and store them in Kubernetes. So watch what happens here. If I do svcat get bindings, we can see that I've got a couple ready, but I've got one here that's got a status of error instance not ready, basically because that instance, the service itself is still being provisioned. So once that service is fully provisioned, we'll then populate the binding, which then creates the Kubernetes secret, which we can also look at. So I'll do kubectl. So I'll do kget secret, and we can see that I've got 2 here already populated, and it's that 3rd one that I'm waiting on. And then finally, if I do kubectl get pod, I can see that I've got some pods that are also waiting to spin up, and they're basically waiting on those secrets to provision. So went through a whole lot of things, but we've got a Helm chart, deployed 3 Azure services and 3 containers. It then is in the process of bringing in the secrets of all of those Azure services and storing them inside of my Kubernetes cluster. Once everything is done, my pods will start up and my application will be accessible. So let me jump over to another cluster real quick just to take a look at that. So if I do svcat get instances, we can see that my 3 instances are ready. I actually did this in the hall before I came over here. Bindings. We can see that my 3 bindings were created. kubectl get secrets. There's my 3 secrets. And notice they all kind of have a common name because I sent this through a Helm chart. I configured that Helm chart to kind of like package everything together. And then finally, if I get the service address, I can pop out here and visit the application, and there's my application. And again, I did this with a single Helm chart. It deployed all the Azure services, all the Kubernetes stuff, and tied them all up together. And then finally, going back to that instance management stuff that I brought up, if I do Helm list, there's my Helm chart. This is the one that I accidentally ran on this cluster. That's okay. But it's this modeled Gorilla one. So if I wanted to delete all of that stuff, all of the cloud services, all of the containers, all of the secrets, I can now just delete the Helm chart or the Helm release, and that's going to go and deprovision all that stuff. So how am I doing on time? Pretty good. So that was a real quick tour of Service Catalog. I gave this talk recently, or a similar talk, and I got a little bit of pushback from somebody in the audience, and I thought it was relevant pushback. And it's like, well, hey, what about alternatives here? And I've also run up against some challenges with Service Catalog in terms of the flexibility that it gave me to do more complex things. I also had, there's a bar that I hit when I hit a service that wasn't available in the service broker that I wanted to use, so I had to go code my own thing for it. So I just began exploring alternatives to Service Catalog itself. And I just wanted to talk about a couple of those, and then if we have time, give a quick demonstration. Now this is not a comprehensive list. Basically when I started coming up with like, hey, what alternatives do I want to talk about? I just wanted to choose a couple that kind of like cover the whole spectrum. And the first one I want to talk about is Terraform. And this is the one that I got pushback. It's like, well, hey, why wouldn't I use Terraform for that? And you absolutely could. Has anybody used Terraform? A couple hands. So just a quick overview on what Terraform is I tend to think of Terraform as kind of like a infrastructure as code solution, a solution for deploying infrastructure in a declarative way. So Terraform configurations are written in what's called a HashiCorp configuration language. It's basically like an abstraction on top of JSON, a little bit more easy for a human to write. But one of the things that's unique about Terraform is it has this concept of providers, and the provider kind of brings the juice to Terraform. So there's a provider for Azure that allows me to deploy infrastructure, but there's also a provider for Kubernetes that allows me to deploy pods and services and stuff inside of Kubernetes. So using Terraform and a couple of the different providers, I could essentially achieve the same goal, meaning deploy my Azure services, deploy my Kubernetes services, and then using something that's called string interpolation, make those connections between the connection strings and the secrets. So that's pretty cool. So the authoring experience, you need to understand HCL, but it's not that bad. But then, kind of looking at some of the other things here, instance management with Terraform, so talking about instance management, we just took a Helm chart or Helm release, deleted it, and we deleted one instance of that application. We can kind of do the same thing with Terraform. What happens when you run a Terraform configuration is that a state file is created, and then you can run Terraform destroy to remove that stuff. But it's a little bit more heavyweight than just Helm delete. You need to track the state files. You potentially need to build your own solution to manage like a big, if you've got 1,000 instances of those applications, you potentially need a solution to manage 1,000 state files. And so there's a little bit of a bump in kind of complexity around instance management. In terms of flexibility, Terraform providers are written in Go. I found the Terraform provider for Azure, which is what I know, much more complete than the open service broker for Azure. So I already had access to more properties and resources using Terraform. However, I still hit a wall. I still hit configurations and deployments that I wanted to do using Terraform that I then had to go and contribute the code to the provider myself. So I found that in this particular case, it was a little bit more flexible than the open service broker for Azure. However, there wasn't full flexibility. I still ran into some stuff. But then the other thing that I wanted to think about, like when I'm choosing a solution for cloud distributed deployments like this, I also want to think about maturity. And without doubt, Terraform really showed there. I mean, it's a huge, mature product with lots of contributors, lots of users. So just wanted to call that out. I'm not going to demonstrate Terraform though. And then on the other spectrum, I wanted to talk about another alternative, something called Cloud Native Application Bundles, or CNAB. Is anybody familiar with CNAB? So one hand. And we'll see here, like a couple hands. We'll see here that like one of the, I don't want to call it a ding, but one of the things that I'm going to call out here is the maturity level is just not there because it's almost like a brand new experiment. So what Cloud Native Application Bundles are is really a package format specification to describe and bundle together all the components of a cloud distributed application. So that sounds like exactly where we want to be. So it's a specification on how to package and deploy applications. There's a couple different pieces included in a Cloud Native Application Bundle. And this is the first time I've talked about CNAB, so I'm still working on some of the verbiage here, so just bear with me. But inside of a CNAB bundle, we've got a bundle.json file, which is basically just the metadata, and we're going to take a look at one of these. We then have a bundle runtime, and this is the piece that we actually run, the entry point to our deployment. And what's neat about CNAB and the tooling around it is that we've got absolute flexibility. Like this runtime can be anything. And we're going to see what I have as just a bash script, but it can be Terraform itself. And then we have an invocation image, which is really just a container image that fires up and executes my runtime to deploy and manage my applications. But I don't want to spend too much on CNAB because it's just a specification. We now have an ecosystem of tooling being built to work with Cloud Native Application Bundles. And the one that I'm going to talk about here is called Duffel. And Duffel is just a command line tool for installing, uninstalling, and managing Cloud Native Application Bundles. And I'm going to give a demonstration of that here in just a moment. So when comparing Duffel to Terraform and Service Catalog, I kind of came up with the following things. The authoring here, so if we kind of backtrack to Service Catalog, I can just hand to my developers like, hey, we've ramped up on what a Kubernetes manifest file looks like. If you want to deploy Redis instance, you really just need a chunk of YAML that looks like this. We really, that is super simple. Like authoring manifest files that integrate with Service Catalog, I mean, there's not much to it. The spec is what the spec is. On the other hand, though, like authoring Duffel or a CNAB spec, because we can use any tool, bash scripts, Terraform, I mean, the authoring, it requires domain knowledge. Like we'll see here, I'll show you one. Like I had to write a big bash script. I had to know how to do that. So the authoring, authoring can be complex. Instance management, on the other hand, though, if we look at Service Catalog, we were using Helm. Duffel offers like almost an identical experience, so it's pretty dang cool. But where, in my opinion, Duffel and CNAB really shines is its flexibility. Because I can have anything power this thing, I'm not going to hit a point where, hey, Open Service Broker doesn't support this, or Terraform doesn't support this. Like there's at no point using Duffel or CNAB am I going to hit a wall where man, I just can't do what I want to do. So it offers super duper flexibility. However, it's brand new, it's not mature. But rather than talk about it anymore, let's take a look at it because I think I can do a better job kind of showing it off in demonstration. Just bear with me. I'm going to open up a new code editor here and also switch to a new cluster. All right, so what I have here is a CNAB bundle. Inside of the JSON file, you can see that I basically given it a name, a version, a description, defined what the invocation image, the name and registry. So this is basically just a Docker image. I've also specified some parameters. So these are the things that I need to go into, the things that are going to control how my application is deployed. So that's the JSON file. I then have a Docker file that makes up the invocation image In this case, I'm installing kubectl on the Docker image. I'm installing the Azure CLI. I then have the runtime. And I really want to like kind of drill in on a couple of things here. You know, one of the biggest things that we're bringing, Duffel is bringing, is kind of like a common set of commands. So Duffel install, Duffel uninstall, Duffel upgrade, and Duffel status. So what we're going to see here is that I now have a command line tool where I can say like Duffel install this bundle, and it's going to go and create an installation of that bundle based on the bash script that I have in here. And so you can see here like the complexity here, like I had to write all this stuff out. In fact, I didn't even get to the point where I've built the upgrade step yet. I just have the installation and uninstallation. So let's take a look here. So I can do Duffel bundle list. Oop. Duffel bundle list, and I've got one bundle here. Now you might ask yourself, how did you get that bundle? I'm not going to run it here because it takes a couple minutes, but I can do Duffel build, and it's going to take this JSON file, this Docker image, and it's going to basically package up my application into a bundle. And some topics that I'm not going to hit on in this talk is that a Duffel bundle is also something like you not only have like the scripts to deploy it, but we can also bundle up the container images that make up the containers, and you can actually like put this bundle like on a USB drive and move it to another computer and install that bundle. Or eventually, I don't think the plumbing's been fully baked out yet, push these bundles to registries and do something like Duffel install my app. It will then pull down the full bundle, so the instructions to deploy it, the container images, and all the metadata, and deploy that as well. I already ran Duffel bundle or Duffel build, so I've got my bundle there. If I do Duffel list, I've got nothing installed. So let me go ahead and create my first one. So I'm going to do Duffel install -- credentials. So we've got credentials stored locally. I'm giving the Duffel release a name, Duffel Cake, and then the name of the bundle that I want to deploy. And so it's actually running everything in this script here. So it's going to, in this case, the same thing the service catalog did. It's going to deploy the service instance or the services to Azure. It's going to grab the configuration strings or the connection strings, the passwords, store them in Kubernetes just using kubectl commands because I built that all into the script. It's then going to start the container images on the Kubernetes cluster that will then consume those secrets and then be able to talk back to the container instances. Now, in this case, I am not creating the Cosmos DB. I built it so that it uses a pre-existing Cosmos DB to save some time. But if we come in here, so there's the resource group was created. My 2 resources were created. We can see that everything has been deployed. I actually stuffed everything in a namespace here, and we can see that my 3 containers are running. Now, it's like, okay, so what? You just wrote a script to do that. But here's where, in my opinion, things get pretty cool. Now, if I do Duffel list, we can see that I have my 1 instance here. Now let me go ahead and deploy another one. And this one, I'm setting some parameters on it. Give that a second. Actually, let me see if I can pull a list while it's still running. Yeah, I can't. So we'll give that a second to run. But what we'll see is once that's run, I can run a Duffel list and now see my 2 instances. I can then do Duffel uninstall and specify one of those instances, and it's going to do the same thing that the Helm uninstall did in the case of Service Catalog. It's going to go and delete those cloud services. It's going to delete the secrets. It's going to delete the container images. And again, this was all up to me to code up inside of this uninstallation piece. So really, all I'm doing is deleting the Azure resource group and then deleting the namespace that everything is stored in. So we can see this here. So Duffel duffel list, and there's my 2 instances. And then I'll do duffel uninstall, and we'll just do duffel cake. Oh yeah, I need to add credentials. And it's gone through the reverse. So that was my talk. We've got a couple minutes. I didn't hear a cannon go off, so we might be able to still catch this guy getting shot out of a cannon. I appreciate you coming out. I do have time. I've got nowhere to be. If you want to talk deployment, talk service catalog, talk CNAB, I appreciate it. I know it was late, so really appreciate you coming out. Thanks a lot. Awesome. Thank you. Yep. Oh, appreciate it. Thank you so much.
Test 1 2. Hey hey. 1 2 1 2. Test test. 1 2 1 2. Testing. All right. Now I'm going to talk in the microphone like I don't know what I'm doing. Test test. 1 2. Hey hey. 1 2 1 2. All right. So we're getting pretty solid sound from the handheld microphone in Ballroom B as in boy. Test test. 1 2. All right. Now I'm going to test the lavalier. I'm live. I should be getting signal to the lavalier microphone. Test, test. 1 2. Testing, testing. 1 2 1 2. Whoa. Yeah, we got a little jumped up on us there a little bit. Test, test. 1 2 1 2. I'm not worried about it because I trust you. You know what you're doing, and so yeah, it sounds so. Yeah, just mess with that as much as you feel you need to. Sounds good from the front. Sounds good from the back. All right. So as long as they wear the microphone appropriately, we should be good to go there. So what I am going to do now, actually, I'm going to test the DI. That's the last thing we need to test on our end. And let me play some music. Oh, I'm at max volume. All right, I paused it, so that's good there. Okay.
I don't think we get a mic. Oh, no, we do get a mic. Good.
Yeah. Hello, 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 hello.
Hello. Hello, good evening, everybody. I like the people who are sitting in the front, people who are sitting in the back corner. Hello, Eastern Siberia. Welcome, everybody, to the Hackaday and Tindy Bring a Hack Birds of Feather meetup here at SCaLE 17. I'm Roger. I'm a contributing writer for Hackaday.com. We have Emily, who's a writer for Tindy.com. And we have Selena here representing SupplyFrame. And this whole thing is under the umbrella company, SupplyFrame, which usually deals with major electronic manufacturers, but also owns properties like Hackaday and Tindy, because the ownership of SupplyFrame knows that we have the big companies, and we have the little companies, and we have the entrepreneurs and the tinkers. So we're here underneath that umbrella, and so I see people here I'm familiar with from Hackaday LA. Please bear with me for a few minutes while I give all our new friends here a little rundown of what's going on with these organizations. And after we do the overview, we have any questions, we'll answer those. And then we will start going to look at people's projects, and we'll lead off with some that we brought up our own. And I know some people in the audience have brought theirs too. Everybody gets 2 minutes or less. If you want to use just 5 seconds, that's cool too. And after everybody gets a little chance to show and tell to the crowd, and everybody just get up and chat and mingle. We will not take the full hour. I'm hoping 10, 15 minutes is all our intro is going to take at max. So, Hackaday.com. It's a website where it's a curated tech blog of interesting news for tinkerers, makers, and I'm a contributing writer. We have a staff of writers that write stories that we find around the world and share them with that kind of audience that love these kind of projects. And we hope that these stories will inspire people to take on projects of their own. And for that, we have a separate website, hackaday.io, which is our community content site. Anybody can create an account and then have projects where you can have pages where the home page is for your own project. So if you don't want to set up your own website, property, blog, or whatever, you come to Hackaday.io. We already have the infrastructure all set for you. It's kind of like an open source of your project, your creativity, your design process. And I have my own projects on Hackaday.io. All the CAD data is on there. All the source code's on there. So one way to think of it is like GitHub, but for hardware projects. Now, that's all online, and that's great, but at some point, these hardware pieces need to become physical pieces, and how do you transfer them around? And that's what we have, Tindy.
Thank you, Roger. So as Roger mentioned, Tindy is kind of a marketplace, but it's not a marketplace like Banggood or AliExpress. The difference with Tindy is that it's more of a good analogy is that it's like Etsy, but for electronics. So what you're going to see on there is not a lot of like high volume, low cost things. There's a lot of small run things, in many cases developed by people that have had projects on Hackaday.io. And these are more like boutique items. A lot of people, these are like people's passion projects that they've decided to turn into something that they want to share with other people. I've bought a few items off of there, and it's a really great place to waste some money, so check it out. There's just such a cool variety of things, and if any of you have projects that you want to bring to marketplace, it's a really good platform for that as well.
So we have places for people to have their projects, create them, and anybody who's done any tinkering personal project, a problem is staying focused and getting a deadline to actually finish these projects. Hackaday is happy to help you. We run contests, give a deadline with money at the end to motivate people to actually finish. So Selena will tell you more about the project, the contest we run.
Hi there. Yeah, so another way that you can participate community-wise with Hackaday, aside from coming to meetups like this, is our contests. So recently we had one that was artistic sculptures that were functional circuits. We had a 3D printed mechanisms contest. Currently, we're running a contest for flexible PCBs. So this one's actually, I'm super excited about because 60 entrants for this contest will actually win a code to get 3 copies of their board manufactured by Oshpark. So if only 60 people enter, you each get a board. So pretty good incentive. But our bigger contest, some of you may be familiar with, is the Hackaday Prize. It's our yearly 9-month-long kind of contest for promoting hardware innovation. This year's a little different in terms of it's not specifically like challenge 1 about robots, challenge 2 about musical synths. It's more based around kind of taking an idea from idea to how you would manufacture it, mass produce it, and kind of take you along that route. But it's still based around creativity and hardware innovation, so it's going to be cool still. I think, yeah, that's about it for our contest.
Okay, and most of what we talked about just now is available to anybody in the world because it's all on the internet. But SupplyFrame is headquartered here in Pasadena, so there's local resources that our neighborhood has access to that you can't just get anywhere else. In Pasadena, we have a design lab, which is going to be part of the Hackaday prize process. It has fabrication equipment to help people take their ideas to reality. So that's another incentive to get into the Hackaday prize. And the other part that I love the best is our super conference in November. It's also here in Pasadena, and that's usually where they announce the winners for the Hackaday prize. So that's where people gather and celebrate all these hardware projects that people have done. I think it's the greatest hardware conference, and it's right here in my own backyard. I've been going for several years now, and I've enjoyed every single one of it. So, anything else we want to cover? Okay, all right, so that's our usual overview corporeal spiel. Does anybody have questions on that? All right. Yes, Liam, you have a question.
So my question is, I often get asked, who is SupplyFrame? And I feel as if every time I try to answer that, like in an elevator pitch on your behalf, I'm missing out really what you do. And so I'm just curious if I know this sort of sounds like I'm a plant now. I'm asking you to give more info about SupplyFrame, but that's what I want.
So yes, that is a tricky question, and especially at the beginning of this year, they've been trying to figure out a concise way of saying that. Right now, we've kind of landed on SupplyFrame handles parts of the business from start to finish with hardware. So anything from at the end, we have websites where people can search for, or I'm sorry, at the beginning, where people can search for electronic parts, find chips. So all the way from, I guess before that you would have Hackaday, where you're ideating, step along, I know I'm going out of order. After you come up with the idea, you make a prototype, you go to Tindy, and you can start, selling more of a certain board that you created. And then farther along, what else do we have? Yeah, we have a whole sheet over here of, I think we have about like 10, we have about like 10 brands specifically over here, but they really encompass a lot, including advertising. So if you're a huge company like Mouser or DigiKey, they can actually work with SupplyFrame and will help them spread their brand name everywhere. So kind of along the whole process of start to finish. There is a little bit about that, but I don't actually know that much. Sorry about that.
Yeah, there are people who think big data because, SupplyFrame does try to say, all right, big electronic manufacturers, where can we take a big database and do something useful for them in a way that they're willing to pay money, which we like because then SupplyFrame has money to support Hackaday and Tindy. Any other? Okay, so given that overview, I'm curious what the audience generally is like. Who reads Hackaday.com? Oh, thank you. You help me pay my bills. Who has a profile on Hackaday.io with projects? I do. Awesome. Who has bought from Tindy? Okay, who is selling on Tindy? Liam, you're not selling on Tindy? You're not. Whoa. Okay, so that's an overview of your fellow audience, and if you have projects, we're going to ask you to present them in 2 minutes or less, and we'll open up with our own projects because we don't just speak for the company. We actually love this community ourselves. Should I just start? Yeah, that's that. So my big project over here is a motorized model of Mars rover Curiosity on Mars 2020. And it has an onboard Raspberry Pi where I can run it as a remote control car. And I have ambition to make this autonomous in the future. And that is what my Hackaday IO project page for SOPI, the rover, is I like, detail the problems I face. I don't know how to solve it. What do I learn? And it's all documented there. So if anybody else wants to make a autonomous model of a Mars rover, they can look at my page and say, oh, this is where Roger got stuck. And this is how he solved it. So now I don't have to be stuck. If you're into robotics, you would know about the robot operating system. It's open source infrastructure for robotics engineer and some industry to study robotics. And I was like, all right, if SOPI the rover is going to be autonomous, it's probably going to run ROS in some way. And so I have a ROS study learning educational robot. And it's a Phoebe. And this is also on Hackaday.io. I documented my goals for making Phoebe and my progress for making Phoebe. And as it gets to version 1.0, I'd say, here's what I've learned. And then here's where I would go if I want to go further. So anybody who was interested in robot operating system, my page could be one of their resources go to learn from my mistakes. Who wants to go?
Okay, so you probably noticed that Roger's into robots. I am into more of like audio-visual stuff. And both of these projects are on Hackaday.io. This one is an ongoing one. This is my Lisa Zhu machine. This is an evolution of what was it, like Roger, like 5 months of like tinkering around? Yeah. Like sometime back in the fall, Roger called me up and was like, hey, a friend's giving me a TV, help me take it apart. So we went over and we took it apart. And he got some cathode ray tubes out of it. It was a projector TV, so he got 3. And he said, I don't know what I'm gonna do with these, but probably I'm gonna save them so we can do something with them. A couple weeks later, I said, like, I think we can drive those. And we have a weekly like hacker meetup that we go to. And he brought his tubes. And we powered them up, and with some more tinkering, we started drawing shapes on them. And these shapes, these curving shapes, are called Lisa Zhu figures, and they're like they're a representation of some mathematical like interactions, if you want to call it, between like 2 sine waves. And I said, this is cool, but we're going to electrocute ourselves. I want to do better. I want to do something safer. And so I've been working on this thing since January, I think, and I'm almost there. The idea is you have a cathode array tube screen here, and then like by turning different dials and flipping knobs and things, like you can make a lot of different patterns. And yeah, Roger's got it up there. Almost done. It should be done this weekend. And this here is, Selena mentioned there was a contest, a Hackaday.io contest. This was back in January. It was the circuit sculpture contest, and this was my entry for the circuit sculpture contest. So there you go. That's the RGB Atari Punk console. At the moment, it is not RGB. It is only R. But that'll get fixed this weekend as well. So if you're familiar with an Atari Punk console, it just uses 255 timers to make some kind of awful sounds. But this one uses light to modulate the sound. And it was built using all this brass wire as like to replace like the traces of a PCB. And it's built out in 3 dimensions. This was fun. I won a prize through the Hackaday.io contest, and I used that to buy some stuff on Tindy. And those are my projects. Selena, you want to?
Okay, last one of us. So today is actually International Women's Day, so I thought I'd bring in some projects that, so I used to teach for Girls Who Code, and there's some soft circuit fashion tech projects that we had the girls doing, 12 to 18-year-olds. So they went from, these will be better if you want to come and look closer later, but these are just kind of, they went from creating within 2 weeks just a plain circuit with a power, negative, a battery there with LEDs, to creating some stuff with Arduino and actually programming sensors. And then afterwards, in the final week of the 2, they went on and created some sound reactive clothing and a glove that a pedestrian could wear to signal when they're crossing the street. So it's pretty incredible. I mean, you know, the components that we can use nowadays to teach, but also what young students can do. So let's see. Yeah, how many people brought a project today? Who wants to go first?
These are just by hand. Do you need AV? Do you need the projector or anything? No, okay.
Okay, so I brought this little Internet of Things clock. Basically, it's 3 bells that I took out of old telephones. And So I found a few that kind of were tuned reasonably. On the back is a ESP8266 node MCU thing. And it's pretty simple. It just goes, it gets NTP time and sets a time, and then, you know, on the hour, the quarter hour and stuff, it'll ring the bells. But the problem I ran into mostly is like, okay, so you can use Wi-Fi Manager to get, you know, to connect to Wi-Fi pretty easily. That works really well. But then once you connect to it, you need to find the IP address so you can get to this web server. And so I was looking at, MDNS, which works like sometimes and sometimes doesn't. I don't know, maybe it's my home network. I don't know what it is. Maybe if you wait long enough, I don't know what it was. Anyway, so in the end, what I did was I made a web page on a static IP that has some JavaScript that will just iterate through all the addresses in your subnet, and it'll go to port 80. No, and it works like in less than a second. It'll go to port 80, look for a string on that, and it works great. And then it just iterates all the. That was the fun part of this thing. So, yeah, I don't know if do we have Wi-Fi in here to be able to get outside?
Yes. Yes. You can. Yeah, there's conference Wi-Fi for okay. Okay. All right, then we can hear it sing. Dave, are you ready to go? I don't see a screen on yet. Okay, I'll move on to the next person. You also raise your hand, yes? All right, come on up. Let somebody else go. Who is ready to go and start yakking now? Anyone? Anyone? Liam? Oh, you're ready now. Short is good. Short and sweet, concise, we like.
So this was my KiCad learning project. It's just a simple LED board. It has 6 columns of 7 LEDs. And most of you are familiar with LEDs. They have a negative temperature coefficient, so you need to current limit them. So what I've done here is basically I have up to 6 integrated circuit-based current limiters. You can choose, I forget the part number, I think it's CL520 from Microchip. And you can get them in either 20 milliamp or 25 milliamp variants. And then down at the bottom, there are 3 discrete 2N3906 based transistor current limiters that you choose what you want your current to be with a current sensor resistor. And so basically what I have here is I could take any 3 millimeter or 5 millimeter through-hole LED of any forward voltage, populate them, strap them together, and then run it from any voltage, say from probably 6 volts up to 48 volts, and not burn out LEDs. And the reason I developed this was I'm interested in visual servoing of industrial robots. So this will be a way to produce some controlled lighting for that application. And I'm currently using it for another application, which is a Raspberry Pi-based security system that uses OpenCV to do motion detection. So that's it.
There's a vendor on the expo floor with a self-contained machine vision camera. Did you check them out? Yeah, that's. Yeah, so if you're curious, there's a vendor on the expo floor that has a completely self-contained unit to do OpenCV. I want to put that on SOPI. All right, so you're going to go without a projection, yeah? All right.
Okay, I had a problem when Broadcom bought Avago and they discontinued my favorite shaft angle encoder. So I looked around and I found the AS5047D at DigiKey and built it into a 3D printed case. And then I custom made a USB to SPI interface, which is actually 2 interfaces into one box. The first is USB to high current 5-volt TTL serial, and the second one takes that and is packet serial and does SPI to talk to the encoder. The encoder is 3 interfaces. It has the SPI, which you can get the 14-bit absolute value from, and it has also a AB, an index and quadrature, and a commutation UVW interface, and they're programmable via the SPI. The other parts of this project is generic hobby robotics thing, which I'm going to put on Tindy as soon as I get the software stable, is a makes a servo out of a brushed type electric motor and one of those, or any quadrature encoder. And the other board takes any RC servo and combines it with the the SPI version of that quadrature encoder and makes it a servo. So you modify the RC servo to do continuous rotation. In the case of the arm there, it's a 9-to-1 planetary and the other is a 74-to-1 planetary. And that lets it go round and round with super torque, and you know exactly where it is.
And Dave, you told me earlier, I forgot to mention, that you have ambitions to sell that on Tindy. All right, see, another Tindy candidate. Anyone else want to say something about a project that they brought? Shy? Okay.
Anyone got a project on their Hackaday IO page they want to show if you didn't bring one in?
Oh, hand raised. What's up?
I don't have any project, but I just wanted to compare experiences. I've used both. What's the other PCB service you mentioned earlier? Just the purple PCBs.
The purple PCB,
OshPark, yeah. I use OshPark and gel PCB for making stuff. I also have been using the, on occasion, Mixify the KiCad and also the Easy EDA website as well, which has a good integration with gel PCB. But what I was wondering is, does anyone have any opinion which one is better? I've used both, and I'm kind of not sure which service is better, whether to use OshPark or gel PCB. Okay, the OshPark one, you always end up having the PCB generally purple, and gel PCB tends to be green. But apart from that, what are people's experiences?
Okay, I only have personal experience with OshPark, and I love it. But if other people have circuit board fabrication experience, come, share a story. All right. You have a PCB fabrication? Okay.
Yeah, the LED board I did, I had it fabricated through dirty PCBs, which is like really, really cheap. And for my next project, I'm looking at panelizing on that little 10 centimeter square board, multiple designs to make things even cheaper. So we're talking about like $25 for 12 boards shipped from China. So it's amazing.
Okay, so it looks like that's about all the projects that we have here. So if you want to, we do have plenty of stickers up here. If you did present, we do also have a Tindy badge that you can solder yourself. Come up here and we'll hand you that. But other than that, if you want to mingle amongst each other, we're all Hackaday cool hardware people.
Yeah, find the project owners, ask about their projects. We love to talk about our projects. Coming up, stand up, mingle.